Welcome, everyone. We are here for the completely free Google Professional Cloud Architect Certification Training Program. We have 2 weeks of fun. I am joined here by Leopoldo Paredes. He's part of our team. He's got a master's degree, about 20 years experience in tech. And Leo made some fun labs for you along the way, so I'm happy he's going to be here. He's going to assist me along the way. I will cover the Google Professional Cloud Architect training, more of the certification materials, how the technology works, why it works, how the pieces and parts fit in, which is fun. And this time we decided for the engineers out there to actually do demos, and Leo's going to join me here. So thank you so much for that, Leo. I want to let you know about the format for the next couple of days. We've got a lot of fun. We've got a fun-filled educational packed 2 weeks. Today, we're going to go for about 4 hours. We're going to go between 3 and 4 hours every single day for the next 2 weeks, but we're going to kick it off today with a nice 4-hour start. There's a tentative description in the of a tentative schedule in the description. Today, we're going to cover some things related to the Google Cloud at a high level. Tomorrow, we'll cover IAM. We'll have a couple of days of networking and then some compute this week. And then next week, we have lots and lots of fun. So welcome, everyone. We're going to have a lot of fun. Before we begin, I want to tell you about a couple of free things that we have going on for you right now. The first thing that I want to tell you is that there is a study guide that goes along with this course. My team, literally speaking, went through the training materials that I created, and they created a study guide for you. It's a good 550 plus page study guide that's going to really help you easily pass the Google Professional Cloud Architect Certification exam along with our training. So I want to make sure you get it. It's completely free. Follow along with our training, and it's free. I also want to tell you that on Thursday, maybe you want to know how to become an actual cloud architect and work as a cloud architect. So on Thursday, we'll have a webinar where we cover what does a cloud architect do. We'll cover the cloud architect job. We'll cover the skills that you need and what it's going to take to be hired, which is different than it's going to take to be certified. So we have that, and it's going to be completely free. And of course, check out this schedule. It'll be in the description each day. We'll tune and modify as things going on, but we're going to have a lot of fun. Leo, do you want to say anything before we begin?
Well, thank you for the introduction, Mike. And it's a pleasure to be here, and it will be a lot of fun. Thank you.
It will be a lot of fun. So Leo's a great architect, but he also got pretty geeky on the tech because of his 2+ decades of engineering background. So we'll have some fun for you for the hands-on tech professionals, and obviously I'll do the architecture side. So we'll begin. Can you just do me a favor? It takes a lot of time, effort, and money to put one of these courses together. And I mean as much as a Mercedes would cost as a general rule. So if you can invite others for free, maybe make a quick post or a quick LinkedIn post or Twitter post or Facebook thing and just invite a friend or send a text message to a friend and invite them because we want to help as many people all over the world as we can. So if you like the content, please leave a like or subscribe. It'll signal the algorithm to share it to more people. Please share with your friends. And so I know that you are awake, alert, and oriented and ready to go. Give me a hashtag Google Professional Cloud Architect. When I see a bunch of them pouring in, I know that you are ready to start the course, and we will start. I'm going to let you know that I did pre-record some of this content, or a lot of the content, but I'm still going to be here to answer live questions. I did it because I was having some back issues, and I knew I had to get spinal surgery, which I did. So I wanted to make sure surgery, no surgery, we had a really good, fun-filled 2 weeks of training. So that's why I did it. So, Chris, let's start the content. Let's see those hashtags in that chat box, and let's begin with our Google Professional Cloud Architect Certification Bootcamp to prepare you for the Google Professional Cloud Architect Certification exam.
In this video, we're going to begin
and also
our
let me know where you're at in the chat.
On cloud computing and the Google Cloud. And in order to start this, I really want to talk about what is cloud computing. And there's a lot of definitions out there on cloud computing, and they're really hard to understand. So what I want to do is I want to take you through a journey. We're going to go look at what an organization's data center used to be like prior to moving to the cloud, and most organizations still have one of these data centers. Then we're going to look at what it takes to actually design a cloud provider of systems, and I've designed many clouds for the last few decades. And then we'll really break it down into what is it you're actually getting with regards to cloud computing. So the first thing that I want to do is walk you through an organization's data center. Here's what a high availability data center would look like. And if you understand the data center, you'll understand cloud computing. So in a data center, it is really a building. And the building is going to be where we house all of our technology resources for an organization. So what's involved in a normal data center? Well, we need a couple of things in these buildings. We're going to need to have power in the buildings. Now, whenever possible, we use two different power companies because if a power company has a failure, we would like a backup power company. So we typically use multiple power companies, and we typically use multiple transformers coming in the building to take the high voltage to the normal voltage used by our systems. We're also going to have networking connections that go out to the internet, which will be protected by firewalls and things. And these will typically connect us to multiple internet service providers. We can't have a single internet service provider. It's a single point of failure. So we'll have net routers and switches and networking connections going out to the internet. Now we will have other routers that are going to go to other locations that we own. Maybe we have a New York office, a San Francisco office. Maybe we have a private line or a link between them. So we're going to have our networking connections that go to our other sites. Now, if we have a power failure in a data center, we're going to have a problem. So we're typically going to have generators, more than one, sitting in our facility that can power our systems if and when the two power companies were to go out at the same time. And we typically have something called an uninterruptible power supply and a power conditioning system, which is going to smooth out and condition the power to make it good and clean. And then after that, provide battery backup. So power goes out, it takes 60 seconds for the generators to kick in, and the battery keeps it powered up. Servers don't reboot, don't crash, everything is up and running. Now, in our data centers, we're going to have the network, which is where our devices plug into. And in the network, for example, we'll have a whole lot of routers and switches, and they'll typically be running a routing protocol. And what will we plug into the network other than routers and switches? Servers. And the servers are going to be where all the compute is done, no matter what type of model we run. Whether we're doing serverless or platform as a service, they're all going to be running on servers. And we typically have storage area networks. Block storage, for example, will typically have file servers. We'll typically also have object storage environments in a data center. And basically, these are going to be systems that are packed full of hard drives in a RAID configuration and provide storage for our servers. Now, this is a traditional data center. Right now, it's a hardware-based data center. What have we done for the last few years in our data centers? Well, we put a control plane in this, and what the control plane does is as follows. The control plane, and this could be a VMware control plane. In today's world, it could be cloud software like Nutanix or OpenStack. Here's what the control plane does. The control plane will manage the resources in the entire system. So if I tell the control plane that I need 5 virtual machines, the control plane will look and see which servers have available capacity, and it will put those virtual machines. I tell the control plane to delete the virtual machines, they'll come off of these virtual machines. I might also have a control plane for my containerized environment, which might mean I've got some Kubernetes servers running here. Let's say a K8. We've got our control plane over there. And then, of course, what's going to happen? We're going to have our nodes that actually do the work. So we like the worker nodes. And where are those worker nodes going to be? And where's all this stuff going to run? All this stuff will still be running inside of the organization's servers. If we wanted to create a Lambda function in an organization's control plane, we've got function as a service as a general rule. We'd upload our code and it would be running on all these servers. So what are you noticing? This is the basic compute of the data center. Now, data centers look like I've described since 1999 when VMware invented the hypervisor. Okay, so now what is the Google Cloud? What is any cloud? Well, let's look at it. Now we have a public cloud provider. And what changed? Well, we have more routers and switches than before, because now we might need to have the equipment that for 1,000 customers. Now we need more servers because we have it, and we need more storage boxes and more storage area networks. What do we still need as a provider? We need the HVAC systems to cool it off, the air conditioning. We need the generators to back up the power. We need the uninterruptible power supplies to back up the power. We deal with multiple power companies. In some cases, the cloud providers have so much power utilization, they're using their own nuclear power plants, or they're looking into building them. We have a lot of networking connections. that go out to the internet as a cloud provider. We're probably connected to every major internet service provider in the world to provide optimal routing. Then we have connections going back to our other regions and other availability zones. That's our intranet connections. And of course, we've got power. Now, the difference is now the control plane is going to be a little different. So instead of the control plane being something that we own or rent or pay for, like Nutanix or OpenStack or Nutanix or OpenStack or VMware, now all of a sudden this is managed by the cloud provider. So now GPC, the Google Cloud has their own control plane. And when you run something like a Google function, the Google function gets scheduled from the control plane and it rolls on a bunch of servers. When you want to deal with a containerized environment, just like in our data center, we'll have the Kubernetes servers running, and the pods where the work is done is going to be done on a virtual machine going back to the server. Application virtualization, upload our code and it runs, again gets done on the server. So, is there any difference between the data centers we built for the last 30 years and the cloud provider's data center? No. The only thing different is the scale. So when we go to a data center, a cloud provider, what we're doing is we're outsourcing our data center services. Instead of building it ourselves, we're using pre-made services from another cloud provider. And ultimately what happens when we're in cloud computing is we end up getting a virtual private data center. And what's this going to look like? And I hope this makes what is cloud computing easy to understand, and then the rest of what we talk about makes more sense. So in this particular environment, what is it we're really dealing with in the cloud? Well, what we do in the cloud is we buy a virtual private data center, and it's typically called something called a VPC. And your VPC, realistically speaking, is going to be your virtual private cloud. Azure calls it a VNet. So whatever the cloud providers call it, but your VPC, VNet, is basically your virtual private data center. And what are you going to put in here? Well, you're going to keep your servers in here, same servers like you used to have. Now, servers, so you'll have a bunch of them. Now you're going to have a virtual router and all the routing, because nothing works without the networking. So you're going to have virtual networking. Instead of the cables, it'll be software based. We'll have our servers. We're going to have storage, which we're going to connect to, some kind of storage, which we're going to connect to. We're going to be running our applications. It's typically on virtual machines or containers or something like that. When we need to load share, we'll be using load balancers, but they'll be virtual load balancers. And we'll put our applications in our databases. So what are we putting in here? Our servers, our storage, our compute, our security, our everything. We're renting a data center when we go to the cloud provider. So we build it ourselves and own it with a private data center. With a public cloud provider, we're renting the space. Cloud computing is a landlord-tenant business. The cloud provider has to build the same thing you would, and then they rent it out to you. It's the equivalent of a hotel room versus a home. The data center is a home. You build it, you own it, you can control everything. And the cloud provider is like renting a room in a hotel. There's going to be 1,000 rooms in this hotel potentially. And each room is somewhat isolated from each other. At least it's logically isolated from each other. And it's your own private space. So now you know what is cloud computing. Now, when we talk about Google Cloud versus other clouds, they're going to be very similar. Because all cloud providers are doing is they're renting out of their data centers. Now, the good news is 98% of organizations are multi-cloud. And that's going to put them in a position where they're sharing the load across multiple clouds, which gives businesses the ability to pick the cloud provider that does certain things best, not have any single points of failure, and negotiate pricing with each other. For example, maybe the Google Cloud does something better on big data, and maybe the Nutanix Cloud is cheapest for high-performance compute, and maybe AWS has something big in one area that we want to use. Combine all three, and we get maximum benefits. So that's what we're going to talk about. So what is compute? Well, compute generally means processing power. It's the term that's going to do the actual work. So it could be a virtual machine and it's CPU power, DRAM power, and networking and storage. Or we could be using, in an AI environment, we might be doing our compute across graphics processors. And those graphic processors will also have a lot of memory and storage and things that are going to be necessary as part of what they do on their systems to integrate into the system. So compute is the work, the load. So no matter what, the compute is always done on a server. Yeah, our servers do the compute in cloud computing and data center work. Now, even when we talk about serverless, it's still being done on a server, but we'll talk more about that, about how that's hidden from you. So all work, all compute is going to be done on a server, and the server's processor determines what it can do. The type of processor, the speed of each core, the number of cores, the amount of DRAM, the networking speed that the system can handle, all of that is going to be compute. And compute is going to be the backbone of everything. It's going to be doing the analyzing the data, running the applications, performing the task. And in a data center, if we've got a private control plane, like that OpenStack or Nutanix we're talking about, we can create our virtual machines in any size we want. In the cloud provider, they're going to have pre-made virtual machines of various configurations that we can choose, for the most part, of CPU, DRAM type environments. And we're just going to pick the right kind of machine, for example, that would match the kind of machine that we would need in a data center, because all cloud computing is a virtual data center. So if we're going to size our virtual machines, we're going, in the cloud, we're going to do it exactly the way we did in the data center. If I've got a workload that needs to be on a virtual machine, and we can talk about what that is throughout the program, but if I've got a workload that should run on a virtual machine, and if it's running on 8 cores right now and 64 gigs of DRAM, then when we move it to the cloud, if it's an optimal performance, maybe we move it exactly the same. Or maybe when we move to the cloud, we don't need as much capacity. We can use less capacity and then add capacity as needed. But we're going to have to size our virtual machines based upon the capacity utilization and the correct strategy for us. In many cases, it's going to be cheaper to run off a few small servers than it might be one giant server. In other cases, it'll be cheaper to run 2 giant servers than 10 small servers. And you're going to have to analyze that, and that's how we're going to be making these determinations as well. Now, Google Cloud calls virtual machines compute engine. And a lot of these certifications are going to be vocabulary of what does Google call it. Google calls their virtual machines compute engine. Azure calls it an Azure virtual machine. Oracle calls it a virtual machine. AWS calls it Elastic Compute Cloud. So understand that your virtual machine is a virtual machine, but in Google it's called compute engine instance. And there will be predefined instances that you can select for it, which one is going to be right for you. Now, in the data center, we can create an image or a bit-by-bit copy of our virtual machines. And we can take that image and launch that virtual machine as another server at any one time. Guess what? In the cloud environment, Google and all cloud providers give us the ability to create an image or use a configured image. And we could take a virtual machine image from the data center, convert it to a Google machine, the Google virtual machine image, and run it directly in the Google Cloud. We can often go the exact opposite direction. Or with the Google Cloud, we can use a template to create a full configuration of a virtual machine, such as the operating system, the type of disk, any metadata that we need to do. And by doing so, we can make sure that our operating system and our images are consistent. It's going to be fast to deploy them. We can make sure that the security configurations of an operating system, the kinds of things that need to be locked down, for example, standard patch level can be done again and again and again in a repeatable manner. And imaging enables us to produce something once and then allow many other people to use it in the future. And of course, if we need an image, we could either convert one that we have from our data center, we can use one of these Google tools, or all the cloud providers have a marketplace that's going to give us pre-built images of specific applications. Maybe we want 2 next generation firewalls from, say, Cisco, and we can get them from a marketplace. Or maybe we want a various database server or a type of web server that we don't want to manually set up, and we can pay for a pre-made commercial solution. And we can use that commercial solution pretty much in all single clouds. Now, of course, we've got a lot of operating systems we can use. We can use things like Ubuntu or Debian or CentOS or even Windows servers. And we can create any kind of operating systems if we want, and we can have them tailored to our workloads, upload them, and then they can be used again, again, and again. And of course, those pre-configured images really make life a lot easier. Now, when a virtual machine comes up, we can automate it, and it's called bootstrapping. So we can use a very simple script as we launch the virtual machine to do it. So we could create a startup script. The system comes up. The system updates the operating system. Then the system may actually install the applications that are needed. Then it patches all the applications. And that happens in an automated manner when the system's coming up. We could come up with a little script for that. It's called bootstrapping, widely used in cloud computing, and really can help automating. You may hear things of a bootstrap script in AWS. Same thing we're talking about here. Okay, now let's talk about how we buy our virtual machines in the cloud. Now, we're going to be often calling virtual machines instances, and each instance is an additional virtual machine. But the term compute engine instance is Google's marketing term for a virtual machine. And there's going to be several ways we can choose what our type of instance is that we actually use. For example, we can use an on-demand instance, which basically is we access it when we want it. If we add capacity, we add it on demand. When we no longer need it, we shrink it down. So this is ultimate flexibility. And we pay for the resources that we use the time we're actually using them. So if I've got an unpredictable workload, and I have no idea that might need one server now and then 100 servers tomorrow and then 3 servers the next day, this is where we use our on-demand instances. And we do this because we know we have no idea what they're going to be. And a sales website could be an example of this. For example, we might need 10 servers normally for most of the time, and then periodically we need 100 during a big sale. So we could typically do this. We could typically commit to, which is what I'm going to talk to next, 10 servers, and then add on-demand additional capacity when we need it. So what is committed use? And all the cloud providers have this. Committed use is the cloud provider will give you a cheaper price if you agree to the following. Pay for it for, say, 3 years or an extended period of time. And by guaranteeing the cloud provider a certain amount of money you're going to spend, it makes budgeting and planning much easier on the cloud provider because they know where the revenue is coming from. Makes it easier for them to invest in new technology. So that puts them in a much better position. So you get a discount, potentially a relatively good discount, if you commit to spending a lot of money for a long period of time. Now, the next thing that we can talk about is something called a preemptible type instance. It's the equivalent of an AWS Spot instance. And the cloud providers have these big, giant data centers. These servers are up, they're running, and all kinds of stuff is going on at all times, right? So they have excess capacity. Now, all the cloud providers give the ability to bid on excess capacity in an auction-like manner and for excess capacity. And by doing so, you get some very cheap prices. But it comes at a price. So let's say we needed 500 servers for 30 hours. In a perfect world, if our workload is stateless and can be started and stopped at any time, what we can do is we can bid a low price for the number of servers that we need, and it can run, the workload can run on these preemptible virtual machines, and we will get up to 80% off. Here's the problem. Let's say we agree to pay $1 an hour for this virtual machine, for example, and somebody outbids us and pays $1.01. The Google Cloud provider can shut off or preempt our systems because we're no longer paying the most amount of money and go to somebody else. There's typically with the cloud provider an opportunity when this is happening. There's like 5 minutes notice. Your systems will be shut off in 5 minutes unless you want to pay more, which may not even be anybody be able to fix it in the meantime, but that's a preemptible machine. So to recover it on demand, when you don't know what your capacity is, you use this. Agility, which is a beautiful thing, but you're going to pay for the agility. Committed use, you're guaranteeing the cloud provider a certain amount of money you're going to spend, and they give you a discount. And for workloads that you need cost sensitivity or things that can actually happen as batch jobs for workloads that can allow starts and stops, the preemptible instances can really help you save some costs. And optimal cost management is going to be using the right ones for the right places. Now, let's talk about IP addressing. So any system that's on a network, if it's going to have to talk to somebody else, is going to have a unique IP address. And when we deal with virtual machines, we'll have the opportunities to use private addresses and public addresses. Now, inside of your data center, inside of your organization, you're always going to use private addresses if you're using IPv4. And we don't have enough public IP addresses. So typically you'll see organizations, they use private IP addressing internally. And you may often hear of the IP private addressing space. And IP addresses were actually spelled out by the Internet Engineering Task Force in RFC 1925. And I'll show you what the range actually is. So we have the 10.0.0.0/8 address space, and this is typically used private internally. We also have the 172.16.0.0 all the way to 172.31.0.0. And this is going to be, they're all going to be these /16s. And we have the 192.168.0.0/16. 16. These are addresses that we use internally. Now, if we need to connect a system to the outside world, for example, a web server, the web server needs to either have a public IP address, or if it's behind a load balancer, the load balancer can have the public IP address and load balance between the servers that are behind it, often in a private subnet in cloud computing. But that we can do. Private subnets are inside and not reachable from the internet. Public subnets are to be used for things that you want reachable to the internet. And of course, all the routing and everything else needs to be taken place. Internal IPs used internally, private. External IPs to communicate with the outside world over the public internet, not a private infra, and not a private system.
All right. Well, welcome back, everyone. We are here. Want to see if any questions have come up along the way, anything that we need to clarify, make sure everybody's learning something and having a good time. So we're back here for that. So we'll see if there's any questions from my team. As a reminder, if you just joined us, we have a completely free study guide that's going to go along with this. What you need to do is sign up. The link is in the description, but it's also have Chris from my team drop it in the chat box. All you need to do is sign up for it. Now, it may take 10 to 15 minutes to get it. Because we get such a large number of requests, we can't have our email server send like thousands of emails at the same time. We have to stagger them over a few minutes. So please do get your copy of that completely free study guide. We want you to have a great time with this completely free Google Professional Cloud Architect Certification Bootcamp. Are there any questions that are here? And while I wait for your questions, I'd like to ask everyone, if you're having a good time and learning something, please give the video a like, subscribe to our channel, and hit the bell to be notified of new videos for your architecture career. And I also want to verbally clarify, when I referred to the private IP address space of the 10.0.0.8, the 192.16.0.0/12, as well as the 192.168.0.0/16. That's actually RFC 1918. And I put it in the chat box as I did that. I must have been thinking of RFC 1925 for another reason as I was describing that, but it is definitely RFC 1918 that specifies private address space. Chris, did you see any questions come in? Is everybody awake? Because there's no questions. Hopefully everybody enjoyed the what is cloud computing and how does cloud computing work. So Team Escalate has a question on what is bootstrapping. So what a great question. So Team Escalate, let's say we have a base Linux image that we have as a virtual machine in the cloud. It's either a standard Red Hat Linux image or a standard Windows image or a standard everything. Now, when that image comes up, it's not really ready for business use. Maybe that image needs to update the operating system. Maybe it needs to actually install some software. Now, I'm not Mr. Linux. I haven't touched the Linux system in a long time because it's not really something architects do. But I do remember building some stuff for fun in my house that did use Linux. So let's say I had an Ubuntu Linux system and we were using it in any cloud provider. As soon as that boots, we could have it do like a sudo apt-get update, where it would update the packages And then after we did that, we could do like a sudo apt install HTTPD or Apache or whatever the web server could kind of be. And then we could do a minimal configuration. Very similar to a bash shell script on server boot up and the data center that we could do. And that's really what it is. So it's basically taking a virtual machine and pre-configuring it for use in your VPC. Hope that helps. If you want me to explain deeper in a different way, let me know, and I'm happy to do so. So, great question, Matthew. The difference between an ephemeral IP and a static IP. And we'll cover this much more later. But, here's the thing. Something that's ephemeral changes. It can change over time. Now, if I had a user and they were sitting behind a firewall and with a private IP address, and I needed to temporarily use any kind of IP address I wanted to for them to connect to the outside world, that's fine. Because if it changes tomorrow, it doesn't matter. But what if I have a server that needs to be reached all the time at the same IP address? Well, that's where we're going to use a static IP address. And, we could use that in our data center. It could be a private server on the internet, or it could be a public server on the internet. But the point is we've got a static IP address. And, we could have 5 websites with internal 5 web servers with static IP addresses internally, which would be sitting behind a load balancer that would be natting them to a single public address and load sharing across them externally. We could do that. But the point is something that's ephemeral is always dynamic. It may be there, it may not be there. Anything that's static is manually needs to be there. And anything really important, for the most part, needs to be static. Good question. Any others? Okay, if not, make sure you've got a copy of that. What was I going to say? A copy of the study guide. Make sure that once every Thursday we do a how to become an actual cloud architect, which is different than being certified. All the skills you'll need, what we do, how to apply, how to not get rejected by HR, and we cover all those things completely free. And our how to become an architect webinar. I'll have my team drop a link to that in the chat box, but also in the description of this video. And give me a hashtag Google Professional Cloud Architect, so I know that you're preparing for this certification. And Chris, let's get back to the content.
Let's talk about cloud computing. Let's talk about digital transformation. So prior to the internet, people worked a certain way. After the internet, people were able to do things that were never possible. Mail no longer took a week for me to send mail from myself in, say, Pennsylvania, Philadelphia to my relatives in Greece. It was instant over an email message. What used to be a $4 a minute phone call from Philadelphia to call my family in Nepetamos, Greece, all of the $4 per minute, all of a sudden was free over an IP phone or an IP voice over IP link. So the internet changed a lot. The internet gave people access to information, they gave access to other people, and it gave access to a wide variety of things, and it changed things. Now, it changed a lot of things, the way people lived, worked, and played for the most part. Now, cloud computing is there to help as well. Now, we have to understand that cloud computing is not new. All cloud computing is renting space in someone else's place versus doing it yourself. So what does this really mean? It means that cloud computing does provide some advantages and also some things that are not as good as the traditional data center. And what is cloud architecture? Architecture is about looking at all your available options, evaluating all trade-offs, and then choosing the right one based upon your organization. But cloud computing does something that's pretty great. First, cloud computing is already there. So, in a normal world, I want to roll out a new application. I have to call Cisco. I buy my routers and switches. I call Dell, for example. It could be IBM, whoever. I buy our servers. I buy our storage. I call Palo Alto and Cisco to buy firewalls, for example, and other appliances. I'm dealing with other companies. And I have to build it, and then I have to have the capacity on my systems to be able to run my business. With cloud computing, I don't technically need to build it. I can literally rent it immediately. And in the traditional data center, it makes some time, 4 weeks to get servers delivered, another couple of weeks to get the servers racked, stacked, hypervisors, what have you, put on the systems and applications installed. And in the cloud, we can have someone write a Terraform script or an infrastructure as code script and do this in a matter of minutes or seconds versus days, weeks, or months in the data center. So the performance bottlenecks of having to build it yourself are often mitigated in cloud computing. So cloud computing promotes a lot of business agility. And this agility enables businesses, potentially speaking, to innovate faster. So instead of the organization focusing on an infrastructure, they can focus on their business more, and they're going to pay the price. Now, understand, for the purpose of the exam, cloud computing is going to be cheaper. For the purposes of reality, cloud computing may cost 200 to 300% more. Those are David Lithicum's numbers. He was Deloitte's chief cloud strategist. When he left, those were his numbers and his experience. David Lithicum is an expert in the field. I also see 2 to 3 times or more to run things in the cloud compared to the data center. But it's the agility, and the agility to launch something fast is a huge business value. Now, we have to understand that Google is very big. They're very strong, they're very knowledgeable, and all the cloud providers like Google and Microsoft and Amazon and others, they are experts at designing data centers and running and operating these data centers. So understand completely that they will do it right. And for an organization that doesn't have a lot of expertise in developing their data center, outsourcing to a company like Google and the Google Cloud might be a great way to do it. So there's a lot that we get out of cloud computing. We get this agility, what have you. And these are things we typically want to talk about. I know cloud computing can shape the future of work, for example. It will make it easier for people to work in various parts of the world because cloud computing is ubiquitous. It's absolutely everywhere. So cloud computing is here to stay, and we'll be using it. And it's renting data centers versus building our own. Now, one of the things to think about is this on-demand ability. The fact that the systems are there and all you need to do is launch a script or have one of your DevOps engineers or cloud engineers launch a script and you're up and running. It's incredible. I can tell you, for example, I had a friend and he had to test various routers for capabilities. He had someone from his team launch an infrastructure as code script, spun up 10,000 virtual machines, used those virtual machines to really torture test the network. And the networking gear did great. And they found out the network, it was a great way to test it. On-demand availability, use the systems as much as fast as you can, and then shut it down when you're done. That was hugely advanced. So just having it there. Now, we also tend to have the ability in the cloud providers, they have a lot of services that are already pre-made. Use this thing pre-made and managed, use this thing pre-managed. So it enables us to build easier service-based architectures, which is completely true. If we use the cloud providers' enable tooling, and they've got a library for a few things, and we'll talk about those libraries throughout this program, because that's a lot of what the certification is about, you'll understand how you can do things faster and maybe be more service-oriented. What you'll also learn throughout this program is when you use these cloud providers' native tools and proprietary tools, it's going to make it a whole lot harder for you to accommodate today's modern multi-cloud architectures. And we'll talk about them when we get through them. So let's talk about our 3 cloud options. And I really want to show you the options and why. So if we go to this chart, and I had to make this chart for your exam. So keep that in mind. So if we deal with the public cloud, we don't have ultimate control of the security. And because of that, we're also in a shared network. So in the data center, we have to worry about ourselves getting hacked. In the cloud, we have to worry about the cloud provider getting hacked and our stuff being hacked, which is an additional attack vector. So cloud computing is less secure. Typically speaking, we have a lot less control. We can't do anywhere near the segmentation network security in the public cloud that we can do in the private cloud. Now, the public cloud is extremely scalable at any level of capacity when you need. This is awesome. It's terrific, and we love that. The public cloud is accessible. It's just there. Just turn it on. Now, here's the interesting thing to think about. In the cloud, there may be 1 million other customers that you're sharing the same cloud with. You might be on a virtual machine, call it a compute engine instance, and on the server that's holding your virtual machine, there may be 50 other businesses of virtual machines there, including potentially your competitors. So shared services, theoretically, you can't do a hypervisor escape and go from one system to another, but yet when it really matters, organizations use private servers. Now, the ownership of the gear is going to be the cloud provider, where if you're dealing with the cloud. Now, the cloud computing, they try to say is cost effective. If you actually look at what we're seeing in the market, the people are leaving the cloud because it costs so much more than they ever planned. They found out that the cost effectiveness, no matter how they designed it, lift and shift it, modified it, it was never cheaper on the cloud. And it can't be, because the cloud provider has to build the same systems you do, and then they have to manage these systems, sell them, and deal with all the things that go along with running them. So it's a landlord-tenant business, and if it costs a landlord $1,000 a month more operating costs on a property, they can't sell it for $1,000. They can't sell it for less. They have to sell it for more, maybe $1,500. Public cloud, AWS, GCP, Azure. Let's talk about the cloud. The private cloud is the most secure. I can do things on my network where two servers can't speak to each other, even on the subnets, without even using an ACL. I can rate limit bad traffic. I can prioritize business traffic over worm traffic. I can't do any of this on the private cloud on the public cloud because it's a shared network, but I can do it all on my public cloud. Now, in my private cloud, I've got relatively limited scalability. And why is that? I only have whatever capacity I have left. How about accessing this? You've got to have access to this data center, which in many cases makes it more secure. You're not accessing over the internet. You might have to access it over a VPN. So this might even be better. Now, our servers in the private cloud are shared servers. Are private. We own them. Only our own company stuff is on these servers. And we can even specify which servers need more security than others and host higher security workloads on various sets of servers. Who owns the private cloud? We do. We can do anything we want. Now, the reality is for high volume workloads, the private cloud is far, far, far cheaper. For an example, you could buy a server from Dell for about $300,000. And if you run that server at max capacity for about 4 years in a cloud provider, you can be dealing with several $1 million. But you'll have less overhead. So we have to think about the private cloud. It often ends up being cheaper for high volume workload, and it's often too expensive for sporadic workloads. And I can tell you why. Sporadic workloads are cheaper on the cloud. Let's say we built the website for a global retailer. The global retailer had 1 million hits per minute during Christmas time and 100,000 hits every day. In the data center, we have to build for that 1 million hits because we have to have the capacity for the Christmas, or we need that capacity to be able to handle it at some point. In the in the public cloud, we can build it for 100,000 and then use auto scaling to handle the capacity that we need at a cell. In the private cloud, we have to have that capacity ahead of time. So that's why sporadic workloads are often cheaper in the cloud, because you can underbuild it and then use auto scaling, which we'll talk about throughout this program. But workloads that run all the time are often much cheaper, 5-10 times cheaper, and potentially even in the data center. So the private cloud. We're dealing with here companies like Dell, VMware, Nutanix, IBM, OpenStack, that kind of thing. And what's this hybrid cloud? Now, this is a really unique thing, and most organizations are using this. In fact, most organizations have what you call a hybrid multi-cloud, where they use like 1 or 2 public clouds in addition to the private cloud. Now, the private cloud's got a lot of security. Why? We can put the most critical workloads where they need the most security, where we can provide it, which is the private clouds, and we can put other stuff in the data center, in the public cloud. Now, the hybrid cloud's highly scalable. Why? Because we build for what we need in our data center, and we can just add capacity on demand to the cloud. So, for example, if we have 10 servers running here and we need extra capacity, just add the capacity in the cloud on demand, and that can be done dynamically with our private cloud software like Nutanix and OpenStack. It's called cloud bursting. Accessibility. Now, my cloud stuff is pretty easy to get to. My data center stuff is a little hard, so now it comes in the medium. Now on my servers, I can put my own private servers. I can use shared servers, so it's now mixed. Who owns it? Well, the hybrid cloud, we own our stuff, but we're still renting stuff that's owned by the service provider. Cost is typically the cheapest in reality with the hybrid cloud, because we can put those scaling workloads in the public cloud, which are often cheapest, but those high performance, constantly running workloads in our data center, but for the purposes of the exam, we'll call it moderate expensive. And there's lots of providers of hybrid clouds. Get a Nutanix cloud connected to AWS, it's a hybrid cloud. Get an OpenStack cloud connected to Google, it's a hybrid cloud. Have a VMware cloud and connected to Azure, it is a hybrid cloud. So that's really what we're actually talking about. So we're going to ultimately use all three, and the majority of enterprises. Like I said, 98% of enterprises are multi-cloud at this point, and there's lots of reasons for it. The agility, the availability, the best tooling of each provider, for example, all the same thing. So let's talk about responsibility models and how they're actually different. In the private data center, you own everything because it's yours. You also have ultimate control of what you use. You control 100% of what you're using. Now, let's talk about what actually happens in the cloud computing environment. You do not have any control over the cloud provider's underlying infrastructure. You have no control over the routers, no control over the switches. You have no control over how they secure their infrastructure, for example. So in cloud computing, you've got this shared responsibility model, which basically means you're responsible for your stuff. All the stuff that sits in your VPC or your VNet, your private data center. And the cloud provider is responsible for their stuff. All the infrastructure that makes it that you can do what you need to get your things done. And we're always going to have to consider that, especially when we get to security, and we'll talk more about it. Now, one thing that's definitely true is when we take our stuff from a buying model to a renting model, we change from a capital expenditure to an operational expenditure. This could be the best thing or the worst thing that would ever happen to a business. And that's going to be based upon the organization's capital structure, which is why cloud architects and enterprise architects and architects that we train we are taught to evaluate the organization's capital structure and cost of capital to build the business case on what's going to be most operationally efficient and cost effective for that organization. And you'd be surprised, often it's not going to be the public cloud. Sometimes it's all public cloud. It's usually some form of a hybrid cloud or a hybrid multi-cloud. Now, another way we can manage our costs in cloud computing and understand it is where we put our stuff. So you may hear cloud costs have got out of control. You hear escalating cloud costs. People are leaving the cloud. Well, they're still going to the cloud as they're leaving the cloud at just as fast of a pace. So what is going on? If we put the right resources in the right place. For example, that server that costs $300,000 and might cost us $5 million in the cloud, stick that server in the data center. Now take your other stuff and move it to the cloud. So we need to understand that. Now we need to understand while services in the cloud are typically much more expensive, we also need a less significant staff because we no longer have to manage the network, the data center, and all this stuff. We're managing virtual assets. And that might reduce some of the IT overhead, which enables a business to put its people on more core business activities. Acceleration of innovation with cloud computing. Yeah, the stuff's there. There's so many pre-made tools. You can get stuff up and running very quickly. Cloud's the easy button. So we have to consider that. The business consideration is the impact of the simplicity of the cloud. And even if the cloud is twice as expensive, that simplicity and elegance and time to market might still be worth it, depending upon how we would look at that architectural design, what that business is trying to achieve. Now, I'll tell you this, to a degree, businesses that weren't cloud-based were starting to look like old-time businesses. A couple of years ago, they had lower valuations and stock valuations, but now companies are getting a little wiser. And we've seen companies even like LinkedIn, which were owned by Microsoft, that was supposed to go to the Microsoft cloud that kept it in their data center. So we're getting to a point where the industry perception of not being on the cloud doesn't feel so legacy or old school anymore. But at the same time, we're actually still cloud-based is a lot of what we're doing. I'll also tell you from a perspective of the employees, a lot of your employees feel good about working on cool stuff, and you can often attract better talent. And many times cloud computing, you can attract people that are more excited about it. So keep that in the back of your mind. So let's talk about the actual cloud architectures and what they actually are. because we have some hybrid cloud, private cloud, hybrid multi-cloud, and I want you to truly understand what they are. I'll probably even discuss a community cloud, although I don't think you'll see that on the exam. So here's your typical hybrid cloud. Your hybrid cloud is we've got our own data center. Let's say we're running, last time I used Nutanix, in this case, we're talking OpenStack, cloud software from IBM Red Hat. And now we connect this to AWS. Got a router on our side, or multiple routers, and we've got a virtual router on the AWS side. We buy a private line connection between them. A direct connection, AWS calls it, Azure calls it an express route, Google calls it, I'm pretty sure, a direct interconnect, same thing, same private lines we've been using for the last few decades, and we've got a hybrid cloud. Now, how do we turn that into a hybrid multi-cloud? Well, we've got AWS that we're working with, we've got Google Cloud, we get another private line, for example, between AWS and Google, and now we're in a hybrid multi-cloud. Now, this, realistically speaking, is pretty good. Let's say we really like Google's AI capabilities, and we really like AWS's large amount of infrastructure. So we could create what's called best of breed, where we could use AWS for what it does best, Google for what it does best, and the data center for what it does best, which is the highest performance, highest security, lowest latency compute workloads. So that's your hybrid multi-cloud. We could also just do a multi-cloud architecture, which is just two cloud providers. And all we're doing with two cloud providers is just as following. We're load sharing between them. We can have 50% of our workload go to, say, AWS, and the other 50% of our workload go to Azure. And by doing this, it's not going to increase our cost for the most part, because instead of buying 100% of our stuff here, we're splitting it, kind of like you went to two stores to buy your groceries, no difference. And now we can send half of the traffic to AWS and half of the traffic to Google. All of a sudden, AWS has an outage. All your traffic is sent to Google, and then Google can add capacity with auto scaling to get you 100% within 45 minutes, and you're up and running. So there is that. Obviously, you know what a private cloud is because we design private clouds. You've seen the public clouds, which is just a single cloud provider. Now, you may also see something called the community cloud, and I want you to know what that is. So let's say we're in Philadelphia, and I'm just using argument's sake. So let's say Philadelphia has 14 hospitals. And maybe those 14 hospitals decide to call themselves the Philly Hospital Cloud. And what we're dealing with in a community cloud is a bunch of organizations get together. They design a cloud. The cloud is designed to be based on exactly what they're looking to actually do. And it's managed and run by 13 or 14 hospitals. By doing this, they can pool their resources and get an economy of scale and better discounts, but they don't reach hyperscale of the cloud providers where they've got so much overhead, they can still do it cheap, and it can be custom built based upon the needs of a specific community, and that's called a community cloud. Last time we checked, it was not on the Google Professional Cloud Architect exam, but I thought it would be good for you to know. So let's talk about some cloud computing service models. And there's going to be a couple models that we can use. And I want to go through them with you. So the first model we're going to use is infrastructure as a service. And infrastructure as a service is getting an exact virtual data center. And in your virtual data center, you'll have your virtual machines, you'll have your containers, and you'll run it all as if it was the same systems in your data center. Now, when you do this, you have the highest performance. In many cases, you have the absolute most control. But you're also responsible for the most things. And we'll walk through that so you can actually see what those kind of things are actually going to be in a minute. But understand, for the most part, what we're really talking about here is control with that private cloud that we're actually talking about with that infrastructure as a service model. So the next model we could be using is something called platform as a service. And what is platform as a service? And I'm going to give you some visuals in a minute. Platform as a service is, for the most part, when things are pre-made for you and you upload your code and it runs. You put your applications and your data and all the underlying infrastructure is there. Now, this is the same as application virtualization we've had in the data center for a while. Windows Server does it, lots of opportunities with VMware, so it's not new. Platform as a service, upload your code, and it runs. And the last type of cloud computing model we'll talk about, and then I'm going to really show you what we're talking about with some graphics and things, is what you call software as a service. Software as a service is basically when you access an application via a web browser, it's hosted by somebody else, it's managed by somebody else, and you've got, for the most part, almost no control over the system. Maybe you've got some IAM controls, very simple. It's basically an off-the-shelf application that you're using. So let's look at what we're actually really talking about and what this really means. So if I walk you through this design with infrastructure as a service, let's see what we really have. You're basically renting your virtual data center. So the cloud provider is going to be responsible for the networking, like I said, the shared security of their data centers. They're going to be responsible for their storage, meaning their actual hard drives that are sitting in their storage area networks, their physical servers, and say their hypervisors. You'll be responsible for your virtual networking and your virtual private data center, your operating systems, whatever middleware you're using to connect systems to systems, any applications data, anything necessary to go on. So in infrastructure as a service, you're renting a data center, and all the heavy lifting, the network, the storage, the physical infrastructure, you're going to get in virtual form. And they're responsible for the physical, and you're responsible for your stuff. Now, when we get into platform as a service, look, the only thing you're really dealing with is uploading your code and your data for the most part, you're uploading your code and storing your data. So that means the networking, the storage, the servers, the virtualization, the operating system, middleware, and all the runtime modules necessary to get it running. It's all done by the cloud provider. So we're typically talking about that and the typical model. And the software as a service model, which is really the three models in your exam, so I'm going to really revert just these three. Basically, the applications as already made by the cloud provider, and the data that cloud provider manages for you with your data, but it's stored on their systems. They manage the operating systems, the servers, the network, and anything, so you have the least control. So if we look at examples of each, you get your VPC, or your VNet, or whatever you want with which cloud providers, your virtual private data center, what you put in there, your virtual machines, all that stuff, that's infrastructure as a service. Upload your code and it runs, that's platform as a service for the most part. Software as a service is an application that's hosted by somebody else for you. So we think about that. So let's talk about the key players in the world. There's a lot of cloud service providers. Key players were, realistically speaking, up until recently, Amazon and Microsoft. And we're seeing a lot of movement with the Google Cloud and the Oracle Cloud as well. And I think it's a good thing as organizations do more multi-cloud architectures. For lots of reasons, they're going to be finding themselves on all these clouds. Most organizations are going multi-cloud here. Organizations started with a single cloud. They realized it was not a good idea. We've never created architectures in the last years where we'd use the same service provider for everything, and I've never seen it before except for some of the early cloud architectures. And when a cloud provider had a failure, the organizations were down and had all kinds of troubles. So there were lots of reasons organizations moved into multi-cloud architecture, 98%. And there's lots of things that we could potentially do. Now, we really need to be a little less concerned about which technology we do and more concerned about what technologies get the business to their actual outcome. So whenever we talk about architecture, it's always looking at it from a non-biased perspective. Can't be falling in love with any technology. We need to basically fall in love with making our clients successful. And you can see that Google Cloud's making big inroads with lots of big organizations, and they're doing great. So lots of organizations are using the Google Cloud. Now, realistically speaking, they're there, and all the cloud providers are going to try to tell you they're different, but in the end, they're only servicing standard data center type things for the most part, and that's what we're really dealing with. So we're going to be in this program discussing the Google Cloud. We'll typically focus on areas of the Google Cloud and principles of the Google Cloud as we talk about designing things for the Google Cloud on the basis of this certification program. One of the core principles, according to the Google Professional Cloud Architect curriculum, is security in the cloud. And a lot of that has to do with the customer data ownership and control. The customer retains ownership of their data, and the customers can control how the data is managed. And it's going to take a lot to really deal with data ownership and control. We'll have to look into things like encryption, for example, and managing encryption keys and data rights and data classifications, and so much more will go into that. Internal controls and auditing. So another key thing that we're typically talking about that's going to need to actually occur, we're going to need to have internal controls that protect against people doing the wrong things. Strong internal controls prevent unauthorized actions by insiders, and a lot of attacks actually come from insiders, sometimes by accident, sometimes maliciously. And by having comprehensive auditing and controls, we can keep people from doing the wrong things and keep track of people that actually did. Some other things we're typically going to need to be talking about is security monitoring features. How do we monitor the environment continuously for security problems? What kind of real-time monitoring can we do for security threats? How can we proactively identify and mitigate vulnerabilities? And the security architects are going to be doing a lot of work here. And of course, we have to talk about that shared security model. All cloud providers have this shared security model, and here's the reason. You can't control their stuff, and they can't really control your stuff for the most part, or they shouldn't be controlling your stuff. So you are responsible for securing your things. Your VPC, for example, your operating systems on your virtual machines, your firewall settings connecting you to the internet, and they're responsible for securing the infrastructure of the cloud itself. Now, the Google Cloud gives us a lot of encryption options. We can encrypt data at rest and in transit, which is done by default. And we should, no matter where we're at, use strong encryption protocols to protect our data integrity. That we can check the integrity via hash and the confidentiality of our data by encryption and making sure that people won't be able to see it without the encryption key. Now, we also have to understand that all cloud providers have a private network backbone connecting their environment. So we can ride from one part of the world to another part of the world on the organization's network. And the organization's network can have good, strong network performance because they guarantee it and they build it, which is different than routing your traffic on the internet, which is best effort. Now, Google has a lot of control on its infrastructure. Part of maintaining really good procedures are, having your systems, having good change control procedures, having a procedure to do everything. And Google, like the rest of the cloud providers, are expert network operators and expert data center operators. So they know how to manage service delivery and can give you a consistently strong, for the most part, user experience. Still expect problems in cloud providers, but for the most part, you're going to get great experiences. So let's talk about some customer preferences as we're dealing with cloud computing. Customers in today's world prefer not to be locked into a single cloud provider. Customers may want to use the various strengths of different cloud providers. Now, there are going to be implications of this when we go through this program. If you want to be able to use a database, for example, and we use a Google-specific database, because maybe, let's say it's the best, we might do that. But if we do that, we have challenges now we're in that database. By comparison, let's say we needed a NoSQL. By using something like Apache Cassandra, we can put those servers in 3 different clouds. By using something like a Cloud Bigtable, we would need middleware to connect it to other databases and other clouds. So we have to avoid vendor lock-in if we're dealing with multi-cloud, which is going to be not using a lot of the proprietary things we're going to be talking about. So as we go through this, we'll talk about which things are proprietary that are going to make multi-cloud hard, and which things are going to be natural and non-proprietary and open that are going to make multi-cloud easy. And we'll go through that through various components. And Google, for the most part, has a fairly open approach to the way they do things. And I don't know whether it was necessity because they had smaller market share, or, Google came up with open standard things like Kubernetes and helped with that. So they do a lot of open standard, open work community, and that's going to be a big help here, specifically when we get to cloud computing. So I hope you understand now what is cloud computing and the various types of cloud computing models that are offered by the Google Cloud.
Okay, well, welcome back. We are here. It looks like there were some really fun, cool questions and discussion points that popped in, which I'm obviously looking forward to do. But I want to just do from a housekeeping perspective. If you just joined us for some reason, there is a completely free guide that's going to go along with this video. It's a good 550-page guide my team made to help you pass the Google Professional Cloud Architect exam. And it obviously goes along with our free Google Professional Cloud Architect training. All you have to do is click the link, sign up, and it'll be emailed to you in 10 to 15 minutes. So keep that in the back of your mind. On Thursday, we're going to have a How to Become an Architect webinar, and we're going to actually talk about what architecture actually is and what architects actually do, and the kind of decisions we have and the skills you need, which in many cases is completely different than certification training. But the questions have popped up, and we'll talk about what it is and what we do and architecture trade-offs if you want. I'll even give you a mini interview if you think you're ready to be hired, or even look at your LinkedIn profile. We're going to do that on Thursday. We hold one every Thursday, so please feel free to join, and my team will drop that link into the chat box as well as the description of this video. Now, and if you're having a good time, give it a like, subscribe, and then let's get to the questions. So Connect Matthew says, can internal IP addresses be accessible across all VMs regardless of a subnet? So Matthew, this is the way it's always been for the last 40 years. All of the internal systems have private IP addressing. The routers and switches route between them. And unless you limit a route or use an ACL or a firewall to block it, normally every system with a private IP address inside of an enterprise can talk to each other. And it's always been that way. So the question is should it be that way? And the answer is no. So realistically speaking, that's where we get into packet filtering, things like access control lists. That's where we get into route filtering. That's where we get into QoS and shaping traffic. Should a server for example, get hit with a worm and propagate too much data, we could rate limit it. So there's a lot that needs to be done. We'll cover some more of those things on the network security days, but what you're describing is the way it always has been, as in almost all systems in the entire world. And even in the cloud, if you've got 2 subnets and you've got routing, or 3 private subnets and you've got routing between them, they're going to be able to talk to each other. So that's the way networking has always been, Matthew. The question is, how do you want to route it and how do you want to architect it? And should it be that way? Good question, though. What drives someone to choose GCP over AWS? So let's be fair. In reality, AWS, Google's cloud, Alibaba's cloud, Dell's cloud, the Microsoft cloud, the Oracle cloud, they're the same things. They're buying the same processors from AMD and Intel. They're buying the same DRAM. They're buying the same networks from the same people, the same storage. It's the same thing. So, if you buy your eggs at Publix versus you buy them at Aldi versus you buy it in my village in Nepenamos, it's just eggs. So all in all, they're the same. Now let's talk about the subtleties. Now you will know, if you look at Amazon, if you look at their message, it's very startup-y, very small businessy. They don't typically talk about in their public messaging, driving transformation, business process opportunity, business optimization. They always talk about tech. And that tends to get the startup kind of people. Now, when you listen to whether the IBM or a Microsoft or a Cisco sells, they go to the enterprise. They look at the organization strategy. They've got decades of enterprise experience. They understand business process modeling. They understand this. So Microsoft tends to get a lot of the big enterprise stuff. And if you looked at the last numbers, AWS was struggling in the enterprise, but Microsoft was gaining ground there. Now, if we look at Microsoft and what they've done well, they've invested heavily in OpenAI, and they have more enterprise data most likely than any other company in the world other than Google, because they've owned almost every desktop of the user for decades. Everybody uses Office, everybody uses Microsoft services, and they even own games, so they've got a lot of data. So when Microsoft went early on and was one of the biggest investors in AI, a lot of people see that Microsoft as an AI play too, and it is. It's an enterprise play. Now, if we look at Google, the biggest search engine in the world, YouTube, the second biggest search engine in the world, they've been custom doing and designing AI chips for a long time now. They have so many AI algorithms for decades that are actually out there. So we often think of Google as AI because they're so good at it. So we might think that AWS is small businessy, focused on the techie, make it fun, go build something regardless of whether you need it or not, just go build something. That's AWS message. Microsoft's message is let's be strategic. Let's figure out what you need and how do we build something for you that's going to change your world and the way we live, work, and play, like Cisco. And Google's always at the cool end of AI. So you might see that. And of course, IBM, you think digital transformation like Microsoft. So there's branding variations, which typically have different salespeople. The salespeople at Cisco, Microsoft, IBM, those people now to sell billions of dollars of stuff. So that's what they focus on. So it's more of a culture and a marketing thing than technology. It's all the same technology when it comes to set a bit on, although there's some subtleties between them. I hope that kind of helps. The other reason is you put all your eggs in one basket. So let's say you're on AWS, you need a second cloud provider. You would never have two networks where your wide area network providers are all the same company. So there's hedging the bets, of course, that. And then the theory would be that Google might be better than AI versus someone else. But it's all theory and conjecture. It's how you design the systems for your needs. Hope that helps. How can we be sure about the security in GCP? They can access your data. They can shut you on your servers. What if they decide? So as whenever we have to think of architecture and anything, there's always trade-offs. What do I gain versus what do I lose? Now, the key is cloud computing provides agility. But is it as secure as the data center? It can't be. And here's the reason, Yaz. In the data center, you can get hacked. Your data center can be hacked. Now, in the cloud, your virtual private data center can be hacked and the cloud provider can be hacked. So you've got two attack vectors. Now, at the end of the day, Yaz, who do you think is a bigger target? Attacking you or attack Google or Amazon and get all their client stuff? And we've seen in breaches in Microsoft and other clouds where people have gotten into a cloud provider stuff and got a lot of client data. So yes, this is a cause for concern. So some companies and organizations that need high security, like the US government, won't use the public cloud. Now, what they do is they have a different cloud that's built for the US government. So their systems aren't on the same systems as private companies. Hence, they call it the government cloud because the government doesn't feel it's safe to put their systems in the same systems as the cloud provider. Because imagine if they did. Now they're in the same, all of a sudden you got a couple of countries trying to gang up and get all the information out of a single cloud provider. So think about that. Now, I also was taught something. So I'm Greek, Yaz, and a lot of Greek people open restaurants. And I was given some advice when I was a kid. They're like, Mike, when you open your restaurant, which I never did, my family had a restaurant, but I didn't. They said, when you open your restaurant, you have to buy the building. They said, because if you don't buy the building and you have a successful restaurant and all of a sudden the landlord wants to triple your rent, you're out of business. So you must own the building. So, we have to think about that. There are times where it makes sense to have your own systems. Now, there are times where it makes sense to have the agility of the cloud to be able to do something in seconds that might take you weeks or months in the data center. So maybe there's times where we want that. So at the end of the day, it's about evaluating trade-offs. Cloud computing offers us agility. It offers speed. It offers us the ability to create new products, new services, potentially, and new things faster than our competition does and gain market share before our competitor does and gain strategic advantage. It may cost us twice as much. It may not perform as well. And it may not be as secure. No, we can do things to mitigate those things. And we have other training where we talk about how to do that. But the key is, yes, we have to think about this because it happened to a company like Parler. They were in AWS, and I can't say good or bad for their business, but AWS said, we don't agree with your politics. And poof, they're closed. And then they would have had to figure out how to create a data center from scratch. And that's not easy while you're paying employees and other people. How do you figure out how to start your company all over again? So yes, Josh, yes, it's real. These are the kind of things we need to think about in any time we design. But same thing about real estate. Do we build it? Do we rent it? Do we buy it? Do we rent it? Same discussion. I mentioned servers are separated in the data center, but most people you speak with worry about their information being together. How do you get to communicating this point better? So at the end of the day, Dimitar, all of these are shared systems. If I go to AWS, I may have 10 customers, 50 customers on the same physical server. And guess what? Their storage is also going to be on a similar hard drive. Now, what does that mean if all of a sudden company B, who's on the server that I'm at, does something that is considered to be an illegal crime, and the government comes and they confiscates the server from Google, Amazon, or whatever? Now that government, technically speaking, has access to your data. Some companies worry about that. So same thing with your data. All of a sudden, the government seizes data because they find some companies doing something inappropriate and they need to collect the data, and they steal the hard drives from or they take the hard drives, not steal, from the cloud provider. And then the cloud provider puts new drives in. Again, your information could be there. So what we have to understand is that when we are in cloud computing, it is a shared environment, and ways that we can protect against the shared environment include encryption, network security, identity access management strategies. And we also have to be fair that when we go to the cloud, there are certain security weaknesses that exist in the cloud that did not exist in the data center. Things like perimeters and shared things. So that means we need to migrate to a different security paradigm. I can use defense in depth in my data center, protect here, 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 here. But in the cloud, people are coming from different directions. Now I need to migrate towards a zero trust architecture where I still have my defense in depth, but I need to trust every request, use encryption absolutely everywhere, microsegment everything because boundaries got weaker. So that's all about your skill, your understanding of the tech, your understanding of the tech's strengths and weaknesses, opportunities and threat. And that's what we do as architects. We say, okay, this architectural option does this and this well, but it does this real bad. This architectural option does this really well, but it does everything else bad. Now, which is the right one for our company? That all depends upon our needs. So, hope that helps. Can I talk more about cloud bursting? Absolutely. I love cloud bursting. I think this is the coolest thing ever. So, think of it this way. Let's say I have a data center which needs 100% of my capacity. And all of a sudden, let's say I'm selling cat food. And all of a sudden, Taylor Swift sends a tweet that says, everybody likes Mike's brand of cat food. Now, all of a sudden, all these cat lovers and Taylor Swift fans, I think they call them Swifties, they're going to be going to this site to buy this cat stuff. Now, all of a sudden, the web servers will be taxed. They'll be overloaded. So you know what they do? They're going to shift the load to, say, AWS. So when we run out, as we need more server capacity, it could add it to AWS, Azure, Google, Oracle. So we always have more capacity. But we don't pay for it until we need it. That's cloud bursting. What's the difference between serverless and platform as a service? So serverless is a completely garbage marketing term that means there's no server for you to manage. But at the end of the day, it's still everything runs on a server. So I hate the term serverless. So serverless could be upload your code and it runs, like with a function as a service, like a Google function, Azure function, AWS Lambda function. Or it could also be, when we're talking about serverless, a place where you put your containers and it just and all of a sudden it provides compute capacity, but you don't have to think about the underlying virtual machine. It could be a database that somebody manages the storage and compute for you. So all you need to worry about is your data. That's more of a platform as a service, but it's all serverless. So the key with serverless is it's just a marketing term, which means you don't know where it's running. And you don't have control over where it's running. And it's going to run on some server that's there. But that's really it. You can have like an AWS Elastic Beanstalk where you upload your code and then it provisions what's necessary. That's an answer of a more application virtualization, if you will. We can have a serverless database where basically somebody else manages the server, the MySQL installation, you will, the storage, the IOPS, the latency, the CPU and DRAM performance, and all you do is manage your tables. That's all serverless, is that somebody else is managing the underlying thing and taking control over it for you. I think, Chris, we should get back to the content. So I think unless there was anything that I missed. So give me a hashtag, Google Professional Cloud Architect. So let me know that you're awake, you're alert, and oriented. If you're enjoying the content, give it a like, maybe subscribe and hit the bell to be notified for new things. And then let's get back to the content.
Now, I'd like to discuss a little bit about the Google Cloud and how it's organized, because we're going to need this when it comes to designing architectures. So let's whiteboard it out. So we're going to have something called regions. And a region is going to be a large geographic area. So let's say we have a region, and it could be the Mediterranean region, a Middle Eastern region, a part of the US, but a large geographic area. And all the cloud providers have their own regions in certain parts of the world. So the regions are going to be a large geographic area. And inside of each region, we're going to have data centers that are actually going to do the work. And typically speaking, you're going to have data centers, and they're going to be called availability zones, typically speaking, or zones. And this is all cloud providers. So whether you call them zones, availability zones, each cloud provider has a name, but I want you to understand this. So in a region, you typically may have a whole bunch of data centers called availability zones. And typically speaking, you might put some of your systems in 2 different availability zones to enhance your resilience to a degree in case one data center fails than others. But you could also look at regions. So without going into any specific regions, let's say that we have a region that's based in the U.S., for example, a U.S. region. Oops. And then we might have another region in Europe, for example. And, for organizations that are going to be limited to a single cloud, which is generally not recommended for high availability needs, they could potentially use two data centers in the U.S. and 2 data centers in Europe. And what happens is these regions are going to be connected by the organization's network backbone. And they're going to typically have some private lines that are going to be connecting their data centers, their regions together. And that's how you'll be able to access systems on both. So think of a region as a large geography, thinking of an availability zone as a data center. Now, what happens typically in networking, and if you were ever going to design large networks, what you would typically do is you would design these networks, and they'll typically have some degree of routing that's common between them, like an interior gateway protocol like OSPF. And then we will have another region in Europe that will have its own interior gateway protocols, its own routing, and its own system design. And then they'll typically run BGP between them. And that way, hopefully, if a problem happens in Europe, it won't propagate across to the US. But it still can, and that's why a single cloud's a single point of failure. Because if anything takes the networking down for the entire cloud, you have absolutely nothing. If anything attacks the cloud's control plane, like in a hacking event, we've got nothing. So network failures, control plane failures, massive hacking or security events can take down a single cloud. So now you know for the most part of how the Google Cloud is organized. Now we're going to discuss some of the principles for design in the Google Cloud. Now, these are the types of principles that are stressed in this certification. Much more is going to go into an actual architecture, much more of understanding the business goals, understanding the workflows, business processes, business architecture components, and all the other systems. But this is some of the things you need to think about with regards to design for the purposes of the Google Professional Cloud Architect certification. One component is really going to be operational excellence. The ability to automate builds, testing, deployment, and use an environment that consistently gets better and accelerates the velocity that applications can be deployed. So the organization can have the best systems in the fastest period of time. So that's a pillar of operational excellence. And along with that means making sure the systems are easy to manage and aren't going to take an incredible amount of resources. And it won't take resources that you don't have to manage those systems. So any good architecture needs to be based upon the business's actual objectives. So prior to starting any architecture, you need to understand the vision for the architecture, what that organization is trying to actually achieve with the architecture. What are the goals? Is it to increase sales? Well, if so, you know what to measure after the architecture is done. Is it to increase the speed that an organization can create code? And that means, the level of code you could produce now versus the number of lines of code later, for example, you could compare them. But you need to know what the goal is so you know what to design for, and then you know what to measure later. This is where you're going to get your metrics, because we need to make sure the systems are meeting the goals of the business. Sadly, in 70% of cases, the systems don't meet the needs of the business or provide business value because they're designed without thinking about the business's needs. So we need to make sure we know what those needs are and be able to monitor the response of the architecture. Did it make the business better? We also need to make sure that we've got a good disaster recovery and business continuity plan for the business. A business continuity plan is how you keep that business up and operational if something big were to occur, and it includes business objectives, whereas the disaster recovery planning is more about how fast can you get the IT systems or the cloud systems or whatever they may be back and up and operational. So we need to make sure that not only is there disaster recovery planning, but on the operation side, somebody tests the plan and works through the planning. Now, in our architecture, we need to design systems that are going to meet the security, the regulatory, the compliance needs. So that means we will need to think about encryption as part of our architecture and strategies, identity and authorization controls, making sure that we've got the right network controls, the right physical controls. It's going to be part of everything. Even applications are going to have to be coded. So making sure we have the elements of a strong security architecture in place for all of our environments is going to be critical. And security isn't just a one device thing. It's going to take a layered approach. And if you can think about an onion, and every time you peel back the layer, there's another layer. That's typically what we want to deal with security. So if you had to get a castle, you'd have a big wall around the castle, and then you'd have a moat around the castle. And then maybe you'd have some knights protecting the castle behind that. So layered security is called defense in depth. And we're going to want to use things like that in addition to a zero trust architecture, typically speaking, when we get there. So that's going to be part of our system design. We need to think about what are the business needs. Does that application or does that system need to run all the time, 24 hours a day, 7 days a week? Can it tolerate 2 minutes of downtime per year, 5 minutes of downtime, or 5 hours of downtime? Because that will obviously govern your actual design and architecture, your actual needs of the system. Now, a lot of security, again, we're going to have to go into here, but that's going to include things like understanding what we're protecting, and every component along the way will need things. So we're going to have to include security monitoring along with all types of monitoring for the system. So what are we really talking about with regards to principles of design? Making sure we design something that's going to meet the business's needs, making sure we have the scalability and the agility in the system so the business can grow or change directions easily without major architectural changes. Is making sure we have the security in the systems, whatever is necessary to do that, whether that be a security policy, whether it be an incident response procedure when something happens, whether it be multiple security vendors' products, whether it be a SIEM system, a data loss prevention system, whatever it takes to keep those systems secure, they're going to be part of our architecture. We're going to need to make sure the networking can scale. Anything from IP addressing SIEMs to route plans are all going to be part of that security architecture. The applications and the way they're designed and how they're designed will be part of that architecture. But all of it at the end of the day is going to go back to how do we make that business more flexible? How do we make that business more agile? How do we make that business more efficient? And all of that is about aligning an organization's people, processes, and technology. And that's going to be the main elements of architecture. There's not a lot of architecture in this Google Professional Cloud Architect curriculum, and I tried to give you a little more there than that's actually here, but join us on other architect webinars and things. We can dive much, much deeper. And that's what we do in our primary training programs, is deal with the 1,000 hours of training that are necessary to answer those questions. Now, we'll move on to a new topic, hybrid and edge computing. And that's going to be something we typically deal with in the modern environment. And hybrid cloud computing and edge computing is quite nice. And we'll talk about why we use these things. So a hybrid cloud, often called hybrid computing, combines the benefits of a data center and the benefits of a public cloud at the same time. Now, hybrid computing has a lot to offer. And why is this? Because in our data center, we have the maximum control. We have the maximum performance. if we want to think about going from the data center to the cloud, there's going to be latency. And that latency may or may not be best upon the applications. In the data center, we have almost no latency because it's right next to us. When we go to a cloud provider, those systems in the cloud provider could be 1,500 miles away. So there's going to be several milliseconds of latency, which can affect performance. Does it matter? It depends on the application, but we need to be able to think about it. The next part of the data center, which is so good, is high performance workloads are much cheaper in the data center than they are on a cloud. For example, you can find cases where a $300,000 server from one of the server vendors like Dell might cost $5 million to run that same identical server over the cost of 4 or 5 years in the cloud computing environment. Now, it doesn't make sense to spend that much more to put that server in the cloud. Keep that server in the data center. But you know what? The agility, the flexibility of the cloud provide a whole lot of business value, and we might want to use both. So in hybrid computing, what we have is we have the data center. We've got all the data center benefits, and we still have the benefits of the cloud, and we can do all kinds of things. One thing we could do if we wanted, we could put 50% of our workloads in the data center if we wanted, and we could put the other 50% of our workloads in the cloud. And just imagine, for example, if we did that, we can monitor the data center. And if for some reason this data center went down, we could use auto scaling in the cloud to bring that 50% capacity to 100% capacity within 45 minutes. So that would improve the availability of the system if we wanted to do that. Now, there's a lot of things we can do security-wise in this data center that we can't do in the public cloud. I can create my own VLANs. I can create access lists at layer 2 based upon MAC address. I can create a special kind of VLAN called the private VLAN, where two servers in the same subnet in the same VLAN can't even talk to each other. I can create controls that if you plug in with the wrong MAC address, the port that you plug into is shut down. And I can even create quality of service to prioritize mission critical business traffic over, for example, worm traffic if it was on our system. I can do that in the data center. None of that can be done in the cloud provider. Why? The cloud provider may have 100,000 other clients in their data centers, and they need standard networking. And in your data center, you're the only clients you can do this. So the hybrid cloud will give us the best performance, the maximum performance, and we still get the agility, scalability of the cloud. And we can do one other thing here, which is called cloud bursting. And this is absolutely incredible. So let's say right now, we basically kept the majority of our systems in the cloud. Let's say all of them for right now. In a hybrid cloud, what we can do is we can have this connection to the cloud provider. And if the application's reached a certain level of utilization, we can immediately add capacity in the cloud provider and just pay for it as we're using it. When we no longer need the capacity in the cloud, shut it down and then resume to our servers, which we already paid for in our data center. So a lot of powerful things we can do with hybrid cloud. Now let's talk about edge computing. Edge computing is something pretty cool, and edge computing is getting the computing processing power closer to the user. So you might, let's say, in your house have a computer. It's fast for you to access it. But if you had to get your data off of the cloud or you had to access a server on the cloud, it might take milliseconds of latency because of the latency between you and the cloud provider, much longer over the internet. But what if you needed that information to be processed as fast as possible? Do you want to take that data over a long network? Probably not. So let me show you this. In this environment, what we have is we've got some edge computing going on here, and I'll show you why the latency matters. So let's say we had a self-driving car, and the self-driving car was going to be communicating with the data center, potentially to be making decisions or gathering information. If the car sensed an obstacle and sent some information to the computer, you want it to get to the server, you want it to get back as fast as possible. And if it took an extra 1/100th of a second to get the information to a cloud server for a self-driving car to give the command brake, maybe that's the difference between hitting something and not hitting something. Not usually the case, but we need that latency to be that low and that fast. Imagine a surgical robot, for example. And the surgical robot that's outside in the field needs to get a command to stop cutting. And we need that instantly. So getting it closer to the server as opposed to backhauling it to the cloud provider, which could be 1,500 miles away, gives us better performance. So this concept of edge computing and putting the compute power closer to the user can really help with a lot of different applications that are out there, reducing the latency of these applications, and it enables some new things. So to me, edge computing is pretty exciting when we start thinking about all these IP type enabled applications we can actually do for the future. Now, you'll typically also hear about Internet of Things with edge computing, which is something you'll also see among cloud providers. Internet of Things typically are Internet IP-enabled sensors, like your refrigerator or 101 other things. And cloud providers often have management software to manage those devices, host those devices for you, and sometimes under some cloud provider circumstances, you can run that at the edge of the system as well. So now you know about hybrid computing and what they are and why, as well as edge computing. Now, Google has this Anthos, which gives you a unified platform for managing your hybrid environments, and it enables some fairly consistent deployment, operations, and security policies across these. There are many other ways you can manage a multi-cloud architecture, but it is a Google certification exam, so you need to know about GCP's Anthos for that reason. And Anthos is going to be that Google's solution for managing your hybrid and your multi-clouds. It's going to simplify realistically modernization of things by enabling developers to use a single platform to deploy and scale containerized applications across the environment. It's built off of Kubernetes, so it enables the organizations to be able to deploy and run workloads across data centers. So when we start thinking about these services together, they make it easier to deal with multi-clouds and hybrid multi-clouds, which is the reality for almost everybody. 89% of businesses, the last time I checked, were running on multi-clouds. And according to Oracle, 98% of enterprises are multi-cloud. So we'll always have to think about ways we can manage and optimize these multi-cloud environments and put the compute power where it's going to be best served to the application, and edge computing and hybrid computing are environments for that. Now, Google also has something called an edge TPU. So Google came up with this tensor processing unit to basically assist with AI and machine learning loads. It's the specific processor that Google actually has. Often we use things like NVIDIA GPUs and CUDA to also run our operations, but this is an alternative that you can do on the Google Cloud. And Google has these TPUs at the edge of your device, at the edge of their systems, at the edge layer to promote very rapid processing, potentially of AI and machine learning workloads before going to the actual data center. So it's really going to reduce latency. And that can reduce bandwidth. It's going to be backhauled to the data center, which can also reduce costs. So I want you to think about this. In an environment where we have like this, where we've got our devices, if they can hit the edge server and back, we only have the networking to contend with from the mobile device itself, or the automobile, or the robot, or whatever it is, to the edge node. We don't have to think about the networking between the edge node and the cloud for the most part, because the work is already being done here. If we had to send it back to the cloud server, not only would we have the latency of the systems, but now we'd be dealing with bandwidth that we might need to deal with and or pay for depending upon the architecture of your environment to the cloud server. So there's a lot of benefits from keeping the data and the processing of data, even AI data. Let's talk about other reasons. In certain cases, we must have data locality and compliance. So many industries like healthcare and finance are subject to very strict data resiliency and compliance regulations. And a hybrid model makes it easy for an organization to process and store sensitive data locally, as opposed to it getting replicated over a cloud provider, potentially speaking, all over the world. So we can have the ability to put mission critical, more private data in our data center and put less risky data in the cloud, should we choose to, because we can, again, get more control in our local data center. And with Google's Anthos, it can help you balance the integration between the on-premise environment, the cloud environment. So that's going to make it easier to maintain compliance and benefit from the scalability of the cloud, the agility of the cloud, and still keep your systems running in the data center, which are often going to run better, faster, and cheaper for high-performance workloads. So that's really what we're talking about this. Now, we can also do a lot of disaster recovery with hybrid computing as well. By disaster recovery, we could either use the cloud as a disaster environment where if our primary data center went down, move it all to the cloud if we wanted, or we can also use the cloud to disaster recover another cloud. So we may have our systems on AWS. I don't want to put my disaster recovery systems on AWS if my systems are hosted on AWS, because if AWS is really out for some reason, then my backups, who knows what's going to happen in a disaster recovery environment in AWS. But if AWS is hacked, chances are that Google or Azure won't be at the same time. So that's why we want to use disaster recovery in another cloud. And let's talk about the kind of disaster recovery we can do in cloud computing that makes it so much more efficient and so much cheaper that you might actually think about. So we might have our data center here. And realistically speaking, let's just say we had 100 different applications. And each application had 10 servers. So we had a total of 1,000 servers, right? In this particular environment. Now, what if that went down? And what if we didn't have what if we had 2 data centers and they weren't all go down? Now, we have a couple of options with the cloud provider. So we have a few ways that we could back it up. And I want to show you why these are different than any other way. So if we had this traditional environment, we ultimately had the choice of having a physical disaster recovery site that either was maximally staffed like this, or maybe it could support 10 of the applications, maybe at 100 sitters and servers waiting to go there. And if and when this were to go down, the disaster recovery environment would support a subset of our business. And this was complicated. We had to buy a year ahead of time. We had to spend a lot for real estate. So this was pretty expensive. Now bring us to cloud computing. We have a couple options. One option that we can do here is if we have 10 servers, we can have 10 images of our servers. And we'll talk more about images later, but we could just have 10, let me just make it bigger so you can see it, 10 different images. And an image is a bit by bit copy of it, of the server. We could synchronize our data periodically if we wanted to, and synchronize the data with the cloud. And if this was the case, worst case scenario, if our data center went down, all you're dealing with is paying to store these 10 images and your data, and we could have a cloud engineer open an infrastructure as code script and literally speaking replicate your entire environment, and it would be up in about an hour or so capacity. And the only thing that would be questionable would be how long you backed up your data. Now in the cloud, we can make it a little better. We could synchronize our data in real time if we wanted to, and let's say we synchronize our databases. DB. Now, if we were to do this, and this is for example, why hybrid clouds are often used for disaster recovery, here's what would happen in a failure. We already have our data absolutely synchronized. We have copies of our virtual machines. Somebody launches an infrastructure as code script, and wow, depending upon how good that organization is and how fast their scripts, in 30, 45 minutes, they've got a full operational business. And all they were paying for was 10 images and synchronized data. So that, again, could be really cost effective, but here's where cloud computing really shines. So if we really wanted good automated disaster recovery, we have these 10 application servers, right? We have in the main data center, we have 100 application servers. And they all take 10 servers each, right? So what if we had one server for each app running in the cloud, which would mean 100 servers? So this is a server, and they're all running. We just have all these little servers running here in the cloud, one instead of 10, and all this is here. So now we've got our database synchronized, and basically 10% of our capacity sitting in the cloud. Now, what's great about this in a hybrid cloud is we can have a system detect a failure, and if the entire private data center were to go down, we could redirect all traffic to the public cloud, and these servers can use auto scaling, and they're going to be up and operational instantly, but they'll be at reduced capacity, say 10% capacity. And automatically over the course of 45 minutes, this thing is going to be 100% unoperational because the servers will just scale out based on need. And this is where the cloud really shines, especially in these hybrid type architectures, but honestly, in any kind of architecture you might have. And of course, our last option is to just run an exact copy of this and here. But that gets pretty expensive because if we have a 100 applications with 10 servers, that means we need the same 1,000 servers in the data center as the cloud running at all times, and that gets expensive. So I hope that makes sense from a disaster recovery, business continuity planning. I hope it's actually making sense of why we're using these varied architectures like hybrid computing and or edge computing.
Okay, I've always loved the cloud computing disaster recovery options, just the ability to just create something and let it kind of almost happen automatically. I've always thought that was cool. But in any case, let's see if anybody has any questions. Reminding everyone now's a chance to ask questions on what we've discussed as it pertains to this Google Professional Cloud Architect curriculum in this course to prepare you for the Google Professional Cloud Architect exam. Not sure if any other questions popped in, but if they did, we're happy to address them. I'll give everybody a minute to do so. While we do, I want to remind everyone that we've got a completely free study guide that you can sign up for. Chris from my team will drop the link to that in the chat box. And basically, that link will basically give you about a 550-page book of notes to help you pass the exam that's going to go along with this completely free training. So go sign up for it. If you sign up, it may take 10 to 15 minutes to get an email to you. Please do note that. Thursday, we have a completely free webinar. And we'll go over how to become an architect. You can join us that as well. But also to let you know, remember I said today was going to be a big day. We've got about 70 minutes of content and a couple of labs. We wanted to start the week big. We wanted to go heavy Google. And then for the most part, everything else will be for 3 to 3.5 hours each day, other than most days. But we'll have a nice little fun lab on some simple things like creating an account and setting up a budget after we go over the content. So hope to see more of you. Ask some questions if you have them, and let's have some fun with this Google Professional Cloud Architect materials. While you're at it, please give me a hashtag GCP or a hashtag Google Professional Cloud Architect. And if you're having a good time, give it a like. Maybe subscribe to our channel and hit the bell. And I'd be curious to know where some of you are. If you have a chance, just let me know in the chat box where you're at. I know that some people are in certain parts of the world based upon names, but I'm always curious to know. Let me know. So there's no questions right now. So if you ask any questions after we start the next video, we'll just answer them then. So let's get back to the content, Chris. What we're going to do now is we're going to provide a high-level introductory overview of the Google Cloud services. And then what we're going to do is dive deeper in other sections on each of these main components that we'll be using in the Google Cloud. We want to make sure that you basically understand the primary services, what they are. In many cases, we'll compare them to other services from other cloud providers to help you in your multi-cloud knowledge as well. And we want to help make it easy for you to learn these services. And sometimes if you're familiar with them, we'll point it out over here. It'll automatically make sense. And then when we dive deeper, then you'll learn the Google specificness of the way they implement these various services that have been around in pretty much every data center and every cloud provider. So that's what we're going to talk about in this section. Now, understand if you're a cloud architect or a solutions architect or any architect for that matter, we're most likely going to be dealing with multi-cloud environments. 98% of enterprises, those are Oracle's numbers, and they're pretty accurate. So most cases we're dealing with multi-cloud. And that's where we're going to try to introduce these at a high level first. The first thing we're going to introduce is something called Compute Engine in Google. And Compute Engine is nothing more than a virtual machine. It is infrastructure as a service, and it is virtual machines. So it's not going to be any different than the AWS EC2 instance, the Azure virtual machine, the Oracle virtual machine. It'll be like any other virtual machine that we would deal with, where we can get a predefined virtual machine, typically speaking from a cloud provider. We can basically take this virtual machine, install anything we want on this virtual machine, just like the same virtual machines VMware invented in 1999, that hypervisor that we've been using in the data center for decades. This is the same thing, but it's the cloud provider's hypervisor.
The next thing that we're going to talk about is something that's platform as a service from a compute perspective, and it's Google App Engine. Again, we're just introducing them now. And the point here is that it's a serverless application platform for deploying applications. So all that's really necessary is the developer has to write their code, they upload the code, and then it's going to run in this application virtualization environment on the cloud provider. The developers can write in Go or Ruby or PHP or Java or Node.js or Python or C# or .NET. It's pretty flexible with regards to the programming language. The developer uploads that code and the infrastructure is provisioned and is there and it's automatically waiting for you. Application virtualization. You might think of AWS Elastic Beanstalk. It's something fairly similar. Now, you're also going to understand that one of the ways we deal with compute could be in a containerized environment. And Google has a fully managed Kubernetes environment available for you. It's a platform as a service, a Kubernetes control plane that's pre-set up and pre-managed. And this is an enterprise-ready containerized solution. There'll be pre-built deployment templates. It'll simplify licensing. It'll consolidate billing. There's all kinds of great things with this. There's also some architectural challenge with this. For example, if your control plane is Google and your other systems are on AWS and your data center and Google goes down, you lost your control plane across other cloud providers. But this is a platform as a service ready option for you. Whether the business can use something like this or they have to use something like IBM OpenShift or Red Hat OpenShift will be based upon business needs. But the Google Kubernetes engine is very similar to the AWS Elastic Kubernetes service or the Azure Kubernetes service as basically managed Kubernetes where the provider is doing the management of it for you. So with Google Kubernetes engine, we're typically going to have the same master nodes that we would have anywhere because we're dealing with the same Kubernetes that we always have. It's just going to be managed for you. So we'll have the API server that handles all the Kubernetes API requests. We'll have the controller manager, for example, that will monitor and maintain the cluster state. We'll have the scheduler that will assign workloads to pods and worker nodes. And of course, we'll have that eti.d that's going to store the cluster data, if you will, and other things. We'll have the worker nodes, like which is where the application is going to be running, which means we'll have the kubelet, which manages communication with the master node and runs the pod. We'll have some kind of container runtime module like Docker or Containerd on the worker nodes to make them run. And we'll typically have some kind of a kube proxy to manage the network communications. And this is going to be managed for you. And that's the strategic advantage of these types of services as they are managed. But we also have to understand that there's going to be some various complexities that are going to be associated by only dealing with a control plane from a single provider. But I'll show you what it could look like so you can understand it. Here's your high-level Kubernetes overview. You have the control plane that's basically dealing with everything that needs to occur. And then you have the data plane, which is the work is done, which is on these nodes themselves. The next type of compute option we have in Google is something called Cloud Run. And that's another platform as a service offering, which means it's fully managed compute. So you don't have to think about managing the infrastructure, managing the number of servers you need. You're paying for the resources that you use. And this is where you're going to be able to put up, standard containers, standard type software. And it's a lot like the AWS Fargate. So instead of hosting it on a virtual machine, now you're hosting these containers in a fully managed environment for you. So you might use Kubernetes as a control plane normally, and then host your containers on a virtual machine. And you could do that in any cloud, or you can use Kubernetes as your control plane. And here you can use Cloud Run to run your servers on. In the same way, you could use Kubernetes with the AWS Kubernetes service, the Elastic Kubernetes service, and Fargate to host your containers. It's the same concept we're talking about across clouds. The next option of compute we typically have in cloud computing is something called function as a service. This is a little piece of code that you upload and it's going to run on a server somewhere. You just don't know which server where, and you don't have to worry about it. So we typically use these functions that if this happens, do something else. So they're typically great for light workloads, sporadic workloads, things that don't happen quickly. For example, if somebody puts an object into object storage, whether you call it cloud storage, and set the permissions to public or open, you could do that on AWS, Azure, or Google, and immediately cause a privacy issue. So you could have a Lambda function or an Azure function or a Google function monitoring something that looks like that and immediately responding and fixing the permissions for you so you don't have a security breach. That's typically called an event-driven architecture or an event-driven compute platform, allowing code to be run on a server where you don't know which server it's run, because all that abstraction is done for you by the cloud provider. You use functions as a service, scale up, scale down anytime you want. Again, Lambda function, Azure function, Google function, function as a service, which can also be done in Nutanix Cloud, OpenStack Cloud, that kind of thing. So storage solutions in the cloud, just like any other data center, a cloud's going to have storage. So what does that mean? We'll have object storage, for example, which is just like we would in the data center, and Google calls it cloud storage. It's the same as AWS S3 or Azure Blob. It is object storage. So we can do all the same things with the Google Cloud. We can set up for lifecycle management, cost optimization, where we're going to move it to the right storage tier. For example, we can use object storage for backup and archival purposes, typically speaking, software distribution. So Google, for their object storage, has various levels of availability for that. Anything from 99%, which is not exactly high availability storage, all the way to 99.95, which is getting into moderately high availability storage environments. Now, we also have something called Cloud Firestore. And what is that? It's file storage. So no different than any other file service that we've worked with in an environment. But it is a hosted and managed file server. So you don't have to set up and manage your own server. So normally speaking, what you would do is if you had Linux, you'd set up a server, you'd create an NFS share, and you'd have to manage all of that stuff and manage the servers and the drives on that server. In this particular case, it is very similar where the provider has a server for you, and all you do is create a share and it is on their fully managed servers. So that's typically speaking file storage that you could use. And it's basically network attached storage. And of course, you can use it and attach it to virtual machines if you've got a lot of virtual machines that need access to the same data at the same time. So again, file storage, no different than NFS you would use in your data center. AWS has their elastic file storage, or you could set up your own file server and share the drive. It's the same kind of thing that we're dealing about. Now, we also have something called the persistent disk in Google. And a persistent disk is block storage. And we're always going to be using block storage as a virtual hard drive in cloud computing. So they call it persistent disk. AWS calls it elastic block storage. Who cares? It's all block storage. It works the same way all block storage environments do in all data centers for the last few decades. Now, of course, when it comes to block storage environments, they can be based on magnetic hard drives, SSD drives, or NVMe drives, and that will determine its performance. But this is just going to be any type of virtual machine type storage where it's block storage. You can resize on demand. You can back up your storage volume into an image, traditional block storage used by virtual machines in the data center, now used in the Google Cloud. You can attach it to a Google Compute Engine or instances or any of your Kubernetes pod instances you would be using as well. Now, we're going to have multiple storage options there, which we'll get to at some point during the program. Google has a bunch of databases that they've made for themselves. One of them is Cloud Bigtable. And what is Cloud Bigtable? It is a fully managed Google NoSQL database that can handle millions of requests per second and provide consistent sub 10 millisecond latency. So where would you use a big NoSQL database? You typically use it on many environments where you need with scalability and unstructured data. For example, storing where you're at in a video game or a player could be in environments, social media environments. You could be using wide varieties of NoSQL databases, massively scalable databases. And if you really look at it, it is the Google version. And it integrates relatively easy with the Apache Cassandra ecosystem, which is a great thing. So you may hear of Microsoft has Cosmos, Amazon has DynamoDB, and Google has Cloud Bigtable. Now, if you're in 3 clouds, maybe you're better off using MongoDB, for example, or Apache Cassandra, because that's going to better fit in your 3-cloud multi-cloud environment. But this is the Google hosted. Basically, they run things, and all you have to worry about is you and your data. Now, the same we can talk about is Cloud SQL. They are fully managed relational databases on the cloud. And they support many of the databases you typically would think of, MySQL, PostgreSQL, SQL Server, that kind of thing. And that's going to make it relatively easy because these are standard relational databases. And this is very similar to any other cloud provider's database management systems. AWS calls it RDS, Relational Database Service. Same thing we're talking about here. Now, we can also talk about Cloud Spanner. Cloud Spanner is going to be a fully managed, scalable relational database maintained by Google. They support regional and global distribution of application data. It provides a good, strong relational database structure and horizontal scalability. Yeah, because it's a relational database, it's got strongly consistent reads, and it typically flows with the rows and column type environment that you typically think with any other relational database. Very structured. Now, when we're dealing with here, you've got something that's going to give you good features, type functionality, typically a little better than what you get out of one of the freeware databases. These are typically a little less than what you would typically get out of, say, an Oracle database, which is a paid database. But Google's got a lot of expertise as it pertains to databases. So it's a great relational database, but remember, 98% of organizations are multi-cloud. So using Amazon Aurora, it's the same kind of concept. It might lock you into challenges later. So keep that in the back of your mind. If you're going to be in multi-clouds, which you most likely will be, use something that works in all clouds. Now, Google also has something called Cloud Firestore. That is another fully managed serverless NoSQL document database that you don't have to think about, designed for mobile, web, and IoT applications. So it typically has great scaling capabilities. And it's kind of the next generation of data store, if you want to look at it that way. It's got good availability at 99.999%. And again, this is going back to an Amazon DynamoDB kind of thing, Microsoft Cosmos kind of thing. So while Firestore is more optimized for mobile applications where Bigtable is more analytical workloads. But here's the thing. If we use these, what's going to happen in multi-cloud? There's non-proprietary databases we can use in all clouds. Now, when it comes to databases, we often need caching to improve our performance, scalability, that kind of thing. So we typically use a cache. And when it comes to caching, we're typically using one of two kinds of caches, either a Memcache cache or a Reddit cache. And what are we dealing with here? Google's memory store is a hosted cache, which you can use with a Redis cache or Memcache. So realistically speaking, pre-made cache that you can use, 99.9% availability, which is a pretty strong SLA for a cache. And you may hear of Amazon Elasticache. Same thing that we're trying to deal with in that environment. Now, Google has a great data warehouse solution called BigQuery. It's serverless, it's highly scalable, it's relatively cost effective, it's great at big petabyte scale data. There's not a lot of operational overhead. And it's based on Google's Dremel query engine. It's got good availability, 99.9% available, and it's unique in the industry. This is pretty much unique to itself. It is a data warehouse. Now, AWS does have their data warehouse that they also have, but this is a big data warehouse and an analytics solution. So it's a little different than the others, but very similar to the AWS. Drawing a blank on, I can't think of the AWS data warehouse name right now, but that's what we're really talking about. Again, There are data warehouses like Postgres, which we can put in every single data center and every single cloud. So we have to think about it. Now, when it comes to big data environments, we're going to be working with data, mapping it, reducing it, changing it, cleaning it up, and lots of things. So we typically need some tools for that. Google has a tool called DataProp. It's very similar to AWS's Elastic Map Reduce and AWS Batch. It's a fully managed Apache Spark, Hadoop, Presto, and other big open source big data environments. But in this case, you're not running your own servers. You're basically paying when you're using it. It's pay as you go per second pricing, fully managed for you. Now, we also have Dataflow, which is going to be a serverless stream and batch data processing service. I hope you're already thinking of the other clouds and what they already do. And basically, you're dealing with streaming data. So typically speaking, in a multi-cloud environment where we can't use anything proprietary, we have Apache Kafka here. But this is very similar to Amazon Kinesis that we're talking about when we talk about Dataflow. Now, we have to be able to deal with messaging type systems and event messaging type systems and queuing systems. So, we've got these pub sub messaging environments. And of course, Google has one too. They call it pub sub. There's no provisioning required because it's managed for you. It's available 99.95% of the time from an SLA perspective. And it's going to sound a lot like Amazon SQS and SNS, those types of environments. Now, Google gives us some data analytics solutions, which is great. There's something called Cloud Composer, which is a fully managed workflow orchestration service. It's built on Apache Airflow. It simplifies the orchestration of authoring, scheduling, and monitoring pipelines across your clouds and your on-premise environments. It's going to feel a lot like AWS Data Pipeline and to some degree AWS Glue. Now, we're going to be dealing with, let's talk about how the cloud is laid off. So generally speaking, anything in Google Cloud, you have the ability to reach it globally, assuming you set up the networking correctly. And what we have is we have an environment where we have regions, which are big geographic areas. And then what we'll have is zones, which are little data centers inside of these areas. So that may sound fairly environment to you, simple and fairly familiar to other cloud environments with you that we're dealing with this. And I'll show you a visual representation of what we're actually talking about here. So normally speaking, you might have a large geographic area. And this is, in the blue is the entire Google Cloud. You'll have a region, which is going to be maybe like the US or a continent or half of a continent. And then we'll have these little zones, which are data centers inside of those. So think about the Google platform being the entire environment, the region being a big geography, and a zone being a data. Look at AWS availability zone. I think Azure calls them availability zones as well. So that's typically what we're talking about. So you understand the way the cloud's laid out. And we will typically have something called a virtual private cloud, which the virtual private cloud is going to be our virtual private data center. We'll get our own virtualized network environment, which will come with virtual routers, which will give us things like the ability to create ACLs and packet filters. Inside of these environments, we will create our subnets. We will put our servers. So we'll set up our own virtual private data center. And they call it a virtual private cloud. AWS calls it a virtual private cloud. Azure calls it a virtual network VNet. I like to call it my virtual private data center because that's realistically speaking what we're talking about. Let's talk about some other networking solutions provided by Google. They provide DNS services for you, fully managed DNS. And they've got reliable, low latency DNS services. Google is known for high availability and great DNS services. Typically, they use Anycast, and you'll see their DNS servers is 8.8.8.8. They might even be on your computer because so many people use Google's DNS. But this is a hosted, fully managed DNS service for you. They call it Cloud DNS. Very similar to AWS Route 53. It's just managed DNS service for you. Now, we're now going to talk about VPC flow logs. So We may want to see how traffic is going from point A to point B in our network, which packets are getting filtered, which packets are not. And in the old days in our data centers, we'd use about 20 years ago, Cisco had something called NetFlow. And it would give you good information about your network traveling through your environment. We used it for network monitoring, forensics, security analysis, cost optimization, figuring out what was going on in our network. Guess what? We can use it on the cloud. We get what's called VPC flow logs. We can analyze this. Now on the cloud, we're going to pay for it, and it's going to get expensive pretty fast. So we don't want to leave it on all the time. Typically speaking, we want to use it when we need it. Not always, but generally speaking, we want to use it when we need it. But in the data center, it's free. So understand, if we are hosted on the cloud versus a data center, we're going to pay heavily to get these types of things. Now, we also have some other networking solutions from Google. We have the Cloud Firewall, which is actually a great next generation firewall. They've gone so far to use the Palo Alto intrusion detection and intrusion prevention systems, which is absolutely fantastic. It'll allow or deny connections based upon deployed rules. It's obviously stateful, and we can configure any kind of good next generation firewall options with this. Here's the problem. We're going to typically dealing with a multi-cloud architecture, and it's going to be very hard managing different firewall platforms. And if we use something like a Palo Alto firewall, a Cisco firewall, a Checkpoint firewall, or a Fortinet firewall, we can put them in all clouds and we don't have any of these interoperability issues. But if we're only on the Google Cloud, that cloud firewall is an excellent firewall for cloud computing. And we also will need content delivery networks, and there's a wide variety of them out there. Akamai is a huge player in the content delivery network space. Cloudflare is a huge player in the content delivery space. All the cloud providers have their own content delivery network. For example, AWS has CloudFront. Fastly is another content delivery network provider, and you typically need more than one content delivery network in very high availability systems. But a content delivery network is going to be a network of caching servers and a network and caching servers that's going to push your content to the edge of the systems. And that is going to cache content at the edge, which will typically enhance the scalability of your systems. It will reduce the workload on your systems. It will reduce the latency to your customers. And content delivery networks give us great options to protect against distributed denial of service attacks by blocking illegitimate requests at the edge of the network. So lots of content delivery networks that exist out there. Google's is called the Cloud Content Delivery Network. Amazon's is called CloudFront. And then there are much bigger content delivery networks that have much more points of presence throughout the world, like Akamai. Now, when it comes to any data center, we're going to need load balancers. Guess what? In the cloud, we need the same load balancers. In the data center, they're physical load balancers. We often get them from F5. In the cloud, we use the cloud providers. So Google has the Cloud Load Balancing Service. And that is a fully distributed, high-performance, scalable load balancing service. It offers Anycast IP for global backend instances to support HTTPS, TCP, SSL, TLS-based traffic, UDP traffic-based load balancing. It can handle multi-region failovers and internal load balancing. So a lot of load balancing features that you've got. Cloud load balancing. Google also has NAT. In many cases, in an organization, we're going to have to take our internal private IP addresses and translate them into public IP addresses. We typically do them on a router or a firewall in a port overload address translation manner. And Google has a fully managed NAT service for you to use that's managed on translation of your addresses. It enables you to keep applications that don't have public IP addresses to go out to the internet and update their operating system or patch themselves without being reachable from the internet. And that's the key. It enables you to go out to the internet to update your systems, but you're not reachable. So it's like an AWS NAT gateway, of course, firewall, if you could do NAT with as well. So we're going to talk about Cloud VPN. And a Cloud VPN is basically creating a VPN to connect either your on-premise environment to the cloud or connect to AWS Cloud to the Google Cloud over an IPsec tunnel, for example, over the internet. Now, the key is VPNs don't get that fast with the cloud providers. Our IPsec tunnels can give us up to 3 gigabit a second, which is pretty good, but not super fast. If we need 10 gigs or 100 gigs or something better, we're going to have to use a private line. But this is just an IPsec VPN. AWS has something called the AWS Cloud Client VPN. It's pretty much the same environment. And we'll talk deeper about most of these things throughout this program. We also have a cloud interconnect, and what that really is a private line between you and the cloud provider. That's it. And you can get a dedicated interconnect, as they would call it, or a cloud interconnect, and it is a private line to the cloud provider. That's all it really is. If you need, you can get it to directly from a service provider like AT&T or Verizon. You can also go through a third-party port, or typically speaking like Megaport, to go to these various cloud providers. And there's lots of third-party providers. The service level agreement we would get will be based upon the connection type. But here's what I want you to understand. When we use the internet for a VPN, we have no guarantees of performance because there's no guarantees of performance over the internet. When we use cloud interconnect, it changes a lot of things. And the reason it changes a lot of things is it's a private line. So it's going to give us guaranteed performance. So if you want to think about AWS Direct Connect, if you want to think about Azure Express Route, this cloud interconnect, this dedicated interconnect, is the same thing that we're talking about. Let's talk about some networking solutions in the Google Cloud. Typically speaking, we're going to have something called peering. And peering is when you connect one network, basically speaking, to another network. And you can use direct peering where you peer to them. And there's also called carrier peering. But what we're really doing is getting you access to the Google Cloud where you're going to exchange routing information, typically speaking via BGP. We can also connect various VPCs together for an environment. So what do we mean by that? We might have, for example, two different VPCs, VPC-A and VPC-B. And we might want them to be able to talk to each other. Now, there's two ways this could occur. One way is let's pretend this was the internet. We don't want to do this, and I'll talk about why. One way is we could take our traffic, leave our environment, go out to the internet, cross the internet, and then go back to the next VPC and obviously do encryption and everything that's necessary. But here's the thing. In order to do this, we had to leave the cloud provider's network, go to the internet, come back from the internet onto the cloud. Now, we're already, and there's no guarantees of performance on the internet, but we're already on the cloud provider. So VPC peering basically creates a private networking connection between two of your VPCs and the environment. And that's what your VPC network peering is enabling you to do. So in this peering environment, you can use private IP addressing. You're not using the public internet. You've got greater security by avoiding the public internet. You can still encrypt it. You've got reduced latency. And in some cases, you've reduced your egress fees depending upon what's being billed by the cloud provider at the time. They're always changing these things. And we have some private Google Access options as well. For example, we can keep our virtual machines with internal IPs and they can still access Google services, which is great. They don't have to go to the internet to access Google services. We can have Google access to on-premise hosts if we've got a connection between us in a good networking environment. We can keep our VPC networks and connect them to other Google services. So we've got a lot of abilities with networking on Google like we do any cloud provider, because what is a cloud? Renting space in someone else's network and a data center.
Welcome back, everyone. We are here. Admittedly, I know this is a long intro to what is cloud computing, but we really wanted to give you a kickoff at a high level of Google services. And then we'll spend the next kind of 2 weeks diving deeper into these concepts to make sure you can easily pass the Google Professional Cloud Architect certification and understand this material. So that's what we're doing so far. Bear with us. We've got another fairly long video. And after that, we've got a couple of very soft, fun labs like creating an account and creating a budget. So that's what we have. I think I saw maybe 1 or 2 questions pop in. I'll address them and then we'll get back to the content. I want to remind everyone that tomorrow we should be starting with identity and access management. The day after that, for the next 2 days, we'll have some fun in networking. I absolutely love networking. Without networking, nothing works, and networking is important. So we'll spend a couple days on networking, and then we'll do compute on Friday, where we'll dive deeper into the options that are available on the Google Cloud. So we have lots and lots of fun stuff coming. So Chris, I think I saw maybe 1 or 2 questions that popped in, and I want to make sure I address them. I think there was one. And I think it was from Devel. So, okay, so the question was from Darnell, and he said, besides the boot camp, what other resources would I recommend for the Google Professional Cloud Architect exam? Now, Darnell, I have to say, I really like this book from Cybex. I can tell you that when I took the Google Professional Cloud Architect certification, well, 2 things. One is obvious. I've been in cloud computing since I've worked with cloud since 1993. So there was nothing new about cloud computing, but I was able to take my cloud computing expertise and designing clouds for enterprises for decades, decided to say, hey, I wanted to see what a cloud certification would be like, bought this book, and shortly after took this Google Professional Cloud Architect exam, and it was very straightforward. So I do like that book. I could generally recommend a practice exam as well, but generally speaking, I do like that book. I would take our course. I would use that book. The book is the official curriculum from Google. What we're doing is fairly similar as well, but we're starting from the top at a high level, and then we're diving deep into everything else as we go along. But I definitely do like that Cybex official Google Cloud Certified Professional Cloud Architect certification book. Very much so. And right after we do the next video, we will Leo will be demonstrating how to create a budget, for example, and how to set up your account. So make sure you stick around. Give me a hashtag Google Professional Cloud Architect or something like that, so that I know you're here in the chat box. Maybe if you're having a good time, give it a like, subscribe to the video, hit the bell to be notified of new stuff for your architecture career. And Chris, let's go back to the content.
Continuing our high-level overview of the Google Cloud and its services, we're going to get into logging. So we have to be able to run our systems, and logging is going to be a critical component of it. So Google has a logging component called cloud logging, and in many cases, the Google convention is stick the word cloud in front of something. So that may help you on an exam. So cloud logging is going to be a real-time log management and log analysis tool. And it enables people that are using the Google Cloud to store, search, analyze, monitor, and even alert based upon logs. We can, with cloud logging, ingest custom logs from any kind of source that we might ever want. And it's a fully managed service, so there's going to be nothing to manage, things like servers, etc. And we can integrate cloud monitoring with other services. So it's going to help us get a lot of information, which we could then use to see what's going on with our systems, track the health of our systems. Now, in AWS, you have something very similar called CloudWatch logs. And quite frankly, in any data center, we've had logging for the last 50 years or so. But cloud logging is going to be very similar to CloudWatch logs. Now, we're also going to have this concept of cloud monitoring, and that's a full stack, fully managed monitoring solution. So it gives us the ability to get visibility into performance, uptime, and the health of our applications, and get custom metrics and business alerts. So that's going to sound a lot like AWS CloudWatch monitoring to you, because it is, and all these solutions are going to sound very similar. Now, we have the concept of cloud trays. So when we're working in the cloud, we've got these distributed applications that are everywhere. And when things don't perform well in a distributed environment, it becomes very hard to actually see what's the actual cause of the problem. And that's where we're really coming up with this concept of cloud trace. And it's going to be a distinguished distributed tracing service. So it's going to give us the health. So we're going to be able to look into our environment and collect latency data from our application, track requests from various parts of the application through the journey. We'll be able to get some in-depth latency reports, and with that, we'll be able to identify some performance issues, and we can work across virtual machines, containers, and other types of projects. So if you really look at what's going on with cloud trace, it's enabling you to look in your environment to see performance problems. Kind of like a medical professional would use an X-ray. And actually, Amazon named their version of this service AWS X-ray. And it's about the ability to really look in and see what's wrong, seeing how to solve problems. Now, the Google Cloud is one of the most developer-friendly things you could possibly imagine, and they enable you to interact with the Google Cloud very easily. Obviously, there's a management type console, there's a command line interface you can use, but you can also connect via the software development kit. And you can do some of these things via the command line this way as well, but you can also use code. And the point is here is you can, in whether it's Java, Python, Node.js, Ruby, Go, .NET, PHP, you can use one of these languages. The developers can use one of these languages to interact with the Google Cloud environment. And this enables much more simplified management and things along the way. So that's one of the things that are typically going to be pretty great that we're actually dealing with here, is the ability to be able to go in there and really be able to see what's going on and be able to interact with the cloud in a much easier manner, because we don't want to be interacting with it via the clicking boxes on a management console. It's just not going to be efficient. So let's talk about some more developer tools in Google, where we're going to have cloud source repositories. And what is that? Where do you store your code in these things? It's going to be a private Git repository service. So cloud source repositories, think private Git. And you can use this to develop and design and securely manage your code. You can store it in Git. You can extend the Git workflow by connecting to various tools like publisher subscriber messaging, cloud monitoring, and cloud logging. We can mirror code from, say, GitHub or Bitbucket, and we've got some fairly powerful code search, browsing, and diagnostic tools that is actually coming with these cloud source repositories, because it's Git. And we can, of course, use regular expressions to search across directories and do any of the things we could in a normal Git type environment. So it explains to you what it actually is. Now, at some point, we may need to keep track of all the containers we have. So, of course, you need some form of container registry service. And what we're dealing with is it's basically a private Docker repository, which is going to enable you to store, manage, and secure your container images. You may want to perform vulnerability analysis on your container images. You may want to manage access control to see who can even access various container images. And you may want to integrate your container management with your CI/CD pipeline for automated Docker pipelines. And in order to do that, you're going to need some form of registry that kind of keeps track of all this thing. So that's what we're talking about with container registry. Now, there's a concept of JFrog, Artifactory, and Amazon has the Elastic Compute Registry. Or the Elastic Container Registry. That's what we're really talking about, just a registry of your containers. So there's other environments and things we want to talk about as well. I want to really talk about Google Anthos a little bit. And Google Anthos is a managed platform that's going to help organizations really manage their applications across the reality of today's world, which is hybrid and multi-cloud environments. So Anthos streamlines deployment. It helps with management and operation of containerized applications because it's using Kubernetes service mesh, which works across all clouds. And it's designed to meet hybrid and multi-cloud platform as a service requirements. It gets you out of that vendor lock-in by using any kind of proprietary anything. And it enables running, managing, and even governing applications across multiple clouds and hybrid clouds. So that's typically what we're talking about Anthos. So there's a couple of things we'll talk about Anthos and its key components. We have the Anthos Google Kubernetes environment. And what that does is it's going to be an enterprise-grade container orchestration and management platform because it's Kubernetes. And it's going to support the deployment in both cloud and on-premise because it's Kubernetes. So we have the concept of Anthos configuration management, and that's going to govern configuration policies across different environments. So you can determine how you want things configured and you can enforce it. We also have this concept of this Anthos service mesh, and it's powered by Isoflow, and it's not actually made by Google, and it provides a service mesh architecture. It makes networking fairly easy and the routing of your traffic back and forth. It uses mutual tunnel transport layer security. So you can think of it as MTLS in order to secure this service mesh and the end user components. So we're going to have that layer of encryption, and it's going to be done, it's TLS encryption, and it's going to simplify any kind of role-based or fine-grained access controls. And of course, with Anthos, we can define some security controls across our environments as well. So it gives us the ability to control a lot of things in a multi-cloud or a hybrid multi-cloud environment, which is the reality for today's compute world, especially cloud computing world. Now, how do we get our data to the Google Cloud? Well, obviously, if we've got a wire or a private line or a direct interconnect, we've got a wire to push it on. If we have an IPsec tunnel and we have enough time, we can push it over the IPsec tunnel or the VPN to the cloud provider. But what if we don't have the biggest network bandwidth to the cloud provider, or what if the connections we have are fully used? We still have to get our data to the cloud provider, and here's where we get into the storage transfer service. And what it really is it makes it easy for you to take your data from the data center and transport it over your wide area network to the cloud provider. So if you've got a lot of data to move, there's lots of ways to do it, and this can be done fairly easily with the storage transfer service. Basically, what's happening is that you're going to use your network, you're going to connect to the Google network, and it's going to help you transfer your data. You could deal with petabyte scale data transfers here. And, this is one of the ways we can use the wide area network to get our data from point A to point B, assuming we've got a good network and we've got good bandwidth. If we don't have it, it's not going to work, and we're going to have to do something different, like use a transfer appliance, which we'll talk about shortly. But this is the ability to synchronize your data in two places over your wide area network. AWS has a similar service called DataSync. So if you've got the network bandwidth and you've got the time, you can just simply send your data over to the cloud, over the network. But what if you don't have a lot of time? What if you've got to move things quickly, or you don't have a big network connection? Well, this brings us into the world where how do you get your data to the cloud? Well, you take your data, you copy it onto a device, and basically the device gets shipped to Google Cloud, and the Google employees put it back in your environment. So we have this concept of a transfer appliance. It's going to sound a lot like the AWS Snowball, because it is. And basically what it is going to be a ruggedized computer and a whole bunch of hard drives with high-speed networking. And what you're going to do is you're going to send your data to this device and ship it back to Google. So very similar to, again, AWS Snowball. Now, the next thing we're going to talk about is the cloud asset inventory. So you need to know what systems you have. And hopefully you've got a great set of architectural documents and you've got a really strong architectural repository. You understand what you have as-built drawings, you've got documentation that explains everything. But in many cases, organizations don't. And Google has this cloud asset inventory. And what it does is it audits metadata about your stuff. So it will view, monitor, and analyze all of your resources and policies. It will give you the entire inventory of what you have. It'll give you changes and give you real-time notifications for things that are changing in your environment. And it can help sift through your IAM policies. Remember, IAM is determining who you are, what you're allowed to do, and keeping track of it, and making sure you don't have to do things that you're not supposed to. So we get a lot of information out of the cloud asset inventory. It's pulling the metadata of various services that you have. So it's going to feel very similar to AWS config. And it's going to give you information about what you have and then make it easier for you to do things. So let's talk about the Security Command Center. And Google has its Security Command Center. And basically that's going to be a security management platform and a data risk reduction platform. And what it's going to do is it's going to give you some straightforward views and inventories of your cloud security vulnerabilities, any kind of threats or compliance issues that it sees. Now, remember, this is an automated tool, so what it sees may or may not be correct, but it's going to give you good information nonetheless. And then you can verify that information as valid or non-valid. So it includes a suite of tools and capabilities that are only going to be available in the premium version. It will give you some security health analytics, which will really scan for security misconfigurations and compliance violations. It will give you some event threat detection, so it's going to use Google's threat intelligence engine for log-based threat detection. So it's going to look at logs and determine if it sees a problem. It's going to do some web security scans that can identify some common web-based vulnerabilities on publicly facing, well, let's say endpoints, if you will. And it can kind of give you some information on what it finds. And, this kind of information, all this information from the security center that it's giving us is pretty valuable because we've got some information about configurations or misconfigurations or compliance violations, which may or may not be right, but at least it gives us something to look for. It gives us information for things that it thinks may be a problem, and it's scanning things. So good tool here. Now, companies may have their own tools that they choose to use, but this is a Google version of a tool. But the point is now you're collecting lots of information. You can send it to your SIEM systems, your security event monitoring systems, and they can be monitoring these logs, other logs, and all of a sudden it notices an event occurs, and and they can correlate that event for you. So lots of great things that come out of this. Now, when it comes to identity and access management in any kind of security, it's really about, is the right user using the system? Who are they? Which we have to authenticate them. We have to authorize them. Okay, Mike can access this, but Mike can't access this. And then we have to track or log what we've done for accounting or auditing. And this brings us into cloud audit logs. And what it is an activity visibility service. It's going to tell you who's using the Google Cloud, the kind of things they did, any administrative actions like launch a machine, delete something, that kind of thing. And it's going to be immutable, always on trail. So you're always going to know what's happened. And this way, someone can't delete something and say, I didn't do it. And this is going to be great for incident management. It's going to be a critical part of auditing our accounts and auditing our systems, which is a critical component of security. And this is the Google Cloud auditing log. So it's called it's called Cloud Audit Logs. Now, if you're familiar with AWS, you may have heard of AWS CloudTrail. Same kind of thing. These things have been around for decades because IAM's been around for decades too. So now we have our environment. We've talked about some more environments. Now you'll recall that a VPC is basically your virtual private data center. And in a data center, you want a security perimeter, right? So what we have here is we have these VPC service controls, and they can help you create a security perimeter. And it will constrain some of your things like cloud storage, cloud bigtable, BigQuery, and it keeps your data from leaving your VPC. So it's going to ensure that data is not exfiltrated in case you maybe had a misconfigured access control. So it's going to enhance your security, and it's going to provide some data loss protection to make sure critical data doesn't leave your system. Now let's talk about data loss prevention. Again, there's going to be industrial tools we can use across all our cloud providers, but Google has some data loss prevention tools. And the Google data loss prevention tool is called the Cloud Data Loss Prevention. And it's going to be a managed data protection service. And it's going to feature a lot of things that will discover and classify and even protect sensitive data. It can support deauthentication messages for streaming and stored data. It can constantly scan the environment for things that don't meet the classification requirements. So it's a good data loss prevention tool. Now, if you're in 3 clouds, it's going to be hard to deal with 3 different data loss prevention tools. You may need one tool that you put on all clouds. But if we were just in the Google Cloud, and again, this is a Google certification, they have to tell you, and you have to get certified on knowing what their tools are. Whether you use them or not is going to be another service. Now, anytime we're dealing with security and privacy, at some point along the line, we need encryption. And part of encryption is to basically have an encryption key and a decryption key, so to speak, and that way, and to be able to understand the message. So if I've got a message that's encrypted and you need the secret decoder key in order to be able to decrypt that message, if you don't have it, you can't access it, which is great. But you're also going to need a key management service to make sure that the right people have the keys and nobody else has the keys. Keep track of the keys, rotate the keys, and store the keys in a secure management. So there are lots of great cryptographic key management systems that exist out there. And the reality is in multi-clouds, you're probably going to need a more industrial system. But Google has a very good cloud key management system. It is an excellent key management system. And it enables you to manage your keys. It'll manage the encryption keys for sensitive data. It'll support customer managed encryption keys for customer supplied encryption keys. It integrates with the cloud hardware security module for FIPS 140-2 level 3 device protection. So good, strong encryption. Now, sometimes we need a hardware encryption tools as well. So this brings us into the cloud HSM. And this is going to be a managed hardware security module. And the reason we're going to use this or might use a hardware device is it will protect our cryptographic keys, and it will keep them in a FIPS 140-2 level 3 certified hardware security module. So it's going to be good security this provides. And being able to keep your keys private and store them is going to be absolutely critical to ensure compliance for things like financial services and healthcare. And the cloud HSM can integrate into the cloud key management system. And you're going to pay as you use it, pay as you go. Again, this is a great tool. Now, in multi-cloud, we might use a more industrial tool, but again, this is a good tool, and it's going to be part of the exam. So how might you interact with the Google Cloud? Well, there's going to be a couple of ways you can do it. You can use the Google Cloud Console, which is basically a web-based interface where you can click a few boxes and it gets it done. So that's going to be one way that you can actually do it. Now, of course, you can SSH to various tools if they're accessible to your private network or in the internet based upon how it's set up. So you'll be able to deal with certain things as well. But, you can use the web browser-based console. You can also use the command line. And the command line will make it very easy by comparison for you to get things done, assuming you know and understand the command line. So kind of keep this up. Now, Google Cloud has got a couple of different command lines. They've got the G Cloud command line, which is a primary tool for creating and managing resources. They have a BQ, which is a BigQuery command line if you were going to be using the proprietary database. We have the CBL, which is the Cloud Bigtable command line if you're going to use the Google NoSQL database. And we have GSUtil, which is the Google Cloud Storage command line tool. And of course, we've got the Cube CLI, and that's going to be the Kubernetes command line tool. So you can click a lot of boxes on a website, which is going to take forever, or your cloud engineers can use a command line, which is going to make it very easy. Now, of course, we can also push things over APIs and client libraries as well. And we can push things through Google Cloud APIs as well. We can connect to application APIs to provide services and various things. And of course, there's going to be administrative APIs. So when we talk about APIs, these are going to be programming interfaces to be able to access one system to another system. And there'll be a lot of that in Google Cloud as well as other things. So these are typically speaking what we're really dealing with when intro to Google Cloud. Now, we're going to be discussing cloud architecture, and this is a cloud architecture exam, and there's a little bit of architecture in the Google Cloud. If you want to learn a lot more about what does a cloud architect do and the skills of the cloud architect, join us for a free webinar. We run one every single week on how to become an architect and all the skills you need. The link is going to be in the description of this video. But in this overview section, we're going to be talking about some cloud architect skills. And the key here, as an architect, your job is to drive business transformation for your client. What does that mean? We're here to make our client's business better. That's the whole point of the architect, is to enhance that business's efficiency. And what could that mean? It could be a hospital where a greater percentage of the patients leave the hospital without having a negative effect in the hospital, like an infection. That could be there. It could be an online retailer where we're trying to increase sales. It could be, how do we improve the employee productivity of a business? It could be any of these things. So the first thing that we typically need to do as architects is understand our client's goals. We typically need to understand the client's business processes or their business architecture. I've got videos on the YouTube channel on what is business architecture and how that and what that is, for example. Then we need to understand and baseline our client's current technology across all clouds to be able to see if it'll meet their future business goals. And if not, then we're going to need to create an architecture team to design the architectural strategy or the blueprint to get that client to their goals. Now, at some point, we're going to have to take that architecture, show it to various stakeholders across the organization, get their feedback, and redesign that architecture based on stakeholder feedback. We'll have to represent that architecture back to the client, get any feedback, tune the architecture several times in most architectures. At some point, we'll create a statement of work. We'll respond to any of RFIs, RFPs, RFQs, create a governance structure for the architecture, create a change management structure, and typically we architects go to a new one. So there's going to be a lot of skills related to business acumen, leadership, executive presence, emotional intelligence, executive communication skills, CXO, relevancy, sales skills that are going to be critical for the architect. And none of them are going to be covered in this course. But this is because it's a certification course, not what we do. And that's what we do in our 1,000-hour type training. But I want you to at least think about the skills you need, because they may ask about some of these skills on the architecture exam. So you have to be able to understand the client's business objectives. Business objectives are not just some tech thing. Business objectives are business goals, whatever they may be. And you as the cloud architect to be able to translate those business objectives and figure out what kind of technology solutions will get that business to its goal. So you're really aligning an organization's people, processes, and technology. Now, the architect has to be a trusted advisor. And what does that mean? It means you can't walk into a client and say, I'm excited about the Google stuff, and I got all this beautiful Google stuff for you. If you do, you're an enthusiast, and you are the most dangerous person in the world. And here's the reason. Imagine a doctor that only liked to prescribe Pfizer drugs. And every time they walked in a room, they prescribed Pfizer this, Pfizer that, Pfizer that. Now, Pfizer makes some great medications, but they don't make the entire pharmaceutical library of the entire world. And we need our doctors not to be biased by any pharmaceutical companies. And we need our architects to be biased on making our customers successful and not fall in love with any type of technology or any type of provider. So as architects, we have to be a trusted advisor. As strategists, we're really strategy consultants. Now, we have to convert the client's needs into a solution. And that solution will involve people, processes, technology. We'll have to build training plans as we design the architecture to get the customer to adopt it, and so much more. Now, the key is business, business, business. So if we walk into a client to enhance their business, and you don't know business, you're not going to be able to do anything about it. So, we train business on our clients. If not, you can get a master's in business administration and learn business, but you have to be able to understand an organization, understand business processes, understand business architecture, understand the business inputs and outputs, and understand the forces of business and how you can optimize them with and without technology. So that's going to be so important that you have to understand business skill, understand business. You're also going to have some extraordinarily good communication and collaboration skills, because in most cases, an architecture will take 6 to 12 months to design and take a team of 15 to 50 people. So we have to figure out what the organization is trying to achieve. Are they trying to increase sales? Are they trying to reduce patient deaths that are in a hospital? Are they trying to improve the customer experience? What is the actual goal? That is the most important. Now, let's talk about cloud migrations. Initially, we thought it was going to reduce client expenses. And part of your exam is it will make costs cheaper. In reality, it won't. And it's not going to make it cheaper, but that doesn't mean it's not worth it. Cloud computing is very agile. In the data center, I need to launch 100,000 servers. I've got to go buy them, rack them, stack them, put hypervisors on them, and do anything I want. I need 100,000 servers in the cloud. I can use, a DevOps engineer can use AI to create an infrastructure as code script, tune it, and then launch those 100,000 servers potentially in an hour or less. So from the time they decided to the time I started, assuming it's something very simple, and it's not going to be that simple, but it gives you the point. It's so agile. Now, one thing we have to definitely talk about is when we move to the cloud, we take what's usually considered a capital expense and it turns into an operational expense. So I'll explain to you what is a capital expense. A capital expense is something you purchase. An operational expense is something you have every single day or week or month or when the business is running. So you have an operational expense. Let's take it to your house and most people. If you bought a house, that was a capital expense. You bought that house and you didn't have to pay for it day one. You financed it. Now, you may have rented a property in your life, and that's going to be a capital expense. So it is what it is. Now, is a capital expense better than an operational expense? Sometimes, based on the organization's capital structure. Is an operational expense better than an organization's capital expense? Sometimes, based upon the organization's structure. So it's going to be based on debt and interest rates and financing and taxable situations. So don't just assume moving to the cloud, going from CapEx to OpEx is a good thing. It could be the worst thing in the world, or it could be the greatest thing in the world, but you need to know. But understand that there's different tax implications of CapEx and OpEx. For example, capital expenditures are typically depreciated, where operational expenses are typically written off, and all that needs to come into a tax. So understand that there's a shift in the way organizations actually pay for things and how it'll affect their balance sheet. Now, with the cloud, we have to understand it's going to be very expensive ongoing to maintain it. But we're not usually buying something, so it may or may not make sense. It may make sense to buy a server for $300,000 versus paying $5 million to run on the cloud for a few years. And people would say, but what if we don't have the $300,000? You don't have to. You can finance that $300,000 and at approximately 7 or 8% interest. It's about $90,000 a year. And it might be cheaper, $90,000 a year, than to finance it, than it might be to pay $1.5 million a year to rent it on the cloud, based upon the organization's business. So understand it's a shift from capital expenditures to operational expenditures. Not a good thing, not a bad thing. It's going to be based on that business, whether it's good or bad. So you're going to have to, the cloud architect, the enterprise architect is always going to have to be able to communicate to the chief financial officer and explain the total cost of ownership and build a business case that's going to show some return on investment capital for that business. If you can't do it, for the most part, you're not going to be selling your solutions to the client. Now, when we get to the cloud, typically speaking, we're trying to do a lot of things. We're trying to enhance security. And cloud computing is not more secure than the data center, but many people have the data centers that are not secure enough. And all in all, a well-designed, properly architected data center will be more secure than the cloud environment because of tougher perimeters. Having said that, in many cases, the cloud computing provides a better security environment than the data center because organizations don't have the sophistication to build very good data centers and very secure data centers. You want to deal with a big bank? They have the sophistication. You want to deal with a global internet service provider? They have the sophistication, but not everybody does. One of the goals that we're trying to achieve, typically speaking, is data reliability. Look, data is an asset, and enterprise architecture usually considers data to be an asset. But what do we do with that data? How do we protect that data? How do we make sure the data is good data, accurate data? So we're typically, in any kind of migration or any kind of enterprise architecture, we're typically thinking about this. We also have to think about downtime. Downtime is a very unique cost to a business. There are businesses that if they're down for an hour could go bankrupt. There are other businesses that if they're down for an hour, it doesn't matter. There are some businesses, if they're down for 10 minutes, somebody can die. And there are other businesses that can be down for 10 minutes and nothing happens. So we have to understand downtime and minimize it to the level that makes sense for the business and its actual business needs. I've worked with clients that lose $1 million a minute if their systems are down. Now imagine what a 4-hour outage would cost them. $60 million an hour, 4 hours would be $240 million. That might be terrible. It might be worth adding some additional redundancy and pay for it to not have that. You're going to have a lot more redundancy. Now, in any good architecture, and we can do this on Google Cloud, we can do it in any environment, we're trying to reduce the disruptions of services and make sure systems are available when needed and work properly when needed. So that's going to be a big goal here. Now, in any good architecture, it's only going to be as good as the information we receive from the client. One of the biggest things we do as architects is work across business units and communicate with various stakeholders. If we've got an enterprise that has 10 different business units, we need to make sure that the systems we put in place for one business unit do not harm another business unit. Do they need separate systems? Can they use the same system? So we're going to have to get the stakeholders involved. We're going to have to get their information to make sure we design the systems properly in a manner that's going to enhance business performance. We're going to need their insight and feedback into the architecture, and we're going to have to get their support. Because when it comes down to rolling out an architecture and getting people to use it, if we don't have the stakeholders buy-in, we will get nowhere. So we're going to have to get stakeholder engagement, and this is going to be critical as part of our business requirements and our architectural solution. We're going to also have to be able to create a return on investment capital model to be able to show the customer that we have some positive gains from the money we're spending on there, as well as figure out the actual total cost of ownership versus what people think it's going to cost to be in the cloud. So these are some of the things we need to think about. As I mentioned, in the data center, we buy the stuff, and it's capital expense. But what if in the data center, instead of buying the stuff, we decided to lease the stuff or rent the stuff? Well, now our data center is going to be an operational expense versus a capital expense. So on the exam where they say a data center is all capital expense and cloud is mostly operational, that's partially true, but it depends on how the data structures, the data center is set up and structured and how the equipment comes. Traditionally, though, you have to build a data center, you have to build a big facility, you've got to bring in a lot of power, which gets very expensive. You've got to bring in backup power and generators, which gets expensive. You've got to bring in a lot of HVAC, and that gets very expensive. Then you've got to buy the equipment, buy the racks, buy everything needed, and set it up, rack it, and have the staff to maintain it. So typically speaking, with a data center, there's a lot of things to purchase up front. But you pay a whole heck of a lot, yes, to use them when you purchase them up front because you own them. Now, when we go to the cloud computing, we only pay for what we use, which may or may not be good. We actually pay for what we provision. So we don't have to buy something, but we pay a lot more for it. For example, a server that might cost $300,000 may cost $4 or $5 million over several years to run it on the cloud. We didn't spend the $300, we paid a few million. Is that good? Is it not good? It all depends on that business. Did they benefit from the speed and the agility to go to the cloud instantly? Did that give them a first market mover advantage that assisted their business? Or did they just pay so much and hurt their business by using the cloud? That's why the architect needs to have so much business acumen and financial knowledge. So one thing I can tell you is when we go to the cloud, for the purposes of your exam, it's cost efficient. For the purposes of reality, it's probably not. But you've got to pass the exam. Cloud computing is agile, and that's worth a lot, and you're going to pay a premium for it. We typically can always want to look to optimize on the cloud our operational expenditures. So, we're constantly looking, are we using the right size? If not, can we change the size? Is this application running cheap on the cloud? If not, let's move it back to the data center. So it's about optimization of capital expenditures and operational expenditures to get the clients to their goal. Now, we have to be able to address total cost of ownership, and I'll explain what that is. So if I buy a server for $300,000, maybe I need to pay $5,000 of electric for that one server over the next 4 years. Maybe I need a tenth of a full-time person to manage that server for 5 years, and maybe that cost me an additional $150,000. And maybe I need some insurances. So I might be dealing with a server that might cost me $400,000 as a total cost of ownership, but it might still be cheaper than the $5 million on the cloud. But we can't basically just look at one thing. We have to know the total. And we're on the cloud. We can't just think of just the server. We have to think of the storage. We have to think about data transfer fees. We have to think about all the stuff that we're going to be paying for along with that server, which could become much more expensive. So whenever dealing with the chief financial officer, we're going to have to prove both that this is a good use of their money to go to the cloud, and two, that we're actually making a difference with the environment. And we can't do that if we don't know our total cost of ownership. Now, we will typically dealing with service level agreements whenever we're dealing with a third party. And a service level agreement basically is the provider offers to give you a level of service, and if they don't, they reimburse you a certain amount of the money you spent. So that's typically what we're talking about with an SLA. Now, I'll go over SLIs, SLAs, and SLOs. But an SLI is what you call a service level indicator. And it's going to be a quantitative measure that's going to give you the chosen characteristics of the level of service. And what does that mean? It means the service should be able to be 99.99% available, otherwise known as 4 nines. And it's going to measure availability rates, error rates, response times, etc. Now, we might be dealing with a service level objective, or SLO, and that's going to be a specific numerical target that's going to explain the expected level of service. So if you're dealing with the cloud and you expect 5 nines and you design your system across, theoretically, and it probably wouldn't do this in a single cloud, but two zones in 2 different regions, theoretically something like that could get you to 5 nines, assuming you have the absolute right level of change control procedures and redundancy and other things. You could. Of course, I don't think you're going to get 5 nines on any single provider, but that's why you typically would go multi-cloud for this. But keep that in the back of your mind. That's what a service level objective is. The performance goals. Now, the service level agreement is going to be the guarantee that the cloud provider is going to have its services available when you need it. So if Google Cloud Storage is supposed to be 99.95%, that's its target, and it's not, they might give you some financial credits. So it's giving you a little bit of your money back should the provider not meet their expectations. Now, that doesn't mean it's necessarily going to compensate you for the real challenge. Imagine you have an emergency services system that's cloud-based, and the cloud is down for 30 minutes, breaching your 99.999 guarantees. But what if somebody dies in that 30 minutes that the cloud's down? Well, sure, you'll get a little money back, but that's not going to cover the person that died. Or a hospital where systems were down and somebody died. And two things. So that's why we can't just look at SLAs and view it as a pure guarantee, because we have to look deeper and we have to protect ourselves. Because while SLAs are well-meaning, getting some money back if somebody were to die because of an outage is not going to be sufficient or acceptable. Or having a bank that loses $100 million in an outage that gets a credit of $500,000 in a service level agreement is not going to cut it. So at least you understand what SLIs, SLOs, and SLAs are and their strengths and weaknesses and limitations. So we need to think about that. So when we start thinking about the technical piece, we have to define the what of the system. What is the system supposed to do? Are we extracting data from one thing to another? Are we providing an AI recommendation engine to get a person to spend more money? Are we using AI to mine data to determine when we would buy a fuel option contract for an airline to cut their fuel costs? So we have to define what the system is going to be. And we also have to define some non-functional things, how the system should perform, how it should handle some constraints. And that's something we also are going to need to describe along the way. And we have to understand the difference between a technical need and a business need. Now, understand the Google Professional Cloud Architect, like all certification exams, like the AWS Solutions Architect Professional, the Azure Solutions Architect Expert, cover none of the business part of the architect role, which is 80% of the role. They only cover the technical piece. So keep that in the back of your mind. That's why we train people the way we do in our architect programs. If not, go get an MBA and learn some of these skills elsewhere, because you're going to need them for a great architecture role. Now, when you actually take the exam, and this is a high-level overview, we're going to get into the meat of the content, understand that a lot of the situations will be scenario-based. And you're going to be dealing with scenarios, and you're going to be thinking about the things that will help solve them, which is quite good. So we'll be thinking about things in study-based questions. It could be about scaling strategies, for example. It could be about which technology to use. So these are going to be the kind of things that you're going to see. And when we actually get to that, when you actually get to the exam, but this is an overview of the Google Cloud and its services. Now we're going to get a lot deeper into the Google Cloud now that we've introduced these concepts to you.
Welcome back, everyone. So what we're going to do is I'm going to answer some questions for a few minutes, and then Leo and Chris will explain the format of the labs, some of the labs that are going on, that kind of thing. But I know there was at least one question on there. I saw a cool, fun question pop in on Anycast and Multicast. So even though it's not necessarily part of this concept, I really wanted to answer Ngozie's question there. So can I talk more about Multicast and Anycast? So yeah, so they're two completely different things. Anycast is where we have two devices that use the same IP address for high availability purposes, and I'll show you. Multicast is when we send something to several people at the same time. So they're very different, but we can go through this fairly quickly. Let me just show you. I actually, while I saw the question came in, I started doing some whiteboarding. So let's talk about Anycast in action. In Anycast, what we have here is a situation. Let's say this cloud here is the internet, and 8.8.8 are Google servers. So what we have is we have these two servers that are synchronized here in Anycast, and they have the same information on them. And here's the reason why. Here I'm over in Florida. I want to go to this website that's got cat. So I go to the cat website, whatever it is. I enter that in my browser, and it goes to my local DNS servers, which is 8.8.8.8, which is a Google Anycast address. The server responds to me, and then my browser gets redirected to the website with the cats, and I'm all kinds of happy. Now, the thing with Anycast is it's designed for high availability. So here I am in Florida. For some reason, the local server just crashes and it goes away. It's no longer with us. And the way Anycast will work is I want to go to the cat website. I enter the information. It redirects me to this other Anycast webpage. The other Anycast webpage responds, and then I get redirected to the website that I want to go. So that's Anycast. Now, by comparison, Multicast is a little bit different. Multicast is I send something to the receivers that want to receive it. So let's say I've got a TV channel and I want to receive that TV channel. What I have to do is I have to receive it. And the process of multicast is going to be something like this. We have the host, and the host sends, I want to join this channel 224.6.8.9. And that is an IGMP join group message that typically occurs. That switch will actually look at that IGMP message and say, add that port so this person can receive it. Now the router will see that request and say, whoa, who has the source address to the IP address of 224.0.8.9? I don't know. Send a request to join, star comma G join as a particular to the rendezvous point. The rendezvous point will say, I have the source to this, and it will add the source to its outgoing interface. This will be added to the outgoing interface, and then this host can receive it. Now, all of a sudden, we've got another host over here wants to receive it. All they have to do is do an IGMP join group 224.6.8.9, and now that person's receiving it. So basically, we now have two users here that are receiving the same stream while no one else wants to receive it. Oops, no, let me go back and change so no one else wants to receive it. Now, all of a sudden, I've got a member over here that wants to do it. They send an IGMP join group and they get added. So realistically speaking, that's what's going with multicast is more than one people can say it. Now, you see this rendezvous point, which is the authoritative source of information of where this lives. What you might see is you might see two rendezvous points over here, and both of them may actually have the same IP address, which is in an Anycast environment that you may see. And that way, if one of the rendezvous points goes down, just like DNS in our previous example, we're good because they both have the same IP address. So realistically speaking, that's the difference between Anycast. Anycast is more than one thing with the same address for high availability. Multicast is I send something to the people that want to receive it, and I only have to send it once. The network replicates it. Really, really great question. So if there's another question, I'll answer it. Otherwise, and realistically speaking, let's get Leo, let's get Chris. They can talk about the 2 new labs that we're going to do for the day. And hopefully that'll be fun for others. There is also a video on our YouTube channel, What is Anycast DNS, that I made for you. And maybe one day I will do a multicast workshop because I spent a long time as a principal solutions architect as a multicast consultant. So it's kind of fun, geeky stuff for me. So if you guys want multicast, we can do multicast. Welcome, Chris. Welcome. Chris is our chief operating officer. He's back there making sure things actually work. And all the stuff is supposed to flow and the content flows, and Lee and Leo don't forget to show up. And that's Leo who actually did all the official tech demonstrations.
All right. So I just wanted to do some housekeeping notes as it relates to the labs that we're going to be going through. So, of course, this is a live YouTube live stream. Interaction between the two of us is a bit complicated between us and you. So what we're going to be doing is we're going to be playing these lab demonstrations for you, and 2 ways that you should approach these. Of course, watch them in real time with us, but also watch them again on the recording. The recordings are going to be available on YouTube as soon as YouTube finishes the stream. The reason I say that is because we all know following things along and doing it yourself, and then coming back and doing it and going back and forth between, what did they do there? Okay, let me rewind and let me make sure I do exactly what they did over here, and I understand what's going on there. So there's going to be 2 different approaches for you to take. Watch it with us in real time. Some of them, I would venture most of them probably not able to actually be done alongside with us in real time. Some of them can be. I'm just speaking from my experience. If I'm doing a lab for the first time, I'm probably going to stumble and bumble, and this 30-minute demonstration is going to turn into a 5-hour thing for me because that's learning. So that's why I wanted to emphasize that there's not just one way to watch it. It's not just watching these live with us and that's it. It's watching them and then watching the recording again, pausing, rewinding, fast forwarding once you figure out that thing that you couldn't figure out 15 times in a row. So I just wanted to say that the labs that we're going to be doing today are kind of like laying the ground, we're going to be doing creating your account. We're going to do the setting up multi-factor authentication and creating a budget. Basically, just getting you started. So you're going to be creating your Google Cloud account. You're going to set up your multi-factor authentication, make sure you're safe, and then you're going to set your budget so you don't go overboard. If you want to go along with us. So I just want to set that groundwork. We're going to play these 3 demonstrations. We're going to take a quick break between each one, not so much for questions, just to give people a little breathing room between them. And then I want to let us do some questions after we do those 3 videos. Now, that's not how we're going to do them all throughout the boot camp, just this particular set of getting you started. But I just wanted to share that again from the housekeeping and operations standpoint of running the stream. Leo or Mike, do either of you want to share anything before we play them the demonstration for creating an account?
Leo? Okay.
Oh, there you go. You're unmuted now, Leo.
Well, basically, you introduced that, Chris. These are the labs to anyone that will start touching the tech, right? Touching the cloud provider. So how to create an account, how to make that account a little bit more secure than only using password, and how to keep track of the costs, even if Google offers a free tier, some free credits, but it's a good idea to keep track of the costs.
Yeah. And actually, you know what as a reminder, we also have for AWS, the solutions architect, the Azure solutions architect expert, and there's labs that you can do with those if you want to play with some other clouds as well. And if you didn't know, we have a CCSK, we have a CCSP, we even have a CISM security thing that you can get on this channel. So if you have anything you're curious about, please feel free to dive deeper.
All right. So to keep Mike from going down too many rabbit holes about what we offer, let me start the video for how to create your account.
Hello and welcome to this lab. In this first lab, I will demonstrate how you can create your Google Cloud Platform account. If you already have a Gmail address, you can click Sign In and enter the email address and password. If not, you will need first to create a Gmail address and then use those credentials to sign in here to this site, cloud.google.com. I already have another tab with my email logged in, my Gmail logged in, and I see here Get Started for Free. I click this button and I am presented the step 1 of 2, account information, and this shows the email address I'm using, and then it shows the country I'm currently located, and here on the right you see some description of this offer, which includes $300 US dollars in free credit to spend over the next 90 days. And there is no automatic charges according to this offer. You only start paying if you decide to activate a full account, pay-as-you-go account, or if you choose to prepay. So if you don't choose to activate any of those options, you can spend $300 US dollars over the period of the 90 days. I will click Agree and Continue. And it will ask in the step 2 of 2 to create a new payment profile. This will only be used after the 90 days period, or if you decide to activate a full account, a pay-as-you-go account, or a prepay, if you choose to prepay. So I will click the plus sign here and enter the required information. The profile type you can select as individual if you are creating your own Google account to practice the labs and to learn about the Google Cloud Platform. The other option is to use organization, but this is not a cloud architect or a cloud engineer, a system admin that will create this account for an organization. So choose individual, as I believe you are creating this personal Google Cloud account for learning purposes. And you need to enter some personal identification. Click verified. And then you need to enter more information about your address. Finally, choose the city you live in, and then click the Create button. Now the payment profile is done. What you need to add is a payment method. Click the plus sign to add a debit or credit card. And then you need to enter the information for the payment method.
Thì ta từ đâu family story
Yeah. Once you enter the information, click Safeguard. Then you can click Start Free. Now it asks for some information. Select some of the options and click Next. And finally select the rule. I will choose Other and add Student. And click Done. So welcome. And here I have spent 0 out of 1,981 credits in Brazilian reais, which is equivalent to $300. And this credit will expire on June 25th, 2025. This is it for creating the account. See you in the next lab.
All right, welcome back. So that's how we create an account.
Exactly. So as we go through and Leo does some demonstrations, if you've got a question, drop it in the chat box. If you're watching it after the video, maybe put it in the comment section. We really want to do what we can to assist you.
Absolutely. Leo, you want to add anything you want to add to that? I think it was pretty clear from my perspective.
Pretty straightforward, and the offer is valid. I don't know if they have this only from time to time, but the offer is valid, currently valid.
All right. And I see that Sri asked about slides being available in the course. So we don't actually have any slides, but what we do have is we've got a study guide that goes along with this. I'm going to put the link to it in the chat box there for the study guide. That'll be much more in depth than any slide would have been. But these demonstrations will be available on the recording, of course. So more than welcome to watch that recording, rewind, pause, fast forward as many times as you want to. And like Mike said, if you're watching the recording later on and you've got questions, just put them in the comments, and we watch our comments like hawks. So
yes,
we'll keep an eye out for those. Without further ado, let's move on to the multi-factor authentication, and then the really fun one of creating a budget. I like budgets. So here we go.
In this lab, I will demonstrate how to make your account more secure by setting up a second-step verification or multi-factor authentication on your account. This will make your account more secure, but you will need to enter every time you want to log in to your account. You will need to enter the email address, the password, and then a code from the second step verification. You will be able to choose different methods, but to start setting up the second step verification or two-step verification, you'll need to click on the circle with your initial on the top right of the screen. Then click the blue Google account button. From the left side menu, select Security, and then scroll down to how you sign in to Google options, and then verify if the two-step verification is on or off. In my case, it is off, so I will click this option, and I want to turn on two-step verification. Here from the bottom, I can choose what kind of second step I want to receive the code from or to. For instance, I can use passkeys and security keys. I can use a Google prompt on my Android phone. I can use Google Authenticator to generate a code so I can enter on the login screen. And I can add the phone number to receive a short message service with the code. I will choose the Google Authenticator. So I will click the Add Authenticator app option so I can create a token on my Google Authenticator app on my phone so I can receive the code from the Authenticator app and enter as the second step verification for logging in. If you want to add an Authenticator app to your Google account, click this option and click Set up Authenticator. Now you need to scan the code on the screen to link it with your Google account. Upon scanning the link, my phone asks me which application I would like to use to open that link. I choose the Google Authenticator, and now the Google Authenticator is asking me to add a token. If I want to add a token for this account, and I click yes on my phone, and now I have a token for this account on my Google Authenticator app on my phone. So now I can click next here on the screen. And from the Google Authenticator app on the phone, I will type the codes here. So this code is generated on my phone by the Google Authenticator app, which I included or linked to this Google account. Enter the code and click verify. Now it says your authenticator was just added. Now I can click the turn on two-step verification button or click the arrow to go back to the previous screen. Here I have the Authenticator app added or linked to this account, and now I can click turn on two-step verification. So every time I try to log into this account, it will ask for the second step verification. It's adding me to enter a phone number. I don't want to enter a phone number for this account because this is a test account. I will just skip this step and then continue without a phone number. Yes, I want to continue anyway. This is not a safe or recommended. You should, especially if you have only one Google account, you should enter your phone number. So if you lost the password or if you have any difficulties logging into that account, you can receive codes or recovery codes on your phone to be able to recover your account. This is a lab account. I will delete this account after I record the lab, so I don't want to add a phone number to this account. So it says you are now protected with two-step verification, and it shows the option I will receive the code or will generate the code so I can enter after I enter the password to perform the login. If you reach this step, click done and setting up multi-factor authentication on your account is finished. Thank you and see you in next lab.
All right. Everybody got their multi-factor authentication set up? I swear my Google Authenticator has like 19 token things on it at this point. Leo or Mike, you wanna add anything or?
I did not demo. Please go ahead.
As far as things go from right now, everything feels fairly straightforward that we're describing to me. But, just because it feels straightforward to me does not mean something feels straightforward to you. We all have different things. We all have different expertise. We all have different things they know. So all we care is that you've got a great experience, that you maximize this Google Professional Cloud Architect Bootcamp. So if you've got a question, please don't hesitate to ask. We want to do everything that we can. And then, Chris, do we have anything else? One more?
We've got the budget walkthrough, but I want to, Leo, you got any commentary?
Well, I just did not demonstrate after creating the second step verification, but every time you log in, you need to enter the username, password, and the second code for the second step verification.
Yes, absolutely. All right. Well, let's get on with creating a budget. The next one's going to be a little bit longer. It's about 20 minutes. So make sure you're comfortable and ready to go.
Yeah.
Hello. In this lab, I will demonstrate how you can create a budget and set an alert when that budget is reached or exceeded. After you go to cloud.google.com and perform your login, you will reach this screen. You can click Console, and then you are taken to the welcome screen of Google Cloud Platform Console. And to create the budget, you can select the option, set up budget alerts from here, or you can click the navigation menu and then click billing. Then from the billing overview window or page, you can select budgets and alerts. You can click create budget from this option on from the top here and see that there are documents and tutorials for helping you doing this activity. If you need help, please research Google documentation for that. So enter a name for your budget. I will enter a very suggestive name. This is a lab recording. Please consider this. If you are doing this for an organization, for your work, choose names that are in compliance with the organization's policies and standards. Here under time range, you can select the period you want your budgets to monitor the spending. It can be monthly, quarterly, yearly, or you can set a custom range. I will just leave the monthly option selected. And here the read-on option, it is just for protecting the budget from unwanted deleting or modifications. For this lab, I don't need to set up that option. And for learning, you also don't need to set up that option. Here under project, you can select the specific project you want the budget to cover or to monitor, or you can leave all projects. In this case, I only have one project, but I will leave the default option selected. Here under services, if you don't select anything, if you accept the default option, the budget will monitor all Google services possible. You don't need to choose which services you will want to monitor. But if you want to choose the services, please open this option and select the services you want from 1,792 possible services Google offers. Here under the labels option, you can enter the key and value for the labels. Let's say you want one budget to monitor the development department. So all services created for the development department or by the development department, you should add a key value pair, a label for those services. So this budget or the budget related to the development department will monitor all the services with that label. And this is valid for how many budgets you want to create. You can create different budgets. And if you want to monitor by labels, every time you create or add a new service to that department or that account, you should add the label to that services so they are monitored by the budgets. I will not add any labels here. And for credits, you can leave the options as they are selected. This will include every credit, promotion, offers, discounts into the budget. This means the budget will also monitor the free tier services you use during the time the budget is monitoring your service. Leave them selected if you want and click next. Then we need to set the amount for the budget. Here you can select a specified amount, a fixed amount, or you can base the current month budget on the previous month. So you can use last month's spend as the budget limit for this month, or you can specify a fixed amount And if you don't change that every month, the limit for the budget will be this specified amount. Here under target amount, it's showing my local currency here, and it will probably show your currency, which is different from mine. For this lab, I will create a budget for 10 units of money. In my case, it's Brazilian reais. And I will click next. In this next page, I can set the thresholds for the alerts. My total budget is for 10. And if I set a threshold for 100% of this budget, it will trigger a notification, an alert, when total consumption of services on this account under this budget reaches or exceeds 10 reais. I can set different budgets, different percentages. Let's say 90% of the total budget will be 9 and 50% will be 5. And here you can trigger on the actual spend or consumption of the services or the forecasted. The actual will trigger the notification when the actual value of 5 in this case is reached or exceeded. If you set for forecasted, the notification will be triggered when, based on the daily consumption, 5 is forecasted to be reached during the month. So if your total amount is 10 and you want to forecast when 5 will be reached, the notification will be sent when the forecasted value of 5 is reached. I will just leave actual spend here for my triggers, my thresholds, and I will add one more threshold for 1%. So whenever 0.1 units of money are spent on this account, a notification will be triggered. Here you can manage the notifications or the types of notifications you want to receive. The default option is email alerts, but you also have the option to add different accounts, different email accounts. The first option is email alerts to billing admins and users. In this case, the only user of this account will receive this email alert. If you create other users for billing admins or other users on this account, billing users, they will receive the email notification as well. You can link monitoring mail notifications channels, which is selecting a project and maximum of 5 monitoring mail notification channels. And the last option is to connect a pub sub topic to this budget. Using this option to connect to a pub sub topic, you can send notification alerts for Slack, for instance. If you have a department that is responsible for monitoring the consumption on the accounts, they can receive alerts on Slack when the trigger is initiated, when the threshold is reached and the trigger initiated. Not all services update the billing immediately after the service is consumed. It could take some time after the consumption of the service. Let's say you created a virtual machine, you terminated the virtual machine. The consumption could be updated on the billing hours after you terminated the virtual machine. But anyway, choosing to connect a pub sub to use Slack, for instance, for notifications will take a little bit of coding and using other Google services like Cloud Run to send the notification to Slack. It's a little bit more hands-on option to connect to a pub sub. But for this lab, I will just leave the email alerts as the option for receiving notifications. And once I do that, I will click Finish. And my first budget is created for a monthly period for a total of 10 units of money. You can click the name of the budget to see the details, and you can also add more triggers, more thresholds. You can do modifications and then click Save. For now, the budget is created. Right now, I don't have any consumption. I haven't used any service to trigger the notification by email. But after recording the labs for creating virtual machines and using different services, I will check the budget, how it is. And if the threshold was exceeded, I will receive an email in this account, and I will add that email to the end of this lab. It will be kind of a time travel, because I will go to the future when I actually have some consumption of services on this account, and then I will go back here and add the example email with the notification for the consumption of the services, which I don't have at this moment. After creating that first budget, I did other activities so the services or the consumption of the services could accumulate. But then I noticed that since I included the discounts, promotions, and offers in the budget, it doesn't show the services I am consuming, or at least the budget will only step from zero when the $300 expires or are used. Then and only then the budget will start increasing the values. Because of this, there was no email, no alert email sent by this budget, because it still shows 0 out of 10. For this reason, I will create a second budget here, and this time I will unselect the promotions, discounts, and other codes that do not allow the budget to show the consumption of the services I am having while using this promotional period. I will click Create Budget. And then I will name it my second budget. I will try a custom range from January this year up to July 1st. I will allow all projects. Since I'm creating projects and removing projects from this account, I want the budget to monitor all projects. And I will leave all services selected as well, so the budget monitors any service I use. Here I will unselect the discounts and the promotions and others. Now I'll click Next to go to the amount section, and I will keep a specified amount, and this time I will enter, let's say 200 Brazilian reais. And there are some percentage, some triggers here for sending the email alerts. I will accept them. There is one for 50% of that total, which represents 100, then 90% of the total, and then 100% out of the 200 Brazilian reais I set my budget to monitor. I will accept the email alerts to billing admins and users as the form of alert to be sent, and then I will click Finish to finish creating this budget. Now we can see this budget already has some services monitored since I set the period from January 1st to July 1st. The services I have already used in the previous days of creating this budget, and we can see there is already consumption of services that is reported by this budget since I set the dates from January 1st to July 1st this year. All the services I have consumed during the previous days of creating this budget, those services are already reported here in the budget. Whenever the budget reaches the triggers, 50%, 90%, and 100%, the email alerts will be sent informing about the threshold being reached. As I mentioned when creating the first report, I will wait for the thresholds to be reached and for the email alerts to be sent, and I will come back with an example of those email alerts. I will click cancel because I didn't do any modifications on this second budget. As I did for after creating the first budget, I will wait for to consume more services from the Google Cloud Platform so the thresholds are reached and then the alert emails are sent. Some days and some lab recordings later, the services accumulated expenses on my Google account. At this point, I have received the email alerts for 1% budget, 50%, 90%, and 100%. And one of these emails is like this. They bring the percentage reached and they inform the budget amount. And that's it. The others, the 90% budget, the 50% budget, and the 10%, the 1% budget. To delete a budget, you click the name of the budget, and then you click the delete button. You click delete to confirm you want to delete the budget. And then the budget is deleted. In this lab, I demonstrated how to create a budget and how to set thresholds to trigger sending alerts. I also mentioned the different ways you can use to send alerts when the thresholds are reached. Thank you for watching and see you in the next lab.
All right, everyone, we are back. So I think there was one question that I'm going to go over that I may or may not have misinterpreted the question in the chat box. What is a host name? And then if there's any other questions for Chris and Leo.
Oh, no, not for me. I'm just here to moderate the two of you. So
if you have a coordination question or a facilitation question, send that to Chris. If you've got a lab question, send it to Alonzo. If you've got an architecture question, send it to me or a business executive.
Well, we are not sending anything to Alonzo. So I'm going to leave it with you, and I'm going to leave it with you and Leo. I will remain in the chat box. Have fun with any questions that you have. Let me put up the first one.
Hi all, what's the host name? So let me talk about what is a host name. So Chris, I want to go to full screen right now. And what I'm going to do is I'm going to actually share something. I drew it when that question was coming in. So if we actually look at, I'm not exactly sure what's going on there. So let's go back to, If we go to a fully qualified domain name here, it's going to have 3 components. And the 3 components of a fully qualified domain name are going to be the host name, which is what you call it, the domain name, which is the domain that the organization owns, and then the top level domain. So if I call my computer Cindy, and I have a computer named Cindy in my house because my cat does like have a computer that she likes to walk on the keyboard, and I don't want it to be mine. So Cindy can't really do any damage on her computer. She's got her own. So that machine is named Cindy. It's not plugged into anything. There's no real internet access, but the keyboard is there. So if she walks into it, it's no big deal. Now that would be the host name. So the host name is just what we call it. The domain name, again, is what we register. And the top level domain could be .co, .edu, .net, or what have you. So it's just what we call it. The system is its host name. And typically that'll fit into a DNS server or an Active Directory server. So you'll be able to use a name to connect to it, not its IP address. Great question there. We can both come back now, Chris.
And apparently Alonso is in the chat box. So if you have questions for Alonso too,
you could ask him too.
Yes. So
I recommend marketing questions for Alonso, or of course you could do any architecture, AI, or otherwise.
But yeah, so I'm going to let Mike and Leo stick around for a few more minutes if you guys have any questions. Now, keep in mind, this is just the beginning. We've got IAM tomorrow. We've got networking Wednesday and Thursday. We've got compute and containers on Friday. And then next week, we're going to be covering security and databases and storage and all that fun stuff. So we're going to be diving a lot deeper into all of this. But Samuel's got a question.
So Samuel's question is, what is a fully qualified domain name? So a fully qualified domain name is something that has a host name, a domain name, and then that top level domain. So let's talk about the difference. And I know you, Samuel. So let's imagine we just wanted to reach a name, a host inside of our entity. And I could make it Leo's Mac, Chris's Threadripper workstation, Alonso's Mac, Mike's whatever home built crazy system that he's got running over here. I could name it anything I wanted. And inside of my domain, I could actually have a host file that's sat on everybody's computer that says Cindy, and all you'd have to type is Cindy and it would reach it. Now, I might instead use Active Directory or some kind of directory service where I could just enter a name inside of my domain and I could literally reach a system. Ping Leo's computer. And it would work if we had a host file or something internal to resolve it. Now, if we're in an external environment by comparison in the internet, how do we send that traffic to where it needs to go? How do we resolve that traffic when it's off network? And that's where the DNS servers really are coming in, where I send it a full name. So it's leosmac.gocloudcareers, which is our domain, .com. And that way I could just ping Leo's Mac or SSH to Leo's Mac if I had access to it, as opposed to remembering Leo's IP address and connecting to it via its IP address. But that's really all it is. It's just adding the host name plus the domain name plus a top level domain. And that's why you can go to training.gocloudcareers.com. The training or subdomain is actually effectively functioning as a host name. The Go Cloud Careers is our domain name, and our top level domain is .com. So that's realistically speaking what we're talking about. I hope I answered your question there, Samuel. So it looks to me like questions have dried up. I think Leo and I have kept you guys busy now for 4 hours. 4 hours on the Google Professional Cloud Architects. It's just the first day and we got 2 more weeks. So if you want to catch up on anything, go look it up. Go rewatch something. If you've got an area of question, we're going to leave this up. If you've got a friend that you think would benefit, please invite them. Maybe like it, share it, do what you can, and send this to others because we really want to help as many people as possible. Leo, have any last words for the day?
Well, that this is very educational and very entertaining. And if you all like the content and the labs, share with your friends, with your colleagues, and come back tomorrow.
Come back tomorrow. Leo's modest. He's got over 20 years of expertise. Welcome back, everyone. Leo and I are back for day 2 of our completely free Google Professional Cloud Architect Bootcamp. This is a 2-week boot camp to prepare you for the Google Professional Cloud Architect certification and exam, obviously. Today, we are going to basically talk about some identity and access management components. We're going to start to get into that today. And I think it'll hopefully be some fun for everybody. But welcome back. Today is day 2. I want to remind everyone that if you were not here on day 1 of this free training, don't worry. You can go back and see day 1 of our Google Professional Cloud Architect anytime you want. Today can stand alone from yesterday. You can watch today's and go back to tomorrow's, anything that you want to do. So please make sure that you go back and watch the original day if you haven't seen it. Someone from my team drop a link to that. Now, we also have a free study guide that if you sign up for, it typically will take about 15 minutes for you to get. And, so fill in the email and then you should receive it in about 15 minutes. So please do so. There's about a 550-page study guide that goes along with this book. And this boot camp should easily prepare you to pass the Google Professional Cloud Architect exam. I know I passed the exam very simply, easily. It was actually I've been designing clouds for cloud providers for decades and have worked with all the clouds since 1993, the first ISDN cloud and other clouds that I worked with. But, I thought I'd get a cloud computing certification. And the first one I did was the Google Professional Cloud Architect. And we built the curriculum based upon what I did for that and what I've done to help others pass this. So you should be good with this. But I still recommend always read the official book. This is the official book recommended by Google. So I do recommend this study guide as well as the video that we have here. And also the other, as well as the study guide we created. And it might be worth doing a practice test because maybe you're not sure the way Google likes to ask their questions. And a good practice test could get you used to the weird way they ask questions or the weird way anybody asks questions. And that way, when it's the exam, you don't have to focus so much on interpreting the questions because you already know how they're structured. You just have to answer it and it makes it a little easier. So that's something that you could think of too. So that would be my suggestion on it. But anyway, we're going to have some fun. Leo, did you want to say anything before we begin?
Thank you, Mike. Yes, welcome everyone. And please share this with your friends, your colleagues. This is free without any cost. And everyone can only learn and get better from that. Thank you, Mike.
Yeah, so it's great. And everything we're providing here is free. Again, this is an inexpensive book. If you want to get it, I don't get paid anything for buying this, not buying this. I'm just saying that I like the book and I used it when I took the exam about 4 years ago. So it's all up to you. So the way we're going to run this is we're going to basically have a discussion for 20 to 30 minutes. Then we'll answer questions. We have 2 easy mini labs today on IAM that were, of course, created by Leo. We'll have some more when we get into the networking and things tomorrow. They're going to get a lot more fun and they're going to get a lot more geeky. But today, we have to address some real concepts here. We'll have some intro labs and we'll get geekier with the labs tomorrow. But so, keep that in the back of your mind. The question is, how much is the book? Our study guide's free. The one that we created, this entire course is free. Everything we've given you here is free and the training program is free. That was just an unrelated book that I happened to like when I took the exam, when I mentioned the Cybex one. But I like to read books. So let us know where you're from in the chat box while we wait for a few more people to join us. I like knowing where everybody. I see Angela's in Southern California. I just got back from Beverly Hills a few weeks ago. I thought it was really cool to see all these self-driving cars driving around the road. I was impressed with how well they were actually driving in all practicality. The Waymo cars, I think they were called. But where else are you from? I know Leo's in Brazil. That one I know. And I know I'm in South Florida today. And my wife is in Philadelphia. And I really wish she was in Florida. And one last thing that I'll mention is that on Thursday, we're going to have a webinar. And we're going to talk about what it takes to become a cloud architect or an enterprise architect or a security architect or an AI architect, any kind of architect you want. We run a webinar every Thursday where we'll talk about what we actually do in these roles and the skills that you need in these roles. And the skills of the roles are very different than the certification. So I want you to know what those skills are. I also want you to know how to get past the HR people when you don't have a perfect resume so you don't get auto-rejected. We'll also talk about that. We'll talk about what hiring managers want. So if you don't have a perfect resume, you can be the other stuff they want and that'll go far to help you get your first tech job. And it's completely free. So join us. It'll be live on Zoom, and I look forward to meeting you. Okay, San Francisco Bay. Yeah, that's right. Mark's out there. Little Rock, Arkansas. I think I've traveled the entire world and not made it there. So I have to do that at some point. Darnell in Chicago. There was an Equinox that I used to go to in Chicago that I really thought was a really great gym. Spent some fair time there too. All right, so we're going to get into the content. Everybody, will start the content now. Give me a hashtag Google Professional Cloud Architect, because this is a Google Professional Cloud Architect Bootcamp to prepare you for the Google Professional Cloud Architect PCA exam, whatever you want to call it. And then, Chris, let's start the content.
Now we're going to be starting our discussion on identity and access management. And I'll begin with a summary of identity and access management, and then we'll get much deeper into some of the Google offerings and the solutions you can do with IAM on the Google Cloud. Okay, so in this diagram, I've given you a picture of authentication, authorization, and accounting. And I'll explain it to you, and then we're going to work through an example together. So authentication is determining if you are who you claim to be. So if I log in as Mike Gibbs, I should be able to prove that I am Mike Gibbs, so I get access to Mike Gibbs things. And someone else should not be able to be Mike Gibbs. So authentication is determining who you are or you claim to be. And that could be a person or a device. Authorization is determining what you're allowed to do or what you're allowed to have access to. And then accounting is keeping track of what you've actually done. So let's work through an example. In this case, we use the example of Cindy. Now, Cindy is my cat. I tend to love this cat. Now, there's a lot of cats in my community that walk around that look a whole lot like Cindy. She's a standard tabby cat. But in this particular case, Cindy went outside for about an hour. She now wants to come home. So Cindy actually scratches on the door, makes a few sounds. And all of a sudden, I look at Cindy and I say, oh, that's my cat, Cindy. And I open the door for the cat. So the authentication is that this cat is Cindy and not someone else's cat. So now Cindy's been authenticated and I know who she is. And now Cindy wants to do a few things. First, Cindy wants to go to the fancy tuna store on her computer. So she goes to the fancy tuna store and the request is authorized, meaning she wants to go to the tuna store. The identity systems in our house say, yes, Cindy, you're allowed to go shop at the tuna store. So she goes to the tuna store. Now, Cindy does whatever she wants in the tuna store. Now she wants to do something else. She now wants my car keys because she wants to go drive to the mall because there's a mall and a special fish market that's 100 miles away and she wants to drive there. But I don't want my cat driving the car. So I've sent up an authorization policy that Cindy's not allowed to drive my car. So now Cindy tries to drive my car and she gets told no. So that's the authorization piece. She was authorized or allowed to get to the fancy tuna store, but she was denied access to my car keys. And then the accounting piece of this is I actually look at my credit card statement and I find out that my cat spent $200 on tuna. And I find exactly every can of tuna and the types of tuna she bought at the fancy tuna store. So authentication, who are you? Authorization, what are you allowed to do? And then accounting is what have you done? Okay, so now let's get back into the cloud identity content, but I wanted to do a level set with regards to what is identity and access management, and it's all about determining who you are, what you're allowed to do, and keeping track of it. So initially, when you sign up, you're going to set up your Google identity and your admin account, and that's where you're going to initially navigate to the Google Cloud Console. You'll begin the process of setting up your cloud identity on the cloud platform. You'll sign up for an admin account, and there'll be prompts to sign for administrator accounts. Now, obviously, there'll be some click-through agreements that you have to click through and read. When you click through these agreements, that is a legally enforceable online contract that you actually sign. So please read it. And a lot of signups do this because they have to make sure that you will abide by the rules, etc., what you're responsible for, what they're responsible for, and they typically do it as a click-through agreement. So you have to read them at some point, or the attorneys obviously should read them for you. Now, most of these agreements are necessary to sign before you move on. So please understand, these are contracts that you're signing. So there's a legal implication of it. So make sure you understand the implications of this when you sign up. And make sure that your company policy is going to align with the types of things you see when you read through those click-through accounts. So we'll begin with compliance scenarios in the exam. I want to let you know that there will be scenario-based questions about common IAM things on your exam. There'll be questions on GDPR and very common things and privacy situations that you'll find on the exam. And instead of just asking you an ABCD question, there'll be a scenario and you'll have to read the scenario and you have to think through what might be the right solution. So keep that in the back of your mind. At the end, we'll talk about the various case studies that you'll see on this exam, but we want to teach you the Google Cloud before we get into these types of case studies. So in certain legal environments, like GDPR, you have to make sure that if there's a big kind of a service outage, for example, you don't lose messages and you don't lose data. So typically speaking, in order to deal with that, you'll typically need some kind of a queuing system or a messaging system. And I can whiteboard it out for you to make it a little easy. But sometimes, as it pertains to compliance, you may have to do this. So let's talk about what I mean by a queuing system or a messaging system. Let's say you have a server here, and this server needs to receive some information. And let's say you've got the information coming in here. And the information flow is it's going to be leaving from the information source, and then it has to get to the information server. So what if, for example, this server were down? Well, then you would lose these messages. And in certain cases, from a compliance perspective, you can't. So what you would have to do in a situation like this, and you may see a question like this on the exam, is you may need to use some form of message queue. And in this message queue, what you can ultimately do is if for some reason the server is down, the messages will be placed in the queue and they will wait in the queue for the server to be back up. And then when the server is back up, it will send the messages to the server. They discuss this and when you start thinking about certification. So I just want you to understand that under certain environments, we may not be able to lose messages. GDPR has some regulations that way. So because of that, because of the data protection, the data privacy, and some data residency requirements, we may have to do message queues. We also have to understand that there will be legal and compliance rules, and we may need to use IAM things to help keep this to stay compliant. For example, European citizens' data can't leave Europe or the European Union to stay GDPR compliant. Now, what does this mean in a cloud provider where they may replicate your data all over the world? It means you're going to have to do things about this and prepare for these things whenever you deal with cloud computing. If you want to know much more about that, we have a completely free cloud security certified professional CCSP course that is actually sitting on this YouTube channel, which will talk much more about the legal and regulatory challenges in cloud computing with regards to the data. But we just touch on it in this program. So when it comes to messaging systems for publishing and subscriber or queuing systems, in order to make this happen, there are opportunities that we can use. Google has their own messaging system. Apache Kafka is typically one widely used, and the reason it's used is it works in all clouds. So you can think of Apache Kafka, for example, as an open source stream processing platform. It gives you a lot of control of your architecture compared to a managed service. And it allows you to ensure that your data stays where you want it to be when it comes to messaging systems. So Kafka is often something that's typically used. You can also use PubSub, which by Google, which also does similar features and functionalities, and now it supports regional data control. So, but Kafka's inherent control and flexibility might still be preferred when you've got strict compliance scenarios and you've got to deal with multiple cloud providers. So on the exam, just prepare for, to understand service agreements, because they will talk about it and why you have to read the service agreement and what the service agreement is and the implications of it, meaning you signed a legal contract. In general, in many cases, when we're dealing with regulatory environments, we may need control and a lot of flexibility of what we do. So that's what we want to touch about compliance scenarios for the exam. Now we're going to get into much more of identity and access management. It's just one thing to note and think about when we talk about IAM and compliance. And IAM is all about compliance, keeping track of what people have done, all about compliance. So there's so much here. Not letting people do things outside of their scope, all about compliance. Not letting people access private information, all about compliance. So now let's get into the fun IAM stuff. So Google has an IAM service called Cloud Identity, and it's identity as a service, meaning it's a managed identity platform for you to use instead of managing your whole thing like an Active Directory environment. And the point here is it's going to provide a unified platform for identity, access, and application endpoint management. And it's going to be very easy to use. It's going to be very set up, and it's going to allow various users on the Google Cloud to consume and connect to various resources. Pretty easy. There's a couple of accounts that you typically talk about. When you sign up for the Google Cloud, you'll immediately create an administrator account. Now, this is an account with a lot of rights. The administrator account has access and ownership to the entire cloud identity platform. And when you set this up in this administrator account, you're basically setting up a billing account alongside the administrator account because that's the person that owns the account. So I kind of hope that helps understand when you set this up what that administrator account is. You may hear it called the root account in other cloud environments and other clouds, same kind of concept. Now, we may set up billing accounts. For larger organizations, we may have to set up multiple billing accounts. So I want you to think about an international conglomerate that may have 10 different divisions. They may actually want 10 different accounts. So lots of subsidiaries. It may not make sense for a single administrator to manage the entire bill for 10 different departments that they may not even know what those 10 different departments are doing operationally day in and day out. So that gives you the opportunity to do billing accounts and create multiple billing accounts, which is fantastic. You can have the cloud billing account, which is going to pay for the Google Cloud projects and the Google and anything you're dealing with. And it's like and it can be linked to your cloud billing account, and that can be linked to one or more projects. So initially, when you set up the cloud identity and administrator account, it's going to do a few things. One is you basically have to add your domain and verify your domain. So there'll be a setup phase and you'll add your domain. And at some point, you're going to have to verify your domain name. So if your domain name is cindythecat.com, first you have to add that, and then they're going to have to verify that you actually are the owner of cindythecat.com. Typically speaking, there'll be a .txt record, and that's typically generated in your DNS records for verification. And there'll be some form of manual verification that you can do if things go wrong, where you'll have to manually add a TXT file to your DNS setup. But setting up the domain so they know who you are realistically, and they associate the domain with your account. Now, once you have your domain added, you're going to have to add your users. So you'll add various users. They're called cloud identity users. Now, for a large organization, they may have a lot of information, especially with enterprises that are dealing with large environments. And they might be using things like new organizations as well. The key here is when we set things up, we want to figure out how to set them up for scalability. You know, a small business, it's easy. It's straightforward. A single user, a couple of users, there's nothing really to think about. But when you're dealing with a large enterprise, things change. It takes careful planning to make sure you've got a very scalable structure or a scalable architecture that when your users build, it's going to keep growing. Now, when you have one big company over here and they have multiple little billing accounts over the company too, now you're going to have a lot of careful planning that needs to go on as well. And you might need to coordinate these accounts to get a discount for the primary account. So there's work to be done. There's management overhead, and thankfully there's a lot of work for us cloud architects because we end up doing a whole lot of these then looks, evaluations, meetings with vendors, meetings with stakeholders, that kind of thing. So thankfully that's what we tend to do. So think about that from the perspective of the scalability. Think about the billing management when you set this up. Maybe we want to align the billing records with the organizational structure. And that way it makes sense and people can understand structure-wise the people that need to know what's going on with the cloud expenses, and they can compare their cloud expenses to what they previously paid. They can compare their cloud expenses to and the performance they're getting to what they previously had. Since any architecture we have in a perfect world, we're going to get better. So we have to understand that security principles in the cloud are a lot different. We lose a lot of the security parameters in the cloud that we typically had. Typically, we had a back-end environment and in our data center that was completely protected from the internet, and then we had a demilitarized zone outside of our firewalls for things that needed to be used. So there is that. Traditionally, we may have also had a tiered environment and monolithic applications, which we still will on the cloud and off of the cloud, but they're slightly different than the microservice base. Actually, they're a lot different in the way they actually work. So on the cloud, we have to think about what we're going to be using and what we're going to be securing. It's a lot different to secure a single server. That's easy compared to distributed things all over the world, all across multiple clouds. And because we're going across clouds and across boundaries, understand identity and access management becomes so much more critical. So let me show you why it's so much more critical and why it's so hard and why IAM becomes so important. So if we look at this environment, a traditional environment, here's our data center. And in front of the data center is our firewall. Outside of the firewall, we have the internet. And I want you to see how easy this is to protect. Nothing is getting in from the outside into this building, into the data center where the users are, where the systems are. For the most part, if the firewalls are architected well. If you've got a web server, or it sits out here outside the demilitarized zone. So, web server. And if we deal with this, what does the web server need to get? Typically speaking, TCP port 443 at this point. So all that's necessary is you open a hole in the firewall to a specific subnet for the web server to be. And all that's outside the environment. Now, what happens in an environment, or what we had was we had a very simple architecture, which was like a 3-tier web architecture. So you might have a web server over here. You might have an application server behind it. You might have a database behind it. And this is pretty typical. But the thing is, the traffic was coming in a single direction. If we had a web server, only port 443 traffic had to hit the server. And we could firewall that off. And then between the web server and the app server, we only had to allow the traffic, typically speaking, we were very particular on the traffic that we even allowed. And then even the traffic coming to the database was only destined for the database server. So this was easy to protect. Now, I want you to think of an environment where you've got things that are talking to everything all over the place. So this could be a service. And this could be another service. And this could be another service. And this could be another service, and these services could be hosted on 2 or 3 different clouds. So now you've got multiple vectors of attack. Things can be coming this way, they could be coming this way, they could be coming this way, they could be coming the other direction. So we lose a lot of this good network security. So the only thing we're going to be able to do, will be more that we can do, especially if we microsegment our environments into multiple VPCs and how we route between them. But all in all, without getting into some fairly complicated networking, we can make sure every request to that server, I'm trying to do this. Are you allowed? No. Okay. I want access to this. Am I allowed? Yes. I want access to this. Are you allowed? No. So by checking every verification is one of the best things we can do now. That's why there's such a heavy emphasis on IAM. So I showed you the traditional model, and I showed you how, it's easier to defend. And I also showed you how on like a 3-tier website compared to a microservices environment, in many cases, it's still easier to defend because our boundaries, our perimeters, and where the traffic is going and the directions they're going are fairly easy. As it gets further distributed and further apart, network security and other things are still valuable, but they become less effective, and IAM becomes so much more effective. So what are we talking about here? One of the things we need in security is the principle of least privilege. And what does that mean? It means don't give people access to more things that they need to do their jobs than they need to do. So if I need access to this system as part of my job, I will be authorized and given access to it. If I don't need access to this system for my job, I won't have access to this. So by doing this, it limits the damage because now the people that can access the highly sensitive systems are only a small number. And that way we can protect information. Now let's talk about another thing we need to do in security. It's going to be the separation of duties. And this is a great security concept. And it makes sure that no one person can do everything, and therefore they can't hurt the environment. And you'll see this all over the environment. 2 people needed for certain things. Let me give you an example outside of security, as I think it'll make it a lot easier. So let's say you went to you wanted to go to the bank, and you had a safety deposit box out of the bank. Yes, I don't typically type very well when I type on live, but let's say there was a safety deposit box. But in order to get to the certain safety deposit box, you needed your key, and someone else held the second key. By doing it this way, it would take your key and, who knows, maybe your wife's key in order to be able to access the account. Now that increases security dramatically. But we can also talk about separation of duties. So let's say we have a person with an important job. And they have a lot of access to this information in the job. Enough information that if left alone and they were malicious, they could cause serious harm to the company because they'd have access to too many systems. But what if we could take these important jobs and share it between 2 people? Now, this does a lot of different things. It limits the harm that the first person or the second person can do. And if the first person and second person don't have enough information or have incomplete information because they only know how to do their job, there could be no harm to us. We may also implement things like job rotations. And here's why. If we have person A and they have a lot of power, this person by themselves could commit fraud and do certain things. But imagine if we have person A and person B. And every 12 months, they switch jobs. So now if person A does something bad, 12 months later, person B will catch it. And if person B does something bad, 12 months later, person A will catch it. And when you see that, people are going to be less likely to commit fraud or cause harm to the company when they know they're going to be caught. Principle of least privilege: don't give people access to more than they need to know. Separation of duties. Yes, don't give one person the ability to do it all if you don't have to. Separate it by a large number of people. Minimize the threat surface. So whatever you're going to be dealing with, minimize the risk to it. So if you're dealing with microservices, which are going to be harder to secure than specific monoliths, especially when you've got good perimeters, make sure you've got some good identity and authorization, and make sure you authorize every single request. So if you try to do one thing, you're not allowed, or yes, welcome, those kind of things. And that's what we need to worry about. So when we design any architecture, we need to always think of the potential attack points and the ways that a person could come in, manipulating people. It could be one way, coming in on the network could be another way. And there's all kinds of threats that come out. So we constantly need to be doing threat modeling. We need to be thinking of how attackers can get in and get various threat information feeds to tell us about new and emerging threats so we know how to protect ourselves against them. We always want to find a way to reduce the impact should something happen, reduce the blast radius. And there's lots of ways we can do things like that. We'll talk about separating our environment, but the key is we want to make sure that if something happens, it doesn't necessarily have to cause a big problem. I'll give you an example. Let's say we had 2 VPCs, or 2 virtual private data centers, as I like to call them. If we put everything in a single VPC, let's say we have HR and finance in here, if anything happened, we could potentially lose HR and finance systems. But what we could do is we could take one VPC, and then we could then we could have another VPC, and we could put HR systems in this VPC and finance systems in the other VPC. And we can make sure these 2 systems can't even talk to each other if we want. And we can still use IAM, but we have a lot of things we can do. Whenever you start thinking with security architectures, you're always going to be looking how that attacker would come in and how you can mitigate or reduce the impact of an attack if and when it occurs. One of the ways you can do, which you can help, is implementing very granular IAM policies. So you know exactly who's going to be using the system. So when we talk about IAM, we're really getting into who can use what. So let's talk about the authentication piece. Who are you, or who you claim to be? There's a lot of ways we've been doing this. If you've ever walked into a building and had to show them your ID, and a person checked your ID or scanned your ID, that's a form of authentication. They're really determining who you are. Now, we can use a lot of forms of authentication. So we can use something you know, which I don't recommend using passwords or PIN numbers, but something you know is something that you know. And we've all used passwords or PINs. Then there could be something you have as a means to identify you. I've got a specific token card with me. And if you go to a cash machine, well, actually, you have an ATM card. We'll talk about other forms of authentication in a second. And we can determine who you are based upon who you are. Your fingerprint scan, your iris scan, the sound of your voice, which sounds terrifying to me in the world of AI replicated voices, but we can do things of something you are. So when it comes to authentication piece or identifying someone, we've got a lot of options that we can actually use. Now, the more forms of authentication we use, the better it gets. They don't let you just stick your ATM card into a cash machine and get money out. You got to put your ATM card in the machine, and then you have to enter a PIN code. And that PIN code, where you're typing on the thing with the PIN code, is now 2-factor authentication because it's something you have and something you know. So there'll be lots of multi-factor authentications we can use. We can use tokens, text messages, lots of means to do it. We could use an iris scan and a password. So lots of things we can do. Passphrases, what have you. Keep that in the back of your mind. So what's really going on is we're having a server that's going to determine what you're allowed to do, and every time you want to deal with it, the client will go to the IAM server and say, yes, you're allowed to it. So I hope that kind of makes sense. Now, the next component we're talking about, again, I'm going to dive deeper, is the authorization piece. And Google would consider that to be a set of privileges that you have that grants the user access to a specific resource. So being denied access to the secret financial files is an example of authorization. Now, the CFO can get access to those files because the chief financial officer needs access to those files to do their job. And that's really what access management is about. Access management is about giving access to those who need it and keeping access away from those who don't, which is a great way to enhance your security and what's allowed to be done on your systems. Because if you can't access the system, you typically can't take its data, or you can't harm the system either. Now, I mentioned accounting is keeping track of what someone has done. And I gave you the example of tracking my credit card receipt for all the things my cat Cindy buys when she takes my credit card. But she's a good cat. She's a very smart cat. So the accounting piece is that logging piece. So Google's going to give you some of these logs. And you'll get cloud audit logs, which is going to be Google's platform level logs that will track access to resources. And you're also going to get application logs. And this is going to be audit trails of the applications themselves and the applications logs. So you get your logs from the cloud, and you'll get your logs from your application. And truthfully, you're probably going to be getting logs from your firewalls, IDS, IPS systems, and other things, which will ultimately use what's called the SIEM system to aggregate these logs and then to be able to correlate events if and when they happen. But that's way beyond this course, although I'll probably touch on it later if there's more security modes. So why are we doing all this logging thing? We're trying to get to the point of something called non-repudiation, which is if Billy Bob accessed the systems and broke something, and Billy Bob, were you here? No, I didn't. He wasn't here. I didn't touch the system. Well, Billy Bob, I got access to your lab. Oh, so that's why we're doing the logging. And it's an example of a person saying, I didn't break into the building, but having the security cameras that said, yes, you did. And that's what we're dealing with this concept of non-repudiation. So think about this. Let's talk about an IAM scenario in action. So let's say you want to enter a secure area of a building. You enter your badge, which is hard to get, and the badge determines which rooms you're allowed to, and then you answer a question or enter a password. Now, the authorization piece is you've got access, you've been allowed to the room, or no, you're not allowed in. And then the accounting piece is maybe there's a video camera that takes a photo of everybody that enters the room at the time they actually enter the room, and they follow the person around, and there's cameras, and then all of a sudden they've logged every activity they did, and they have provided video proof. So this is what we're talking about from that AAA IAM perspective. So let's talk about implementing IAM in large organizations. It gets big, and this can be a big topic. So what happens when we have an organization with global operations? And they're going to have companies in different parts of the world. Employees are going to have different access requirements. There'll be different legal requirements in all these environments. Now we're going to need something pretty deep. We're going to need something that is going to be robust, it's going to be easy to manage, and it's going to be enforceable. And in many cases, this gets us to what's called centralized identity and access management. Now, there's lots of ways you can centralize your IAM. You can distribute it. There's a lot more things that is way beyond the scope of the Google Professional Cloud Architect exam. But you'll hear much more about it in the CCSP and CISM exams, and even CCSK exams and training. And there's free resources for those on side of our YouTube channel. So please enjoy. So keep that in the back of your mind, and understand that defense in depth is still important. And I'll explain what defense in depth is, and we can use it with IAM, and we use it with other structures. So imagine we've got a castle to protect or an important application, but let's say castle. I mean, I want you to think of where IAM actually fits in. And in the cloud, it may be our only choice, but let's talk about environments where we needed something more. So let's say this is our castle. And I want to show the difference of where IAM fits in. So if we actually had a castle, if we really wanted to protect this castle, I'd make sure that maybe there was a wall around the entire castle. And I'd make it a big, thick wall. So let's talk about this wall. This wall might be 100 feet high. This wall is going to be very, very secure. And I'll tell you what we would do with this wall. So we'd have this wall over here. And that we would have a hard, strong gate that can open and close. And of course, and this way we could let people in when we need to, but not when they didn't want to. Now, imagine we're protecting the king, so we'd probably put somebody on the roof that could protect these things. So we'd put some warriors on the roof. And by having warriors on the roof, if anybody tried to scale the roof or there was a problem, the warriors on the roof could remove the threat prior to them even to getting there. Now, I wouldn't just have a bridge that comes into the castle that is automatically there. I would probably have like a lake or a moat. I'd have this thing surrounded by water. And the reason I would have this thing surrounded by water is if it's surrounded by water in all different directions, it's not, oops, bear with me a second. So if this thing is surrounded by water, and there's water absolutely everywhere, bear with me, I'm going to draw the water. For now, you would have to open the gate, and if you didn't open the gate and somebody tried the walls and the warriors couldn't stop them from climbing the walls, now I'd have this water thing to contend with. And if it was me, I'd fill the water with hungry sharks or hungry alligators. So in other words, the person would have to either break through the gate without getting taken out by the warriors that are sitting on the roof, climb this 200-foot wall. Then if they manage to get past through all of this, climb through the water, which is filled with sharks and alligators and something scary. And then I'd actually have some other guards over here. And these would be scary guards. And I'd have these guards here. And the guards would protect anything that managed to get out of the water. Now, of course, if the castle people wanted to leave, all they would have to do is open the bridge and they'd be outside. So it would take a lot to break into this. But now let's see where identity and access management actually would come in. So here, the person would have to breach the high wall, not get harmed by the warriors, then manage to get past my shark and alligator infested water. And if they finally managed that, they'd have heavily dangerous guards here. And then when they'd finally get to the door, they'd say, "Hi, I'm Cindy the cat. Am I allowed in?" And the IAM would say, "Yes, you're Cindy the cat. You're allowed in." Or somebody breached the system, and now they try to get in, and they say, "What's your username and password?" And they don't have it. So this is where the IAM piece typically fits in. It was always the last line of defense, because at this point, IAM is you've gotten there. Am I allowed in or not? And what can I do? All of this stuff was keeping you get from the IAM place in the first place. But in cloud computing, it's much harder to protect this, because look why this is so easy to protect. There's only one ingress point, and that's the gate, and only one egress point, and that's the gate. In the cloud, we may have people coming at us at all angles when we have highly distributed applications. So let's think of some key considerations for our cloud security environment. We want to implement a consistent and a secure identity and access management solution across our global operations. We're going to have to do other security measures too, but at least for identity, because this is the identity and access management segment, understand we're going to need heavy duty IAM to make it work in the cloud environment. We need to be able to audit systems from an accountability perspective, and in many cases a legal and compliance perspective as well. We strongly suggest that nobody use just a username and password. Google doesn't tend to recommend it at all. Use some flavor of multi-factor authentication when possible, and things that are more dynamic like tokens whenever possible, to protect against unauthorized access. Especially this way, if credentials get compromised, they're temporary credentials. If they're tokens, and they won't, the amount of harm someone can cause is typically much less if a credential expires in 30 minutes than if they had a password for, say, 6 months. So those are the core concepts we've talked about: the principle of least privilege, the separation of duties, and now we're going to talk about some more about IAM.
All right. IAM, to me, it's kind of fun stuff, but then again, I've always been in security in some way, shape, or form, security architecture, network security architecture. So I wanted to see if anybody has any questions. And if so, we'll take a few questions here. Also wanted to remind everyone that on Thursday, every Thursday we do this, we'll have a How to Become an Architect webinar, where we'll go over what we do in the architect role, the skills you need, what hiring managers are looking for, how to bypass HR so you don't get auto-rejected, all those kinds of things. And it's completely free. It'll be on Zoom. You can come, you can ask any questions you want, and we'll do anything we can to help you and answer your questions live and free on Zoom. So I wanted to remind everybody about that. And we also, if you just joined us, there's my team put up a playlist that starts at day 1, so you can go back and catch the first day, which was yesterday. And we also have a free ebook that you can download. It's about 550 pages to help you pass this exam, that's going to correlate along with this course. So if there's any questions, great. If not, I hope you guys are having as much fun as I am with this kind of content. So I love talking about anything related to security, all kinds of security. So are you guys awake? Am I keeping everybody awake? I don't want anybody falling asleep on castle architecture and documentation like that. So if you're awake, let me know you're awake. Give me a hashtag Google Professional Cloud Architect. If you're enjoying the content, maybe give the video a like, maybe subscribe to our channel and hit the bell to be notified of new videos to help you in your architecture career, whether it's a cloud architect career, security architect career, AI architect career, enterprise architect, or network. So give me a hashtag Google Professional Cloud Architect, and I guess we'll get back to the content. So nice to hear that, Tish. And if any questions do come up, please feel free to bring them in the next break. We want to do anything we can for you with this Google Professional Cloud Architect training. And thanks. I think it's fun. I love this kind of tech stuff. All right. I see a lot of people are awake. They're learning. They're having fun. Now I feel great. Chris, let's get back to the content. And if questions pop up, we're excited to answer them next time.
Continuing our discussion on identity and access management, I'd like to begin our discussion on role-based access control. And I'm going to map it out for you with a graphic, but I want to let you know why we're doing role-based control and what it actually is. So imagine you have an organization with 100,000 people, and somebody manually had to enter all 100,000 users and give each user the exact specific rights they needed to do their job. Now imagine over the course of a year, people move around, they change jobs, they need temporary access to something and vice versa. So a lot of complexity is going on. So imagine first having to manually enter 100,000 users and get their privileges right without making human error along the way, and then deal with the changes of permissions. Well, I hope that sounds near impossible. So what if the moment you hired someone and HR hired someone, they were given a job? You're a sales engineer. And as soon as HR entered that person that was hired as a sales engineer, what if it automatically kicked off a system that basically said the sales engineer needs access to these certain things. So we have a group of sales engineers and we'll add the user to it. All done automatically by the HR systems. So let me whiteboard this out because it might be hard to visualize without it, but this is what we're actually talking about. So instead of having different rights for every user, I can, from a management perspective, create a group of users. And these group users could be systems administrators. These users could potentially be sales reps. Users could be sales engineers. Users could be managers. Doesn't really matter. So what happens in the most scalable way to do this is, let's say Cindy gets hired. My cat's very smart. She's been desiring to get a job. So let's say she gets hired. Now, Cindy, I can tell you, is an excellent manager. And the reason I can tell you this is I do whatever she tells me. She just looks at me. She makes a sound that I do whatever we want. So we hire Cindy as a manager. My cat, Cindy. Now, Cindy is hired as a manager. So as soon as she's hired, she needs access to certain management systems. So HR adds Cindy to the manager group. And then the managers have need access to these 10 systems. So it's a compensation system they need access to. They need access to a vacation system to approve PTO. They need a performance rating system, so they have access to this. So as soon as Cindy's hired, immediately she becomes a manager. The manager is Cindy's role or Cindy's job. And what's happened is the permissions are added to the manager. And then Cindy's added to the manager group by HR provisioning the system. And now Cindy can access all the things she needs for her job. Now, Cindy desires, because she's a mischievous little cat, to have access to the systems administrator's information. And when Cindy moseys herself over there, she gets denied. So that's what we're talking about. We're talking about creating a job function giving specific privileges to that job function, and then adding the user, like adding the user Cindy, to that job function. That's role-based access control. And I hope you can understand how that would relieve the human error mistakes trying to provision these systems, make it easy to change things. Someone changes from manager to director, now they need access to new systems, and maybe some of their old accesses are actually pulled. So that's how we're working with role-based access control on all cloud providers, and truthfully in all data centers for the last 30 plus years. So the separation of duties we talked about, and we're going to talk about it a little more. The key is to make sure one person can't do too much. You may notice that militaries have weapon systems. In order to launch some of them, it takes 2 people to do it. And they typically have to be 2 people of very high rank to do so. Well, it's the same thing that we're trying to talk about here. We want to reduce the number of security incidents, and we want to reduce the impact of a security incident. So we have to think about all these things. Now, when we're dealing with a cloud architect or a cloud security architect, we have to understand a lot of things. We have to make sure the systems are secure, but we also have to make sure the systems are still usable, and the systems function properly, and the systems perform properly, and most importantly, that the systems actually do something for the business. So we want to be thinking about these kinds of things, but at least think of using multiple security controls. Defense in depth and zero trust kind of merge them together, and then you get to your goal. And zero trust, which is heavily used in cloud computing, is more about micro-segmenting your environment, encrypting absolutely everything, and then for every single request of a system, determine if the user has access. And if it does, give access. And if it doesn't, deny the request. So now let's think about something else. I want you to think about the dynamic nature of cloud computing. Spin up 10,000 virtual machines, close down 10,000 virtual machines. Take an application that you have, roll out a brand new one quickly and easily and dynamically. You're on one cloud, and all of a sudden something happens to your main cloud, but your systems and data is backed up to another cloud, as well as images of your virtual machine. Launch an infrastructure as code script and bring it up immediately. And, cloud computing may cost more, but the ability to create a script and immediately deploy an infrastructure in seconds or minutes versus weeks and months or years is incredibly powerful. So we want to understand that we have infrastructure as code tools. So when we do this, we want to provision the virtual machines, the technology the right way. And we need to make sure that any orchestration engines we have are patched and secure and we're using it properly. And we want to make sure that the operating systems of everything we have are patched and booted, or whatever, when they're booted the first time, for example. And we need to make sure that we limit everything. So infrastructure as code does give you the ability to do a lot. And why is that? You can limit the users to producing things that only work, limited to a certain number of virtual machines, for example, with a specific operating system. As soon as the infrastructure come up, it can be set up to have mandatory controls that certain things have to be done. And infrastructure as code is not only a great way to improve efficiency, but it's a way to input some governance in your systems. A user wants to try something, install something, but they can't because they're not allowed. And in many cases, this can be a big boom to our security. So thinking about security with regards to some of the administrator privileges that we can give people in some of the roles, let's think about that. We have to be careful that roles like super admin are limited to those who need it. We have to make sure that stuff isn't exposed to the internet that is not supposed to be. And let's be fair, that's the easiest way to get hacked. Keep your systems that are not needed to be reachable from the internet away from it. The internet's full of all kinds of bad actors. And if you ever look at a business's firewalls, you'll see people trying to hack it every couple of seconds, every couple of minutes, depending upon how big the business is. If it's a big enough business, you'll see people trying to do hack attempts every second, every minute. So it's constant. So we need to think about the way we design our systems. We need to think about how people could actually get indirect access as well. For example, there's lots of ways to do remote access and do it very well. One of the mistakes I've seen people make is the use of a bastion host. And I'll show you how this could provide indirect access. So normally when we have a system, we protect it on the internet. But imagine having an internet here. And here you go. You've got the internet. And for some reason, somebody thought the best way to get in would actually be to put a virtual machine here. And with this virtual machine, it has two network cards. One that's attached to the internet, and the second network card is attached to the private centers, private databases, or let's just say the private systems. Now, this is pretty terrifying because people leave this virtual machine here. Here, the Windows Remote Desktop to it or the SSH to this virtual machine, and they'll jump in. But see, you have this virtual machine on the terrifying internet. This is scary. Now, if you wanted to, from the internet access to some form of remote access, there's lots of ways people could do it in a more secure environment. For example, they could have their ISP here. And after the internet, what they could do is they could put a network load balancer, for example, if they really wanted to do it, if they were really careful about it. And behind the network load balancer, they could put a couple of virtual firewalls. And these firewalls are very good security hardened devices. And then behind we could use these just as firewalls to segment the system, or we could do remote access to those firewalls. But let's say we wanted to get really careful. We'd use one set of firewalls to protect the system, and then we'd have another set of firewalls. And off of these firewalls, for example, we could create a demilitarized zone. So, and in this demilitarized zone, which is still outside of our environment, hold on, let's draw our private environment to show you how you could get much more careful. And here's where we would put something called the VPN concentrator. Now, the VPN concentrator, which is effectively a firewall on its own, the only thing that would be allowed on this subnet from this firewall is going to be the IPsec port, which is just the IPsec ports, which I'm drawing a blank on right now. So we only have to allow through this firewall, these firewalls, bear with me. These firewalls can inspect the traffic and make sure the traffic is good and look for any patterns of behavior that are going on, like somebody wants to start a DDoS attack, for example. These firewalls check the data and make sure everything's good. And then the second set of firewalls does this verification check and then only allows IPsec to the VPN concentrator. Now, from here, we can bring the VPN concentrator back. But the key here is this VPN concentrator was made by a security company that specializes in this, and they know how to harden the operating system. And we're using firewalls to protect and make sure that the only thing that gets to here is the VPN is IPsec to the VPN concentrator. It's very different than the Bastion host, which doesn't have commercial enterprise next generation firewalls protecting it for remote access. So let's start thinking about more security measures. So we want to make sure we limit the rights that we're actually using and making sure we don't have direct or access to the internet or indirect access to the internet. So you need to think like an attacker when you're trying to secure systems or protect things. You have to think, if I was going to attack, how would I do it? And that way you can think about the vulnerabilities or the weaknesses you have in the system and how you would secure it. To be fair, in a real enterprise environment, we hire ethical hackers or people to break into the system so they can tell us how they did it so we can find the weakness of the system, because you can't necessarily be objective with yourself. That's why lawyers don't take themselves as a client, and you need an external perspective. So kind of keep that in the back of your mind. Assume people are trying to attack you at all times, because they are when it comes to cybersecurity, and then think about what it takes to do this. So you have to design systems assuming that a lot of things are going to go wrong. Murphy's Law, whatever can go wrong will go wrong. That needs to be part of your system design. So you need to think about multiple parts of the system failing and still being up and running and secure. And we're going to minimize risk through careful design planning and security practices. Again, this is way above anything in a Google Professional Cloud Architect. This is security architecture that we're dealing with. Keep that in the back of your mind. But this is what's covered in the exam. So the key takeaways is separate duties, make sure two people can't do one thing, implement the principle of least privilege, and for the purposes of this exam, use role-based access control, use infrastructure as code to limit and secure what people can actually do, and design your systems to reduce risk. Look, when it comes down to it, there'll be other types of identity and access management, things that might be smarter than role-based access control. We will have things like attribute-based access control and context-aware identity and access management, and these get much more sophisticated in their protection level. There's videos on our YouTube channel how to do that, but it's not inside of the content of this program or the Google certification. And I want to keep it as somewhat focused to the certification, although we've added a lot of additional context to help you. So now we go back to the Google services, and we have the cloud identity. And the cloud identity is that identity as a service that provides that unified platform for identity and access of our environment. Now, when we deal with these things, we have a concept of an identity provider. And an identity provider is a third party that we typically talk about that provides identity services. So it could be Active Directory. If you ever go into a website and it says log in with Facebook, log in with your Google account, Google is the identity provider, and people are connecting to that or federating to that. So when we connect to identity providers, it does a lot for us. So let me give you an example of why we might use certain things. So let's say we have two cloud providers, which everybody does, at least two. And let's say this is AWS, and let's say cloud provider 2 is going to be Google. Now, we could attempt, and let's say the users are using both systems, we could attempt to manually do our identities in AWS and manually do our identities in Google. That gets really ugly. We can basically deal with an identity provider, and with an identity provider, with an identity provider, what'll happen is when you're on, if you logged into Google and needed what happens when you go to log into Google, it'll ask the identity provider, does the user have the account, and the identity provider will answer Google with all the information that it needs. And then Google will use the information from the identity provider to determine if you're okay. The same thing would happen here. It's typically called federation. So what you're doing is you're trusting the identity provider and you're using their information. So if your systems on AWS trust the identity provider and your systems on Google also trust the identity provider, ultimately what needs to happen is you make the changes here on the identity provider, and those changes are withheld on all your cloud providers, because the identity provider becomes the source of truth, or the master identity provider. Now, in order to connect to various identity providers, you typically need a protocol that will connect to them, a language. Because if I'm speaking Greek and someone else is speaking French, we got a problem. But if we're both speaking Greek, it's good. Now, what's the population and the chances of me speaking Greek to someone? Well, I think there's 10 million people 10 million Greek people in the world, or something like that. 15 million people, 20 million, not that many of us. So chances are it's not going to be very easy for me to find somebody to speak to them in Greek. But what if I spoke to them in English? Pretty good chance someone's going to be able to speak in English. Or what if I spoke Arabic? There's a pretty good chance somebody's going to speak Arabic. And potentially Spanish, there's a pretty good chance somebody is going to speak Spanish. So I can create a few official means or languages to connect to other environments. And we're going to talk about two very common ones, and one's going to be SAML, and the other one is going to be LDAP. So SAML, or Security Assertion Markup Language, is an open standard for exchanging authorization, authentication data to a identity provider. So it's like saying, we're all speaking English. And that's one form of the security assertion markup language. It's commonly used, it's the standard, and it's going to make it easy for systems to talk to each other. We can also use LDAP. Active Directory tends to use LDAP as well. And it's going to be an open standard that enables directory services to talk to each other. So it's a similar language. So let's say that's one's like speaking French, or because for a lot of people speak French. So, okay, we can speak over the French protocol, or we can speak over the English protocol. So SAML is one way to do it. LDAP is another way to do it. Now let's talk about the types of identity we get with regards to the Google Cloud. And so let's talk about additions of cloud identity. So if we're dealing with free services in the free tier, we basically have user security management, and we've got upwards of two-step verification. We have some basic mobile device management capabilities. We have the ability to use Google Cloud Directory Sync, which we'll talk about, and we've got some basic audit logs. And we can collect them from the admin console. Now, if we need better, we can move up to the premium tier, and that'll give us advanced mobile data management tools. And we need device management tools. And device management tools enable you to figure out, like, of your 100,000 phones your employees might have. And device management tools may help you say, okay, these user devices need additional security and we're going to push it. Or the user's notebook was stolen, wipe it remotely before anybody accesses the data. So typically speaking, when you're dealing with device management, you're going to need it in the enterprise environment. And that's why it's there for the premium tier. LDAP, secure LDAP, a component of the premium tier, because let's face it, in the reality, nobody's going to be maintaining their IAM systems on the cloud. What they're going to be doing, ultimately dealing with, is they're going to be using some kind of federation or connecting to something else, often Active Directory, like which would use LDAP. Now, you will also in the premium tier have the Google Security Center. That's going to be access to some advanced security tools. The reality is you're probably going to end up buying more industrial tools to use across all your clouds, but these are very good tools. You'll be able to export your logs to Google BigQuery, which is a data warehouse. You'll be able to deal with that, and you'll get an SLA of 99.9% uptime guarantee. So on the premium tier, you've got some pretty good standards that you're getting, some pretty good IAM capabilities. So which do you use? Well, you may use the free tier if you're going to use existing third-party tools, because you may not need to pay for it twice. But the premium tier is going to give you much better security. And for organizations that need high levels of security, they're going to need the premium tier with some of the tools they're going to be working with and integrations they might need. So it depends on the organization's needs. When we talk about cloud identity, it does have its own benefits in that it's a fairly simple single platform to manage identities across your applications and endpoints. It's integrated very seamlessly into Google services, which that makes it easy, and many third-party services. It supports advanced security features like SAML and secure LDAP, which is obviously important. It tends to scale based upon the tier that you're actually using, and it tends to help an organization meet compliance needs, like audit logs in the Google Security Center, because it's an IAM system, and IAM systems help organizations stay compliant. So let's talk about managing identities. So as cloud architects, we're not going to touch these technologies ever. We're not going to be allowed to in our job. But cloud admins and cloud engineers will be touching the technology all the time. So when it comes to being able to manage users, at some point, we're going to have to create or import users. The engineers would be doing those. And they'll have to understand how to manually create user accounts in the Cloud Identity Directory. They'll also have to know how to import the existing user accounts into Cloud Identity, potentially from other directory providers. So for the cloud engineers that are going to be working on these things, that's where the accounts will be created. For the people that will be managing this, isn't this also often the sysops role that are going to be maintaining these identities over time. Now, at some point, the user's lifecycle will also need to be managed. When a user comes into the company, there'll need to be an onboarding process. There needs to be a procedure for adding new users to the Cloud Identity Directory to make sure they have the necessary rights and permissions. So that needs to actually occur. As users move from one role to another role, we need to manage their prescriptions or their permissions accordingly, because they may not need access. And the worst thing we can do is what is called privilege creep. And privilege creep gets scary, and we have to deal with that from a security perspective. This is privilege creep. I had a person, and this person was a manager. And because they're a manager, they get access to manager systems, right? And for some reason, the manager decided that they wanted to take a sysadmin role for a long period of time. They actually missed their tech days. So now the manager decided to take a systems admin role. Now, the manager needed access to these systems: finance, HR, payroll, bonus systems, expense reports. And the systems admin, by comparison, oh, this person needs network access to the routers, switches, the IAM systems, operating systems. Ugh. Okay, so you're seeing this. So imagine we have this user, and they've had these privileges, and now they take a sysadmin role, and now they get these privileges, but nobody ever took their privileges away. Now the manager, who decided that she didn't like being a sysadmin, and she didn't really love being a manager, decides she's going to do another role. So now this person, the manager who's now the sysadmin, now this manager goes to marketing. Now all of a sudden, this person needs access to market research, advertising systems, budgets and systems. Now, if we're not careful, and we didn't change the person's or take away the person's permissions that they didn't need for the job, at the end of the day, we have a marketing person that now has the ability to delete parts of the network, delete servers, access the finance system, and when they really only need access to do is market research and advertising budgets. That's called privilege creep. So the key here is it's going to be responsible for, we have to be responsible, and the people that are going to be touching these identities need to make sure that as people change jobs, they don't keep their old permissions. Their old permissions get taken away and they get new permissions that are related to the role. So when we bring the person in, there's a specific set of procedures teaching the new users what to do. As the user changes roles, guess what? Their permissions change along the way. And as the person leaves, we need the proper procedures to collect equipment, offboard people, terminate the person's accounts and permissions in order to make sure we maintain security. Now, when possible, we want to use more than one single form of authentication. So that brings us into two-factor authentication. You may hear Google call it two-step verification. And basically, it's using two forms of authentication to prove you are who you claim to be. So I log in, I enter my username and password, and then it asks me for a token. I give the information from the token from the card that I have, and then it gives me access to the system. So we really want to try and make sure that whenever possible, the people that are configuring the systems will set up and enforce two-step verification for users. Now, we also may get involved in something called single sign-on. And single sign-on is when you log into one system, you'll get access to other systems. And by doing it, you don't have to log in 10 times per day. Now, by doing so, there's things that it can handle, and I'll whiteboard it out for you a second. But we can use cloud identity as the identity providers for the single sign-on, where cloud identity will give us the ability to use other things, or we can use a third-party identity provider. So let's talk about why organizations are doing this. Early in my career, here's what ultimately would happen. You would see someone's desk, and they needed high security into 10 systems. So you'd go to their desk, and here's what you'd see on the monitor. You'd see the monitor you'd see a username and a password, and it would literally be on a sticky note on their desk, and it would be for finance. And because they had 18,000 other systems, they'd have another sticky note on their desk for the routers. And what would happen is the person would have 10 and 20 different sticky notes on their desk. This sticky note is going to be for secure, let's say, firewalls. And because it was so complicated for the person to remember all their systems, what they did is they cheated. And ultimately, they ended up reducing the security because we forced out lots of passwords, and it was a problem. So there was one problem with multiple accounts. The other problem is if it takes 2 minutes to log into this account and 2 minutes to log into this account and 2 minutes to log into this account, and a user has to log into 100 accounts a day, that's 200 minutes, which is nearly 4 hours logging in and out of accounts. So I hope you could see that's kind of icky. So we don't want that. Instead, what we want is something that's called single sign-on. And single sign-on is going to be this. When I first want to sign on to the system, I'm going to sign on to a system. Now, we're going to make sure that this sign-on is going to be a secure a good, strong, I know who you are. So now Cindy the cat, and we've seen Cindy before today. So Cindy signs on to this system. And now Cindy goes to the fancy tuna store because she's allowed without logging in again. Now my cat also likes shrimp, so she goes to the fancy shrimp store. And while she's at it, she really likes turkey. Now, it's only Boar's Head brand turkey, but she decides to go to the fancy turkey store. And the key to remember with this is she's only logging in once in order to get to these systems. She signs on, and then she doesn't have to sign on to any of these systems. And because Cindy doesn't have fingers, she has paws, it's pretty hard for her to sign on the system in the first place. So she likes signing on once, and then she gets her tuna, her shrimp, and her turkey. So that's why we use single sign-on. It makes it easier for our users, and it protects them from doing scary things. So when we think about managing users and cloud identity, we want to think about user account management, and that's going to be that our accounts need to be managed effectively from the time they're created to the time they need to be modified to the time they are deleted from our systems. We can use role-based access control to manage our permissions, at least for the purposes of your exam. Some best practices include to regularly review and update our security policies, use two-factor type authentication and single sign-on. And we want to maintain, from a compliance perspective and an audit perspective, strong and detailed logs of everything that we actually need.
Okay, we are back. We are here to answer any questions. It looked like 2 fun ones actually popped in while we went through the discussion, and we'll do that. So I see there's a couple of questions, but if you've got some, ask some. The first one I know is going to come in about a Bastion host, and we're going to architect that one, and I really want you to see it and why no one ever needed to use this in the first place, or should have. Hi, Mike. So the Bastion host is not a best practice. No, never. So what if servers are in private subnets and need troubleshooting? How quickly do you do this, and how do you do it? So let me show you what we've actually done for the last 30 years in almost every environment. In fact, the only time I ever heard a person even talk about a Bastion host was during a cloud provider certification, and the people that were talking about it, honestly, never worked in the cloud, didn't know anything about the cloud, so they were making it look like this was the way to do it. So let me show you how normal organizations do it. So let me just bear with me. I'll make sure that I get to the right size here. Oops, bear with me. Okay, so if this is where my campus is, first understand that most people still have some servers and things in their facility, but let's just say this is where my campus is. Now, that's where my employees are. Now, the campus is always going to be connected to the cloud. Otherwise, you won't be able to reach the systems on the cloud. So let's say this is your cloud provider, And these are all your private subnets, which is basically where all your data, all your applications, all your everything is. So what happens is we have to create a wide area network to the cloud provider. And we either take a private line, and we typically use a private line, which is basically a wire that you purchase, an Ethernet cable. There's some subtleties, but you own that wire. You can encrypt over that wire, and then all the work is done from the private systems through a private wire with encryption on it to the private subnets. Now, this could have also been an IPsec tunnel between these two environments. It could be a software-defined WAN, like an SD-optimized WAN. It could be a secure access, secure edge WAN, but realistically speaking. Now, that's what we've always done. Now, let's say we have a remote access user that needs to get onto this campus. So let's talk about how we normally do remote access for management in a high security environment. So let's say here's your internet connection. Right behind your internet connection, you're going to have, typically speaking, more than one firewall. So let's say it's in a cloud provider, or it could be a data center. We'll have a network load balancer, and we'll typically have a layer of firewalls. Now, will typically be a next generation firewall. These are hardened devices, and we're going to be really specific, and we're going to say that no traffic is allowed in here at all, like zero. Nothing will be allowed in here at all, except for whatever we allow. Now, let's say it's a really high security environment. We might use another set of next generation firewalls. And then what we might do behind here is put a load balancer. And this is normal remote access at most companies. And behind the load balancer, we'll have two VPN concentrators, which are basically firewalls. And what we'll have is VPN. So in order to even be able to get here, we're going to set up an environment where they're going to have to go through the internet. Our internet traffic will be protected by next generation firewalls. These firewalls will look at the traffic, make sure it conforms to a policy, what have you. And the only traffic that's allowed in is IPsec. Now, this then goes to another hardened system. That's two more firewalls that are going to verify it. Now, as soon as the request is going to hit this VPN server, the VPN server is then going to say, okay, do I allow or not allow? So then the VPN server is going to go into an IAM system. And if the VPN server allows you into the IAM system, it'll take you back to the campus, which is where, again, you can manage over this environment. But note, in order to go through the internet, you typically have to go through real extreme filtering from a couple of sets of next generation firewall. And these VPN concentrators are security appliances that are built by experts in security to know how to lock an operating system down and make sure it's not hackable. Now let's talk about the exact opposite, which is the most risky thing in the world, which is called the Bastion host. So over here we have the internet. This is where all the hackers live. And on the internet, in the middle of nowhere, for no reason whatsoever, we're going to put a Windows or a Linux system here. We're just going to put an exposed host in the internet. And we're going to basically give it a public IP address, a public subnet, or an external IP address. And then on that same host, we're going to put another NIC or another port, which is going to be a private address. And this address will be in the same subnet as all your other stuff. So what any hacker can easily do, and this is going to be nothing to do, is easily just hack into this host, and now they've got a back door. So you'll never see a Bastion host in a real environment. This was something that a bunch of people got certified in cloud architecture, didn't understand what they were doing, and started teaching it as a way to connect. And that's why everybody's talking about it, because the people that didn't understand networking, didn't understand security, were teaching people to do this. And that became the way you backdoored into your cloud. But then again, that's the way the hackers backdoored into your cloud too. So most organizations got rid of that. What happened is Azure looked at it and said, these people are doing this. This is crazy. So we'll make a remote access service and call it Secure Bastion. Amazon saw that and went, wait, these people are going to get hacked. This is crazy. So they made their secure remote access. But what I showed you is what we've done for 30 years. You've always been able to do it and never needed this. Kind of hope that helps. When an organization opens a Google account for billing purposes, how do they ensure multiple people have access in case one person in the account leaves the company? Okay, so great question there. So the first thing is we're going to have root accounts, which we're going to lock up, typically speaking, and not share. And then what we'll do is we'll create a shared group or a Google share group. And basically, that's going to be an account that's going to be a billing account. And what we can do is we can create a billing account. We can assign various billing roles, like a billing administrator or a billing account viewer. And that way, what we can do is create a trusted set of people that can get involved in billing or purchasing, that kind of thing. Now, we can also link that bill to an organization-wide account, which we'll talk to later when we talk about our account architectures and things like this. And realistically speaking, that'll be a global wide account under centralized building. And that means it'll be managed through Google's Cloud IAM, and it won't be tied to a single person like if you signed up with a Gmail account. So that's typically what we do. But we are going to be talking about this and how to do this in this bootcamp. It'll be more towards the end, but we're definitely going to talk about that more. Darnell, does a cloud architect need to be a certified ethical hacker? Definitely not. Or understand the cyber kill chain or MITRE attack. So, Darnell, we actually have to really talk about what is the goal of the cloud architect. The cloud architect is to help an organization solve its strategic challenges. And that means the cloud architect somehow needs to shape the people, the processes, and technology. So what we really need to do as a cloud architect is understand the client's needs. What's the client's business goals, the client's business pain points, the client's challenges, the client's struggle. We need to understand what our client's competitive landscape is, what the client's business architecture is. How does that business make money? Where are the pain points and the processes that it actually has? From those given pain points and the processes in those given industry channels, what kind of a technology strategy can we create? Now, when it comes to creating a technology strategy, Darnell, I mean, it's going to take 15 to 50 people. The architect's not exactly going to build this thing. So the architect's going to have to create this design, which means speaking to a wide variety of stakeholders, understanding the organization's 50 to 1,000 applications, understand their tens of thousands of locations, understand all of their applications, all of their networking, all of their security. That cloud architect's then going to need to build a team so that team can understand it. You can start examining various business challenges and think about which trade-offs they have for various architectural options. Then that architect somehow needs to be able to create a statement of work, create a governance structure, sell the architecture to the team, build the business case around it, build a governance structure and those type of things, respond to any RFIs, RFPs, RFQs. And when it's done, it's time to go to the new client. Now, Darnell, if you ask me if a security architect needs, I would say no, they don't need to be an ethical hacker, but they need to know how organizations are hacked and understand what goes into security architecture. Now, the security architect would be things like application security, network security, identity security, physical security, security policies, disaster recovery planning. So it's all going to really depend on exactly which role you want. But nope. Most architects don't know how to break into systems. Most architects probably wouldn't even know how to touch the technologies, especially if they've been an architect for a long time. Architecture is strategy. But Darnell, why don't we talk about this on the How to Become an Architect webinar? And I will tell you, if I'm looking for a security certification for a cloud architect, I generally recommend the CISSP. In fact, when I train architects, the 3 certifications I teach them, one is a cloud professional, one like the Google Professional Cloud Architect or the AWS Solutions Architect Professional, the Azure Solutions Architect Expert. One is a TOGAF, which is an architecture framework to ensure digital transformation. And for security, I usually use the CISSP because that's kind of like this blanket, everything you probably wanted to know a little bit about security. And it also gives you good technology underpinning. So that's why I typically like that. But no, you definitely don't need to be a certified ethical hacker. Okay, well, if there's any other questions, please ask them. To let me know you're awake, alert, and oriented, maybe give me a Google Professional Cloud Architect. If you like cats, let me know you like cats, and I'll make more cat demos. I don't know. I just love cats. Admittedly, I'm a little bit of a cat cuckoo there. The next video we're going to play is short, so if you've got any questions, don't worry. We'll be back very shortly. Chris, we can
Continuing
start
our
moving
discussion
into the
on
content.
IAM, we're going to talk about creating the identities in Cloud Identity and Access Management. And the sysadmins that are going to create our identities are really going to have 3 easy ways to do it. They can manually create individual users' accounts and groups directly on the admin page, the Google admin page that you would configure. The alternative is you might have an enterprise and they may export all of their identities into a file, and then that file can be bulk uploaded and then used as a way to create identities inside of the Google Cloud. It's called a bulk upload. Or we can simply import accounts. So we can import existing accounts from either Cloud Identity or maybe say Active Directory and make life real easy. So we want to keep that in the back of our mind. Now, we have this concept of Cloud IAM and also Cloud Identity. So I want to make it very clear what these 2 things are. Cloud Identity is an authentication system. So that means Cloud Identity determines who you are or who you claim to be. Now, Cloud IAM actually does the permissions and for the user. So if we think of when you try to log in, Cloud Identity will say, yes, Cindy the cat, you are Cindy the cat. But the Cloud IAM says, Cindy the cat, you're able to access this one system, but not the other system. So kind of hope that makes sense from the system's perspective, what's going on in the interplay. So the key here is to try to make things easy whenever possible, to use more than one of these systems, use a layered approach to security. Everywhere we're using a layered approach to security, but understand there's going to be separate interfaces for Cloud Identity and Cloud IAM, and it's going to be a layered approach. But the point here is to be fairly flexible the way these accounts are created. Google offers a lot of ways. It could be manually done. It could be bulk uploaded. It could be imported from something else. Kind of keep that in the back of your mind. That's what we're really talking about these Cloud IAM and Cloud Identity services from Google. So if we think about this, let's talk about Google Cloud Directory Sync. So it's probably not going to be super feasible to be managing multiple cloud providers' identity. And the point is we have this concept of the Google Cloud Directory Sync. And what is it really doing? Well, it's doing a few things. It's giving kind of a centralized management environment to the user that's going to have what they need to actually access the system. It's going to come up with an automated sync, which is going to make it very easy, for example, to be able to synchronize our identities across our environments. And by doing so, it puts us in an environment to make it very easy to deal with IAM in our environment. So I kind of hope that makes sense of what we're dealing with Google Cloud Directory Sync. It's going to integrate very well with LDAP. And by integrating with LDAP, it'll connect to Active Directory and other directory services. And that'll make it easy to synchronize the information. And it'll be a one-way sync from the LDAP server to the Google Cloud. And it will be able to synchronize users, groups, organizational units if you're using them, aliases, profiles, even shared contacts from LDAP and Google Cloud Identity. So it's going to give you a lot of abilities to make it a lot easier to maintain your systems in multiple environments. And regarding provisioning users with Google Cloud Directory Sync, it can be customized. So it will support any kind of custom mapping of rules that are needed to settle the synchronization process. And the Google Cloud Directory Sync gives you a very friendly user interface that makes it very easy to kind of simulate your configuration before running the sync to actually prevent any kind of errors. So it's a pretty friendly, easy to use service that's doing these kind of things. So it's about getting your identities. As I mentioned, there's alternatives provisioning users like bulk uploads, manual creations, third-party tools, even a software development, even a directory API, and there's software development kits for that. So there's a lot of abilities to do this. So let's talk about some roles we actually have as it pertains in the Google Cloud as we're dealing with cloud identity. Now, one of them is going to be something called the super administrator role. And I can tell you what that is right now. The primary responsibilities of that role is it will manage user and group account lifecycles and security settings within the organization. So that's pretty big there. That's why it's called the super administrator. The super administrator has full visibility into their own organization and can be given access of cloud identity and Google environments across the entire organization. So by default, you've got access to your entire organization, but you can be given access to others as well. And in multi-organization setups, this super admin can have visibility into everything. So this person, the super administrator, can manage cloud identity settings and see a lot of the resources. Now, because this super administrator role is big, you want to make sure that account is protected. So maybe you secure that with hardware encryption keys to prevent unauthorized access. Super admin controls typically bypass single sign-on and can authenticate directly with Google. So the best practice here is to limit the number of super admin accounts to 3 or 4 to reduce your security risks when possible. Maintain a backup security key in case one's lost. Provide a backup email account with 2-step verification for recovery purposes. And make sure there's not more than one super admin in an environment to make sure there's more than one super admin to make sure there's not a single point of failure. What happens if you only have one admin and something were to happen to them? So make sure there's more than one, but make sure there's not too many too. So let's talk about the organizational administrator role. Now that person's primary responsibilities is to define IAM policies and grant IAM roles to other users inside of the organization, determine the structure of the resource hierarchy in the environment, and this person delegates key cloud responsibilities by assigning them roles to other users. So this person is still pretty big, but it's typically limited to the one domain. And permissions-wise, they cannot perform actions like creating folders unless granted access to the specific role that allows such functions. So it's more locked down than the super administrator, but it's still got pretty significant permissions in this role. So let's talk about separation of duties and role delegation. It's recommended that you segment duties or have a separation of duties between super admins. Minimize the risk of malicious activity, minimize the risk of accidental human error causing a problem, and typically delegate roles and responsibilities to ensure that no single user has extensive control over the environment. So how should a user authenticate to the Google Cloud? Well, we've got primary methods and we've got other methods. We can authenticate without single sign-on. Realistically speaking, a user can authenticate directly with Google accounts without using any kind of single sign-on. And this method is kind of the least common in today's world because it's just logging on, single username, single password, that kind of thing, typically not very strong. Now we can do Google authentication with single sign-on via cloud identity, and that basically enables the users to sign in. The requests are checked by an identity provider, which is a great thing. We've got minimal overhead and we've got synchronization this way about all our clouds and all our systems. Minimal impact to the user. So we can have single sign-on with an external identity provider. So we've got the users that are going to authenticate with the external identity provider, like Okta or ADFS or Ping Identity. And most enterprises actually do this because it's simple. You've got one big system that you're actually dealing with, and the cloud providers connect to that. It's very interoperable. It's very holistic because now we're dealing with a single third party. If we're using that, it could be an identity broker or a cloud access security broker, but whatever it is, we're dealing with one company to maintain things for us, and we can use it across our environments. Now, one thing that's pretty important is two-step verification, multi-factor authentication. It's almost mandatory for privileged users. So you kind of have to do it. So you want to implement two-step verification, multi-factor authentication, or at least two-factor authentication for any privileged accounts. Because any account that can delete other accounts or access sensitive information, what happens if that user goes awry? We're going to seriously have some problems. So we need to make sure. And we want to do any kind of risk assessments as well for unprivileged users to make sure that even they have two-factor authentication whenever possible. Now, how could we do it? We could use SMS which is not going to be one of the secure methods. The challenge is it's vulnerable to hackers. If they steal the SIM card and you've got a text message, they could actually access your two-factor authentication. NIST no longer recommends using the phone for two-factor authentication, realistically speaking. So keep that in the back of your mind, but it's still better than nothing. Now let's talk about using voice. A voice print in the world of AI. How easy is it for AI to replicate voice? So let's think about other ways we can do it. So let's talk about other ways we can implement two-factor authentications. We can use backup codes, authenticator apps. We could do push notifications. So there's ways that we can do a little better. We start getting into authenticator apps, starts getting much more secure. So the key is these everything is still vulnerable to the hackers that we're really talking about. But if we're dealing with an authenticator, it's a lot better than a phone, which can actually be hacked. So we've got lots of ways we can do these types of authentications. We can use hardware security keys as a secondary factor. This is the most secure. It is going to be a hardware key that's going to have hardware security. It's going to have great cryptography in it. And typically, these are going to work fairly well. And they're going to be fairly secure. There's a couple of environments we can use for these kind of keys. But the point is they're hardware. They're very secure. And we can use that for two-factor authentication. And that complies with FIDO U2F, which is the Fast Identity Online Universal Second Factor Protocol. So two-step authentication tends to be very helpful. Now, the last part of IAM is auditing. Keeping track of the logs, who did what. And if we're going to maintain compliance with regulations, we're going to have to do some auditing. If we want security, we're going to have to do auditing. Sometimes in the auditing process, you find out that people have been in your systems and you didn't even know. That's called an advanced persistent threat, where people are in your systems constantly gathering information and you don't even know. So we have to constantly audit. Now, it'll be necessary to keep things secure. So there's places where we can do our audits. We can go to the admin tab and we'll have some user review settings. We have this user settings review, and we can monitor and review user settings to make sure that they comply with our policy. We can do tests of password strength if we're even using passwords in the first place, and we probably shouldn't be. We should be looking at audit reports that will give visibility into user logins and audit logs across our environments. We should be setting up custom alerts. So we get notified when people are doing things that seem or feel suspicious. So kind of keep that in the back of your mind. So if we have a user that has an account in the premium tier, they're going to get access to the security center, which theoretically provides advanced threat detection, and it will use advanced tools and features for detecting and analyzing potential security threats. And to be fair, they're very good tools. But in a multi-cloud environment, you may want to use a different environment that manages everything, or you manage multiple separate environments. The organization has to make those choices. But we want to get visibility and insights. And the Security Center does a good job of that. It gives enhanced insights into security-related events and other activities inside of the cloud environment, and it tends to integrate fairly well with security operations and make sure that the cloud identity logs are routed to the security operations team, and it's going to make it very easy for them to do ongoing monitoring and analysis. Okay, at this point, we've finished the cloud identity section, and we're going to get into the next section, which will be resource management.
Okay, we're back. Want to make sure we're here to see if any questions popped up, if there's an opportunity for any kind of clarification. Or anything else that needs to be. So, Chris, I'm not sure. Did any questions come up? I know you're behind the scenes. Do I provide any training on cloud cells? And how can a Google Professional Cloud Architect be beneficial for cloud cells? So, bear in mind, it depends what you mean. In our Executive Architect program, we provide a lot of training on cloud cells, because that's more for the architect that's reaching that executive level. Maybe they're also going to be in sales. Maybe they're migrating towards a CIO. Maybe they're migrating towards a CTO position. Maybe they're migrating towards a VP of architecture position. In any of these roles, there's a lot of sales. So there is a lot of there. Now, am I providing account manager training right now? No, I have been thinking about it. I have closed some extremely large. I think the largest deal I ever worked with was $1.1 billion. So I've been thinking about putting together maybe an account manager or global account manager program over time. But so the answer is I provide sales for sales engineers, solutions architects, strategy consultant, enterprise architects, that level of sales. Now, when it comes to the sales, let's talk about what really drives sales. It's not a certification. It's your ability to solve a customer's problem. If a company has a retail website that's generating $1 million a year in net income, and you're able to create an AI recommendation engine, and that recommendation engine takes it from 1 million to 10 million, and the recommendation engine only costs 2 million, then you made them, basically speaking, $7 million with your architecture. That's going to sell. So if we understand our customers' needs, and if we can find a way to build a business case to go solve that. If I have a hospital and I'm an architect and I can automate something or create some new technology that's going to increase the number of people that will survive and decrease deaths, I'll probably solve it. So the first thing we have to understand is we have to be relevant to the customer's needs. Do we understand this customer? Now, the next part of sales, Barrymon, is actually the exact opposite of what you'd find in a Google Professional Cloud Architect. It's actually being a trusted advisor. So if you want someone to sell someone to you, they should not have a bias of Amazon, Google, anybody. They should have a bias for customer success. Now, this is one of those places where vendor certifications aren't so great for you. Because if you take an AWS certification, it's designed to bias you towards AWS and make you excited about selling it. If you take a Google certification, it's designed to bias you. Which is why when we talk about the big heavy hitting certifications like TOGAF, or realistically speaking, CISSP, CCSP, CISM, they don't mention vendors. And even truthfully, if you were taking a Cisco certified internet expert exam, everything on that exam, you could basically swap the name and use it at Juniper or use it at Arista, and everything would be the same except for the command. So there is that. Now, the next side of sales is being able to quantify the customer's financial challenges. So if they've got $1 billion business problem and your technology is under $100 million, you can sell it to them. But if you can't quantify their business problem, you can't do that. Now, the next thing is understanding meeting the stakeholders. So going out there and meeting the stakeholders, getting the stakeholders' needs, understanding the stakeholders' pain points, for example, is something that else would go into sales. And then a solution that aligns the stakeholders' needs along with the key business processes and key technology that's going to solve a problem, you'll sell. Assuming you've got the right presentation skills, the right executive presence, the right business acumen, the right CXO relevancy, knowing how to plan an account, all the steps of account planning that go in there, from qualifying to determining what's there. So yeah, that'll help you sell. Now, a certification like an IT certification, not so much, because these are more about the name of something and how do you call it. But so let's how we talk about where you would do it. So let's say you're an account manager and you've got the kind of business acumen that we're talking about, MBA like business acumen, and you understand how to sell. You could say, when I was younger, I have the CCIE, and the CCA really taught me about networking. I never forgot it. It's near and dear to my heart. You could do that, or you could say, well, because I took the Google Professional Cloud Architect, I understand the Google product set and its service as well. And that would also help you there. But this is more of less of a sales rep certification, which is why you see SVPs of sales that are earning $2-3 million a year. They don't have a single certification on their resume. They may have an MBA though. And then you see a VP at a tech company that earns about $800,000 to $1 million a year on average. They don't have any certifications on them either. And then you see a director of sales, and chances are they don't have any, but I bet you they have an MBA. Or if they don't have an MBA, they have MBA-like business acumen. So I think we need to understand where the certifications are great for getting you an interview. But when it comes to getting hard, it's all about your skills. Good question. They're a little off topic, but I love questions that are people really getting to think about their careers. In fact, if you have a lot of career questions, Chris, do this. Set up a time from 11 to 12:30 tomorrow where I can answer any career questions. We can do it from, say, 11 a.m. to 12:30 tomorrow prior to the 2 p.m. boot camp. And that way, if anybody's got any career questions, I can dive deep on it. How does that sound, everybody? you like the concept, give me a hashtag or a thumbs up or a like or something like that, because it really do want to help. And Chris will drop a link for that as soon as he makes it. It may take him a few minutes to set that up. And in the meantime, let's get back into content and give me a hashtag Google Professional Cloud Architect.
In this chapter, we're going to discuss resource management from a scalable and a secure perspective. Now, this is going to be a big component of the Google Professional Cloud Architect exam, and there's a good reason for it. Organizations can get quite large, and we need a way to make them simple. We need a way to organize them and logically think about them and then manage these resources. And that's what we're talking about here. So Google has this resource manager, and it provides a mechanism to organize the things that you're doing on the Google Cloud, resources, folders, and provide policies to them like IAM policies. So it's going to enable us to create some security across a wide environment in a simplified manner. So I'm going to draw this out and show this to you and explain it to you. So the resource manager enables us to organize our environment. And at the top of our environment, what we have over here is we have something called the organization. And realistically speaking, this is going to be what you would consider to be a top level container. And it encompasses everything going on for the account, or at least the organization. So that means, whatever be virtual machines, containers, everything. Storage, it's all going to be part of the organization. Now, next down, and this is for centralized management purposes. Now, next down the list, we have folders. And folders enable us to group what we're doing by maybe a business unit, for example, or by a team, or by an environment, or about a project, for example, that a company's doing. Not a project in the way Google would look at, but a big project that a company might be doing, like a new location overseas that's going to also have a data center, that kind of thing. But in this case, they wouldn't have a data center. But some big project you'd be working on, you might put under a folder. But in this case, we have at the top, we have the organization, the primary responsible structure, the parent, if you will. And then underneath this, we have the folder, which are going to be a grouping that you can make of something significant from the company perspective. Could be a business unit, for example. And then underneath that, we have what we call projects, or at least Google calls projects. And these are going to serve as a container for resources that are going to be used by your account, like virtual machines, for example. And then resources are what's inside of the project. And multiple projects can be inside of a folder, and then they're there for the organization. And here's the reason why. You can apply a policy at the organization level, and it can be pushed to these other environments, at least some kind of IAM or security policy. And that can really help you manage security in a very simple and a very scalable way. So it's that hierarchical IAM policy that we're trying to get out of these. And the key here is the inheritance of policies. So I'll draw it out, or at least explain it one more time. So the key here is we can put a policy here, and then the folders will inherit that policy, and then the projects will inherit that policy, and even the resources will. So if you think about how hard it would be to manage everything separately, but the ability to set it up at the organization level and have things inherited, that's the scalability. So it enables a lot better access control. And that's what we're really talking about. Managing permissions at different higher levels. We can manage it at a single level, or we can manage it at the top level. So we get very granular and have a lot of opportunities. The resource manager also enables programmatic management. So that means managing things over, say, an API. From a change management perspective, we can look and see what changes were made. We can look at, say, the change history, and that will enable an organization to identify a change or a project that was recently deleted. Maybe we had an accident, somebody made a change and it caused a problem. We can find that change from in the change management logs here. We also have the ability to undo changes. So let's say we make a change and it breaks something, we can revert back and undo those changes we made with regards to the resource manager. And sometimes that can be a very good thing. So it's going to be important to organize your environments well. And if we organize it correctly, it'll be logical, it'll be simple to manage. Otherwise, when stuff starts getting sloppy, and it puts us in an environment where systems are doing things and we didn't organize them well and our architecture isn't logical, how do we change them later? And when it becomes too hard to have all this stuff and to change things later, they typically call it technical debt because you made an architectural choice that didn't work, or that worked tech-wise, but all of a sudden it's a little icky, and now in order to change it and fix it for scalability in the future, you're going to have to spend a lot of money to fix it. So we want to make sure we don't get into sloppy environments in our architecture. We want to plan things properly. The other reason we like the resource manager so much, and Google's pushing this resource manager and testing you so much on it on the professional cloud architect exam, is it's going to be really necessary from a governance and security perspective, from a scalable perspective, to make sure that the policies are applied. And it's going to make it a lot easier than trying to apply a policy every single time. Now, we can still apply a more specific policy to a resource, and that's great, but we can provide generic things that we need to do that are going to get us the way that we're secure enough. And then if we need to lock something down even more, then we can do it at the resource level itself. So it enhances security and governance, and it promotes rapid innovation, because if your organization is clear and it's logical and it's laid out and you know where your resources are and what's talking to what, now all of a sudden when you want to make a change, it's easy because you're already ready to go. If you don't know these things, you may have to analyze everything, figure it out, and fix bad architectures in order to be able to do things. Now, let's talk about legacy infrastructure. So, like in a data center, we can have the most advanced infrastructure in the world that's every bit as good as the cloud computing environment, basically using the same servers, same routers and switches they are, even if they're made by a different company. So, and then we even have more control. But some on-premise environments contain very outdated things. And sometimes they have outdated things because they're still a critical part of the business. And sometimes that makes it more challenging to manage. And sometimes it doesn't. So, with architecture, we have to weigh things as we move forward. And it's not the best technology or the most innovative. It's what's best for the business. But for the purposes of your exam, you should probably know that on-premise environments may have remnants of older things which are harder to use. So keep that in the back of your mind. So if we don't understand the infrastructure and that we change it, the risk of something is so great, which is why, a cloud architect like me, I might need a cloud architecture team, and it may take us 6 months to even figure out what's going on with the client. By the time we're done understanding the business processes and business architecture and all their technology infrastructures and the way the users need to work in the future in order for the architecture to be successful, that could be 6 months just to get that kind of information. So, the more organized things are, the more clearly understood things are, the easier it will be to make architectural changes. And we often want to make architectural changes for innovation purposes. So, keep that in the back of your mind. So let's talk about the benefits of a clean, clear, and organized cloud environment. It reduces risk. As we get rid of unnecessary things or insecure things or outdated things, the risk of new incidents or security incidents is significantly minimized. It also reduces risk because when we make changes, they're less likely to have a problem, because if we don't know what we have, we can't assess the impact of the change before we make that change, which means we could make a change and it can affect another part of the system if we don't understand the system correctly. Now, one of the things some companies like is they like to keep their top engineers excited by working on some of the latest technology. I don't ever recommend that. I recommend designing the architecture that's based upon what the business needs best. But for the purposes of your exam, the improved developer experience may make people want to work for you more, be more likely to want to work for you. And others would argue that if everything's well organized, your developers will do a better job. And that is absolutely true, because it reduces the risk, and when you know what you have. Having an environment clean and having an environment well planned and having the environment that's architected for agility and scalability enables rapid growth or rapid changes in the business perspective, and it promotes a culture of innovation. So that's a lot that we can get out of the resource manager. It helps us do these things that we want to do. It's a tool for us. And, as architects, our design is to help the business. Now, what tool we use to do it? Well, it's the one that does the job best. But the more information we have, the more organized things are, the easier it is to make that determination. So we get very good visibility with the resource manager, and the organizational hierarchy enables us to manage and view resources easily. So we like that. From a security and governance perspective, it's a lot easier to say we need to meet a certain specification by going to the top and applying a policy here and having the other folders and projects and resources inherit that policy than it would have to be for us to set up a policy every single time, one at a time. The adaptability. So if the architecture is simple and it's scalable and it's properly designed, it becomes very easy to add new services or create changes and add new things because the architecture is designed for it. If the architecture is designed for today and the people that planned it out didn't think about what's needed tomorrow and how it would grow tomorrow based upon the business's goals, then it's very hard to make changes. And sometimes in order to get there, you have to go where you're at. You'd have to do a new project, what's called a transition architecture, to get you to point B. And then you need a new architecture project to go to point P from point C, which you might want. But if it's designed properly, you might just be able to make the new changes. So, resource manager will help with that because it's what we're trying to do from an architecture perspective, and it gives us better information. The resource manager gives us good information so that it reduces risks. And that's always a good thing. It reduces risk of the security issue because we can see what we have more clearly. We can make sure we didn't forget certain things. And again, it reduces risk of deployments and new architectures because you know what you have. And you're not making changes to things that you don't understand. So I'm going to talk a little bit more about those resources and their components. And I want to do it to make sure you understand the billing and the such. So when we look at this hierarchy, we're looking at where the components are. At the lowest level, these are the resources the team is setting up. This is the object storage that you'd be thinking about. This is your virtual machines. This could be your containers. All the things you're actually using is the resource. And the key here is that each resource is parented by a project, which inherits the permissions that have been applied to the project. And it makes it a lot easier. Now, one of the things we're going to get here is we're going to get detailed billing here related to the actual projects, related to the actual business unit. So if we're dealing with a company that wants to charge each business unit back for its tech services, it becomes very easy to do. It also helps an organization from a planning perspective. They could say, this business unit is using this much tech, and this business unit is using this much tech, and they can see is the technology making a big difference in the business. Now, when we go to the project level, it's really a grouping mechanism for resources. And it's going to be mandatory for managing Google Cloud services. But the key here is going to be each project will have its own unique project ID, project number. It's going to have a mutable display name and a lifecycle state. So you're going to get some information about it as well. At least when you look at it, you'll get some meta information that will help you understand what it is. And of course, here we have a logical grouping of resources, and we can do it based upon functionality and access control. So it makes it very easy to talk about controlling access to resources and security. Now, a little more about the folder level. Now, these are used to group similar projects. So that's one way we can do it. And what does that typically mean? It means that we can apply a policy here that the projects will inherit. So that, again, makes it so much easier. It acts, realistically speaking, as a policy IAM point. Because, everything, we can create a policy that is inherited down. Now, at the organization level, this is the root top level element of this resource hierarchy. And I know I talked about it earlier, but now I wanted to give you a little more information about each section after first explaining it at a high level and then talking why we need these resource manager type things in an architecture perspective. So now let's talk about the organization. That's the root. That's the top level element. Here's where you're going to get your centralized visibility and control. And you're going to see it for all the resources in the organization. And this is going to be automatically provisioned when the first user with a Google Cloud identity, for example, might be set up, or Google Workspace. when this occurs. So this is going to be critical for resource management, lifecycle management, identity management, and it's really going to help with ensuring accountability. Now, the point here is to be able to create an organizational policy and to be able to set the constraints for a project or a folder or an organization and enforce it and ensure that consistent policy. And we can apply any type of constraints we want. For example, we can evaluate against a list of allowed values or non-allowed values. Maybe like if you can think of an example of like an IP whitelist or an IP blacklist. Whitelist where you allow certain things and blacklist where you disallow it. We can use Boolean constraints that can govern specific behaviors with like a true or false setting. For example, disabling the ability to create a service account. And a service account's that typically used, especially in the Google Cloud, for one system to talk to another system. It's a type of IAM account. And the key to remember here is that organization policies are not retroactive, meaning that they do not automatically apply to existing resources. So you're going to have to manually remediate something if you have existing resources that have violated a policy that you just set. So let's talk about some best practices for structuring, your Google Cloud environment. Plan the organization with future scalability and changes in mind. Assume that everything could change. So when you design an architecture, not only are we talking about this layout, but we're designing the network to make sure that it meets the needs of the future. Will the network have capacity? Do the routers have the capacity? Is it a simple add a link to move forward? Or are we going to need to change routers or change many different technologies along the way? Just for the network, we'd be thinking routers, routing protocols, and what do we need to do to tune it? And how is that going to grow? And then how would we connect to various environments? What would happen if we bought different businesses, for example? What happens? How would we manage different addresses if we dealt with one company versus another company? So we have to plan it every element of this. The network plan is based on that from the network architects. The security architects needs to focus on security now and how it would adapt to changes in the future. So everything we do in architecture is planning for the future. That's why architects aren't touching the technology. It's a pure planning role. So plan with the future needs in mind. Use a lot of projects to facilitate changes in access control. And that way you can apply it on a simple and scalable way and make sure your access control is going to be where it's at. Separate your resources. Align projects with specific applications or environments or business functions. Anytime you can create a separation of duties or a separation of access, you're increasing security. We can use automatic project creation, with an infrastructure as code script. You can automatically create your projects and ensure consistency and ease of management. And when possible, for the cloud engineers and the DevOps engineers that are deploying resources, it's much better to use a good infrastructure as code script to make sure that there's no manual errors. Now, here's the thing with automating anything. If the person who's doing the automation doesn't understand what they're automating, they can break things as fast, if not worse, than they're actually setting them up. So the people that are writing that infrastructure as code script need to be sure they need to understand the rationale, not just how to do something, because they need to be solid and they don't make mistakes. Now, when you're dealing with things, let's talk about we should be able to protect critical projects. And if we've got a critical project in a production environment, we need to make sure that it is protected from somebody, say, accidentally deleting it. And that's why we're talking about such security policies here. And obviously, for more information on the resource manager, go to the Google Cloud website, learn a lot more about the service.
Okay, well, welcome back. We are here. We can answer a few questions. After we answer questions, we've got 2 relatively short labs for today. We may finish a few minutes early. As the topic came up, I'm going to come tomorrow at 11 a.m. Eastern and do a career question and answer session. And on Thursday, I'm going to have a How to Become an Architect webinar. And I will spend 2 hours
getting real strict and exactly what we do as architects, exactly every skill you need, what hiring managers are looking for, how you bypass HR. So please join us. We run one every Thursday. That'll be on Thursday this week. We actually have one more video content to go to and then the labs for today. But Chris, it looked like a question or two popped up. So let me get to these questions before we get to the next one. What would a good focus for cloud architects be? As many companies seem to advertise their job description for an application. So I want to do two things. One is I want to talk about why all these job descriptions are completely inaccurate. And the other thing that I want to do is I want to really give you the real cloud architect job description. So this is something I'm going to be releasing very soon on LinkedIn, but I drew it, so I thought I would show it with you today. So here's the reality. Let's say I want to hire a hiring manager. So I'm the hiring manager and I say, I want to hire a cloud architect. Here's what occurs at 90% of all organizations. I call HR, I fill out a form that says, I'm going to hire a cloud architect. Now, HR says, great, Mike, we're going to go through 4 to 6 weeks of approvals. And in the meantime, HR, us, who knows nothing about the job, we're going to create a job description for your cloud architect role. So because I told HR I want to hire a cloud architect, HR says I have to write a job description for the cloud architect role. Only problem is HR knows what to pay you. HR knows what your benefits are, but HR doesn't know what a cardiothoracic surgeon does or a cloud architect. So what HR does is Googles a whole bunch of silly job descriptions that exist on the internet and says, none of these really say cloud architect, but if I add all 10 of them together, now we've got a new job description. So the new job description that you've seen now lists elements from 20 different people's careers, and none of the skills are related to being a cloud architect. And that's why we typically have this mismatch. Now, the separate problem occurs is by the time I actually find somebody that I can actually hire as an architect, because everybody's trained to be an engineer when I wanted an architect, 5-6 months later have passed, and I don't even need the person that I was hiring in the first place. So now I use the requisition for the architect to give him a completely different job. So that's why job descriptions are bad. So here's the good news. You don't have to believe me. What happened is Gartner went and asked the chief information officers, what do you want in a cloud architect? Now, this is a direct screenshot from the article I gave you, but listen to what the management said. I want a cloud architect that can lead the cultural change for cloud adoption. Now, that means creating a team, examining stakeholders, asking the stakeholders' needs, learning what the stakeholders need. That creating training materials, that's leading the cultural change for cloud adoption. Developing and coordinating a cloud architecture is understanding the business, understanding the client's landscape, the client's challenges, and that's going to take you to build a team of 15 to 50 people. That's developing and coordinating the cloud architecture. Now, then the last part is developing a cloud strategy and coordinate the adoption process. So do I make the single cloud, hybrid, multi-cloud, what have you? Well, that's the three things we do in our job. So I'm hoping you're starting to understand it's going to sound a lot like an executive, because it is. Now, the other stuff we do day by day is find talent with the necessary skills, assess application, software, and hardware, create a team. They call it a cloud broker team, establishes best practice for the cloud. So every new user will be using this form of IAM. Every demilitarized zone will look like this. Select cloud providers and vet third-party services. Which cloud providers do we use, and which other vendors do we use? You typically have about 50 vendors. Oversee governance and mitigate risk. Develop privacy incident response procedures, and manage costs. So the key is that's what we're doing. So that's going to take a combination of business skills like CXO relevancy, sales, executive presence, the ability to profile accounts. It's going to take networking knowledge, security knowledge, identity knowledge, compute knowledge, storage knowledge, security knowledge. And you know what we'll do? On Thursday, I'll give you an entire list of them. In the short term, Anthony, my team wrote an ebook on the skills you need to be a cloud architect, and we'll drop that in the chat box. So Anthony will drop an article on everything you need to know skill-wise. I'll come online tomorrow, Tuesday. Tomorrow and Wednesday, I'll do some HR stuff, some questions and answers for cloud careers. And on Thursday, I'll spend 2 hours. I'll go over the role. And I can do anything I can on this webinar. We'll go over the role. We'll answer questions. If you want me to look at your LinkedIn profile, I want to see if you're ready to be hired. I'll even give you a mini interview there and tell you if you're ready or not. So all that's free on the Architect webinar on Thursday. And I do this every week. Hope that helps.
because it's a great job and I want everybody to have it. And I hate to see so many people get held back from this role because they confuse it with an engineer. And it's a great, great, great role. To what extent does resource management vary by major cloud providers? It's all very, very similar. Actually, if you take the CCSK course that I taught, which is on this channel, I actually break it down how AWS does it, Azure does it, Google does it, and you'll see they're nearly identical. So all pretty much the same thing. So cloud provider is somebody that's renting you space in their data center. So for the most part, all clouds do the same thing because they've all been offering the same data center services because there's nothing else they can offer. Data centers have changed very little since the technology. Now the speeds have changed. We went from single core CPUs to 192 core CPUs. And we've gone from systems with 1 megabyte of VRAM to systems with 8 and 10 terabytes of DRAM. We've gone from a GPU that can calculate very little to some crazy GPUs that can calculate a whole lot. But all in all, it's going to be very similar. Now the commands, very different. The interface and the way it feels, going to be very different. But the actual underlying things, nearly identical. It's a really great question there, Darnell. And that's why I say if you learn the cloud, and I mean truly, truly learn the cloud, you'll know all clouds. But if you just learn a cloud, you won't know that cloud. So we've got a 30-minute video and then 2 short labs to finish the day. Now, tomorrow we're going to get into some geeky, techie stuff on the network. So these labs are going to be tomorrow a lot more fun. But these concepts are so critical. And as architects, we don't touch the tech. We talk about it. So I wanted to give you as much conceptual work as I could because I really want you to be successful. I think the architect career, the cloud architect, this is enterprise architect, solutions architect. These are some of the best jobs in the world. And I've loved them for my 25 years. And I want you to experience the same. Give me a hashtag so that I know you're here. If you're having a good time, maybe give it a like. Subscribe, invite a friend, really share these free materials with others because we really want to help. And Chris, let's get back into the content. Give me a hashtag, Google Professional Cloud Architect, so I know you're here.
This section, we're going to talk about cloud identity and access management, and that's going to be another big component of the Google Professional Cloud Architect exam. If you'll recall, we talked about cloud identity earlier. And cloud identity is predominantly the authentication piece and determining who the user is. Now, I know when we talked about that, I actually gave you a lot more about IAM because I wanted you to understand identity and access management. So because I did that, this section is going to be a lot easier. But we're going to go over the cloud IAM, specifically the Google version and how it can work with regards to authorization. So IAM is absolutely critical. In general, the human element of our business is often the weakest link. A whole lot of cyber attacks result from somebody that has too many privileges and sometimes accidentally makes a mistake, or we have the wrong person using the system. And a lot of that can often be fixed with better authentication, but also much better configuration management. Now, with regards to IAM or any kind of security, we have to always use the principle of least privileges. The principle of least privilege is give people access to only what they need to do their job, the resources. You may also hear the term need to know. That's slightly different, but almost the same things. And that means don't give information to people that don't need it, nor need to know it. Now, they're very similar concepts. And when we're dealing with security, in many cases, we're going to be talking about the principle of least privilege, or again, that separation of duties, which we talked about before, which is don't have one person responsible for everything separated amongst multiple people. Because if you have one person that's responsible for everything and then they do something funny, like embezzlement, there's no one to even catch it or notice it. And risk management is going to be critical for all businesses. And risk management, which is way above the scope of the Google Professional Cloud Architect exam, is about identifying the organization's assets and what they're worth and the risk of being compromised, for example. Then determining what you would do. Do you mitigate the risk, transfer the risk, accept the risk, that kind of thing. That's more risk management. And access management is one significant component of risk management because how do you reduce the risk? You implement controls. And one of the controls that we're typically talking about here is IAM. Other types of controls could be things like firewalls. Other controls could be physical security. There's a lot. Other controls could be input validation or a lot of different things. So security is all about implementing controls to meet the needs of the security policy. And as security architects, we create that security policy and, of course, the security architecture. But understand that human element can be a real risk there. Now, we're going to talk about Google's IAM platform, and it's called Cloud IAM. And it provides good enterprise-grade access controls to authorize actions on cloud resources inside of Google. It enables full visibility and fine-grained control. It enables you to centrally manage all of your access control across your Google Cloud resources. You may have to think, what would you do in a multi-cloud solution? But generally speaking, with Google Cloud IAM, it really provides excellent management of the Google Cloud resources. Now let's talk about IAM policy management. We can manage IAM policies, and we can do it via the Cloud Console, the thing you click with that looks so pretty, the API, or the command line. And we have to think about strong access management. We have to make sure that only the people that need these high privilege roles actually have them. And we want to make sure that people don't have more privileges than they need. So we're going to align this heavily with our authentication, authorization, accounting, security model. So let's talk about some IAM considerations. So user experience with IAM should be designed to allow users to perform their jobs without too many obstacles, because here's the reason. You make the passwords too complicated and people put sticky notes of the passwords. They write a little folder on a computer that lists all their passwords. We don't want people to be doing that. I mean, there are password managers that can be used, but what happens when the password manager gets hacked? Like a recent example just happened. So we have to think about all of these options. So security teams, realistically speaking, need to be engaged in the IAM architecture. Now, in a big environment, in a big global environment, we'll actually have IAM architects and security architects collaborating on these together. In smaller organizations, the security architect may do it all, the IAM and the security. The policies that are going to be created with IAM need to align with the enterprise security policies and help monitor it. So when we security architects design that security architecture, part of that architecture is how people are going to monitor and manage these systems. And the IAM systems can help here because there's auditing after the fact. And when we deal with an enterprise, new cloud organizations may need to revisit and think about their security policies, especially as they evolve to the cloud, because there are more challenges in the cloud for security, and there's a lot of challenges and data sovereignty and laws, and there's so many more challenges in the cloud. And I'm not saying the cloud's not bad, but you really need to think about this. Now, again, that's way above a Google Professional Cloud Architect. Those types of challenges, obviously, we teach in our Security Architect program. That also covered fairly well in the CCSP exam. And there is a CCSP exam or certification training bootcamp, an entire bootcamp on this channel. So I suggest checking that out to learn more about it. That is absolutely some pretty important content for anybody working with the cloud. So we're going to talk about the specifics right now, and we're going to be talking about IAM members, roles, and policies. So let's talk about what these things really, really are. Let's talk about members. What's a member? A member is a human user. So I like to think of a member, at least when I view it, as a person. And that's the way I always view it. Now, a service account, if you're a Linux user, you may be familiar with service accounts, but a service account is when one system needs to access another system. And that's going to be what's called a service account. I'll give you an example. So we might have an application server. And the application server might need to talk to a database. And what you typically do is you create a service account that enables these two to speak together. Now we have the concept of a Google group, and I'm going to show you what a Google group is. And a Google group is just going to be a group of accounts. So what we're going to have is several accounts under that. Oops, bear with me. Didn't cut it. And that's realistically what we're speaking with regards to a Google group. And the Google Workspace or the Cloud Identity domain represents the full domain that can access these resources. So anything that can access the resources is the full Google domain. Now, every member is going to need some way to identify them. You know, in life, well, we have our name, Michael Gibbs, right? But somewhere along the line, the cloud provider is going to need some way to identify, who the members are. And that's typically identified by email addresses for accounts and groups or domain name for a domain. Now, when we talk to about members, and remember, members are people, we're going to create a role, which is going to be a collection of permissions that define what operations that member can do. And that role is going to grant a member, the permissions. So I know I walked through what role-based access control, but I want to make sure this makes sense to you. Now, this is the way role-based access control typically works in most organizations. So let's say, for example, we have to hire a new person. And in this particular case, Cindy applied for the job. And for any of you that have ever had a cat before, you know that the cat dictates your life, tells you what to do, where to do it. So, of course, when Cindy applied for a job, Cindy was hired by HR as a manager. So the HR systems typically integrate with the IAM systems. And as soon as Cindy's hired and they create a job for Cindy Gibbs, it usually creates an account that lists manager because Cindy was hired as a manager. So now what we do is we create a manager role. And then we give the manager access to the systems they would need to do their job. So in this particular case, let's say we have Cindy and we hire her as a manager. Cindy's got some goals as a manager. Now, Cindy loves tuna. So as a manager, Cindy wants to be able to give bonuses to their employees if they bring in fresh tuna for her each day, because she's going to be really happy about that. So Cindy needs access to the bonus system. Now, Cindy also knows that if she's going to send her workers to go get sashimi grade tuna each day, what she's going to have is they're going to have to be able to put a credit card in, pay for it, and then Cindy's going to have to reimburse them. So she's going to need access to the expenses system. And Cindy also knows that she wants to be able to give bad ratings to the people that don't get her sushi or shrimp or tuna because she wants to be well fed. So therefore, Cindy will need access to these systems. Now, let's talk about the sales engineers. When they are hired, they are given a set of permissions. But for example, maybe they need access to the sales materials, documentation, templates for presentations, for sales presentations, maybe documentation that could be used with RFIs, RFPs. So, of course, we need the sales engineers to get access to those sales libraries. And maybe the sales engineer needs lab access to mock something up and test it. So you'd see the sales engineers would get that, but we might have sales reps that only need access to forecasting machines and CRM machines and a few others. And that's what we're dealing with role-based access control. And now remember, roles are for people. So we grant the role, we grant permissions to the role, and then the next thing we do is we add users to the role. And that's role-based access control. So that's what we're really talking about and how we would do things. So we can create something now called the IAM policies. And these are going to be configurations that are going to bind members and roles together to enforce access control. Now, the point here, or the purpose, is to ensure that only approved access patterns are going to be allowed. And we're going to define who can access and what they can do. So I hope this makes sense, the way these IAM policies could be applied. Now we can also apply IAM policies to resources like projects, folders, and organizations, which we just talked about in the last section. So we are able to apply these IAM policies of who can do what, for example, and we can do it at a big level to make it easier in a scalable way. So it's going back to groups, and groups are logical containers or groupings of one or more accounts. Going back to this diagram to show again, because now there's a couple of these terms and they kind of they're kind of funny, at least from my perspective, as they're marketing terms, except for like the service account, which is widely used in the industry. So, every company can use their own terms for these types of things. So the groups, remember, are logical groupings of one or more user accounts. And it's to provide simple access management by defining roles for the group instead of individual accounts. So I hope that made sense. That's what we're doing, role-based access control. And groups are going to be created and managed in Cloud Identity. Now, we talked about service accounts being before, and service accounts are for one system to access another system. So going back, we might need a service account to run a batch job, process a transaction, integrate to an external system. For example, we could be running code executed in a Google environment, but it could be under a specific service account. So the key here from a management perspective is to apply principles like separation of duty and principles of least privileges, and to ensure oversight and the management. So whether it's a person that we're dealing with, whether it's a group, or whether it's a service account, we don't want to apply more access than is necessary. So let's talk about the service account's owner. And this means programmatic accounts in Google Cloud that are going to be used to be automated without human intervention, still maintaining traceability. So the point is, with a service account, we still know that they're talking to each other. And this is for applications to talk to applications. Now, when it comes to role assignment, service accounts can be granted roles and privileges to perform certain actions or resources, just like any other account. When we think about it, these are ideal for automating repetitive tasks, such as processing transactions or uploading data to maybe an object storage bucket or an environment. Because we can automate it, we can make it good, and then we can apply a security policy. And that's realistically what we're talking about. And service accounts can be used to run workloads in your on-premise environment and have them then integrate with the Google Cloud API. So service account, if you're from a Linux background, that hopefully makes a lot of perspective too. If not, I hope it still makes sense. So think about key management. So anytime we're dealing with encryption, we're going to have keys. Anytime we're dealing with any kind of security, we're going to be dealing with keys. And how do we keep our keys? Well, we could let the cloud provider manage our keys for us. And when we let the cloud provider do all of our key management, in this case, the management would be done by Google. They would typically rotate your keys weekly. And they're typically in an environment where they're non-downloadable. So the cloud provider is doing all your keys and they're maintaining the security for you. Now, that's fine. Now, we may have some users that have extreme security needs where they need to manage things on their own. And this is, of course, possible in all cloud computing environments. And this is the user-managed key, and this is where a user is going to create and manage the keys. Now, because key management is not that easy, it's going to require careful planning. And when are the keys rotated, and where are they stored, and where are they distributed, and when do you revoke them? So, you can manage it yourself, and many high-security organizations do, but they need people that really understand this. The GCP managed keys is kind of the easy button because they do everything for you. So we have to think about key protection. Now, if we've got to protect any kind of keys we have for authentication, imagine we have the most high-security environment, and the keys are just on a table. So we just take them. So imagine that. So we might, if we have a hardware key, we may have to put that hardware key in a safe in a secure building. So we have to think about how we protect those keys, or do we use key escrows or things like that. So let's talk about the kinds of keys that you can use for managing service accounts. The Google ones and yours. In many cases, these cloud things are the same choices you would typically have, but they have a version that you can use. we have to make sure that no matter what we're doing, we rotate keys. Have to. And there's lots of third parties that can be an escrow or a vault for your keys. So generally speaking, we want to use short-term temporary credentials, like an OAuth 2.0 token or an OpenID Connect token. And we want short-term elevated privileges. And here's the thing. If I change my password every 90 days, and I usually use things much more secure than password, let's say I change it every 90 days. Let's say the first day I change it, immediately someone gets access to my password. Now they could use that password for 89 more days potentially. That's a pretty big problem. But if we use a short-term credential or a temporary credential that might expire in a day, the worst case it could be is the hacker had access to my information for a day. And if we change them once a minute, they would only have access to the ability to do damage for once a minute. Now, obviously, the more times we do this, the more overhead. So, and the greater the challenges would be with scalability. And the less frequently we do it, the easier it will be. But of course, the less frequently we'll do it, the change keys, the more damage that can be done. So that's going to be an architecture trade-off that you'd make in the Google Cloud, the AWS Cloud, and even your data center. These are the kind of things we architects plan on. Just remember, security service accounts are really important because how else would you connect one system to another system? But we have to manage these service accounts very, very well. So let's talk about the difference between default and custom service accounts. The default service account is automatically created. It's generated automatically for Compute Engine instances when a project is created. There's default permissions, which are typically assigned to a privileged editor role, which is far too permissive for what you want it to be. But most systems come up far too permissive, say they're easy to access and easy to set up, and then you have to lock them down. For example, you'd have to if you had a web server, you couldn't just use the standard operating system. You have to lock it down, remove unnecessary packages, close various ports on it, and put some endpoint kind of protection on it. So you'd have to harden things that you typically do, because everything comes up too open for security purposes, but for convenience purposes. So typically speaking, the editor role, the privileged editor role, is going to be far too much privileges for most people. So it's not going to be recommended because of the broad permissions, and using this can kind of lead to excessive privileges. So you might want to change it. Now, we have to think about the dependencies. Instances rely on these service accounts to access other Google Cloud resources. So we have to be very careful when we modify or delete something, because if we don't know what dependencies exist and we just delete something, we would break it. So that's why we architects plan it out carefully, and we typically create great documentation. So when a cloud engineer or an operations engineer is managing it, they know where to go and they know what they ultimately have. Now let's talk about a custom service account. Now this you will be using, and this is where you're going to be manually creating it for specific applications or purposes. Now here you're going to get very granular with regards to your permissions. You're going to have very precise control over access, and this is going to enable others to adhere to the principle of least privilege, separation of duties, and everything else that you want. And this is going to be fairly versatile because you can use it for a wide variety of applications, including those running on premises or in the cloud. Now the best practice here is going to be to delete the default account and create your own with the permissions that you typically need. Now, I talked about role-based access control. We talked a lot about roles. So let's talk about the types of roles that you can use in the Google Cloud. So one of the role types we have is what's called a primitive role. And these are your legacy roles. These are super basic predefined roles with broad permissions like owner, editor, and viewer, that you typically think about with regards to sharing like a file or a folder on a hard drive. Pretty high level type permissions. Now we also have some predefined roles. And one is like a service specific type of a role. And that's going to be a predefined roles that are created by Google, and they provide fine-grained permissions, and they're designed for certain reasons. So, the way AWS has, to certain specific types of IAM policies that are pre-made for certain things, this is realistically speaking the same thing. For example, you might have a role like a compute instance admin, And that will have specific permissions related to managing the virtual machines or compute engine instances on the Google Cloud. And this is often recommended for common use. It's best for standard roles that are commonly used across various projects. Now, let's talk about custom roles, and this is going to be really critical. Custom roles are going to be created by the client or by the user to meet specific business needs. Now, here we can tailor the permissions. We can create roles with a very unique set of permissions that may not be covered in a predefined role. We can get as granular as we need. So most organizations have custom roles that they're using. Okay, so let's talk about some really neat features, some key features that we can actually deal with when we create IAM members, roles, and policies. We can use something called attribute-based access control. So normally with role-based access control, it's that user. You saw how Cindy was a manager and she needed access to the bonus and the expense systems, for example. In this case, we can look deeper. So Google gives us the ability to do what's called attribute-based access control, and we can look at more details, such as the time of day. Because maybe the user should be accessing a resource during the day and never at night. And if that's the case, disallow it at night. We can look at things like the IP address ranges. For example, we can restrict access to a certain subnet or a certain prefix range, and by doing so, only allow a certain set of users to access the system. We can define how long, for example, a user can stay in a system. And we can put these conditions in something called IAM role bindings, which is how the roles are actually completely bound to actual system. So if we think about this, the way with IAMs, how is it going to be implemented? It's typically implemented in something called the custom expression language. And that's going to be used to define the expressions that are going to specify various conditions within an IAM policy. Examples of conditions could be time-based access, like a user can access from, say, 9 to 5 or 10 to 6. They could be location-based access, like only allow users from the U.S. or only allow Florida users. Or we've got a business in Palm Beach County, Florida, only allow IP addresses inside of Palm Beach County if we wanted, or temporary access for a short period of time. Now, from an accounting perspective, and that's the last part of that authentication, which we talked about a lot with cloud identity. We talked a lot about cloud IAM and its authorization. So now let's talk about accounting. And that's to be able to see what happened and then audit it later. Because auditing is going to be critical for ensuring that the identity and access models are secure and they're actually working. So where are we going to get this kind of information, be able to look at things? Well, we're going to have several kinds of audit logs. We're going to have the admin activity audit log. And the admin activity audit log is going to track API calls and administrative actions that are going to modify configurations or metadata. And of course, metadata is data about data. It's descriptive data that helps you understand something better. And these logs are going to be generated when an IAM policy is modified. So we definitely can look at the admin activity audit logs. Let's talk about the data access audit log. So we can record all these API calls that are going to be there that are going to be looking for data, for example. So we can you record these calls that read configurations or metadata or even a user-driven API call on resource data. So the key here is to find out what else is going on in the data audit log. So this is going to be typically disabled by default. Because it's typically can become a pretty big environment. It can get costly. So if it's an environment where security matters, you definitely want to enable your data access audit logs. And of course, we'll get our system event audit logs as well that'll capture administrative actions that'll modify resource conditions granted by systems rather than user actions. So because we have all these systems that are going to be talking to other systems, we need these kind of logs. Now, we have to also talk about configuration monitoring and management of that. So imagine an environment where anyone could set up any configuration they wanted. We could have one user that can set up a web server and they've locked it down, they've tightened it down, and it's perfect. And we've got another user that doesn't even know what server hardening actually is. Where one user wants to use this version of an operating system and this application, and the other user feels like this and setting their permissions anywhere they want. Well, that's a great way to get hacked. So we have to see what's going on with the configurations. We want to come up with stock configurations. We want to simplify. We want to make sure the configurations we have are good and strong and secure. And we want to monitor that and make sure that the configurations stay this way. So we're typically going to be having to monitor these things. Misconfigurations, by the way, by customers are the most common cause or the leading cause of cloud security breaches. So a lot of cloud security breaches, and so many of them come from accidentally just not knowing what someone's doing. Misconfiguration. And it's usually not the person that knows and understands the underlying concepts and technology. It's usually the person that just does a lot of hands-on stuff but doesn't know the what or the why or behind the how that they're actually doing. Now, there's going to be really good third-party solutions for this kind of environment, monitoring and compliance. Prisma Cloud by Palo Alto Networks, for example, offers tools for identifying or correcting cloud misconfigurations. There's the Forseti Security, which is an open source option which provides scanners to detect misconfigurations in cloud environments. It's got customizable scanner rules, and you can available on public GitHub repositories. And there's just scanning functions that we can use. For example, ensuring that there's no all user IAM policies, for example. So the ability to enforce account key rotation, restricting access. You've got to be able to make sure that these things are going on.
Okay, well, Leo and I are back. I think there might be a question to answer. And then Leo's got some entry-level labs that we're going to have some fun with today. Tomorrow's Leo's labs get a little geeky, and they're going to be really fun. So I'm looking forward to them, too. I don't get to touch technology as an architect, but, it's kind of fun to see it demoed here and there every once in a while, too. And so that's always great. Before I answer any questions, did you want to say anything, Leo?
Well, just for them to be prepared for the demonstrations.
Okay. So let me answer the one question that I think came up, and it came from Orlando Chemdry. Are a lot of companies able to pay high salaries for architects? So what I want you to think of is, there are some positions that generate money, and there are some positions that cost money. What if I told you that the average, and I'm not joking, the average of the top 10 stocks in the Dow 30, the average revenue is $287 billion a year. There's a reason I'm starting with them. So if you are able to make a 1% change in an organization's revenue, that's $3 billion, 1% change. So if you're able to create an AI recommendation engine that makes somebody dwell on a page that leaves them on there 1% longer and revenue goes up by 1%, you made a company $3 billion. If you ask for $800,000, it's nothing. And the reason it's nothing is because of the value you're actually generating. So it all depends on what problems you're able to solve. You go in there with MBA-like knowledge and you solve billions of dollars or millions of dollars issues, then guess what? You're worth $500,000, $1 million a year or more. If all you know how to do is just configure technology, well, that's another story, because that's something where there are a lot of people can compete. So realistically speaking, that's why architecture is really an executive position. It's about learning the business, learning the pain points, learning the strategy, and then also being able to map that to a technology, a network technology, a data center, a compute, a storage, what have you. So I'll go through a lot of it, but that's why you see the average architect is about 200,000 for a role. And when you get to principal architect level, it's about 350 to 500, about 350, 375 on average. And that's why when you get into chief architect roles, it's not uncommon to earn 800,000 or more, because these are big business roles. So they're executive roles with tech, which means I need somebody that understands tech, not how to configure it, but how it works and how to put it together, which there's nobody out there, because everybody learns by doing versus learn by concept. So there's nobody out there. And now that person still needs to have big business skills, which puts you at the perfect end of the supply and demand curve. Every company wants one, and there's nobody out there that can do the job. That's why it's so easy to get hired as an architect when you're properly trained, and so hard if you're not. Hope that helps. Great question. And then I'll answer Aaron's question as well. And I'm going to do a lot more of it tomorrow. Aaron's question is, he has a little bit of experience working with APIs and SA360. Is becoming an architect achievable? So Aaron, It has nothing what you used to do. I used to practice internal medicine. I was a principal architect within 2 years. Vladimir, for example, was a 20-year-old college student, a student of mine, first architect job, North Highland. Pierre was, I think he was 25. He was operating sailboats. First tech job, solutions architect at Leafs Web and Kana. Yvonne, 24-year-old waiter, first tech job as an architect, a solutions architect at AWS. Wallace Agana, for example, was a sales rep hired as a enterprise architect, straight as his first tech job at JP Morgan Chase. Whereas Al was a student of mine who was a sales rep whose first job was a senior solutions architect at Deloitte. Aaron, as long as you have the skills and as long as you get the training, you can get any job you want. Any job. But I can promise you what you learned as an engineer is not going to cover you to be an architect. And what I mean by that is you might need to know an API. But as an architect, I might need you to know if your weighted average cost of capital is 7%, how would you leverage that information to design a private cloud versus build a public cloud? As an architect, I might ask you, what's your IAM strategy for the organization? What are the architectural trade-offs you would face? I might ask you about the architectural trade-offs to go across going on a single cloud versus 3 clouds, for example. And that's the kind of answer I'm looking at. So the answer is yes, absolutely. You can definitely get there. I've taken nurses. Camille is a nurse. She's now a director of architecture. I've taken teachers like Nicole, whose first job is an architect. It doesn't matter your background. I've taken emergency medical technicians like Delroy Batten and got him his first job as a security solutions architect. Yes, you can. It's just about getting the right skills. I'll talk about exactly what those skills are on the webinar tomorrow. And I'm going to come in and do a career question and answer session tomorrow because the questions came in and I want to help you. But yes, you can go do it, but you will need training. But that's the great news. You want to be an airplane pilot? You can do it. You want to go be a physician? I promise you can go to medical school and you could be a physician. You can do anything you want. I love that because I practiced internal medicine for a little while and realized I love tech a little better. So I switched. 9 months later, I was a CCIA and I was working in networking. All right. So what we're going to do is we're going to play some of Leo's labs. Today's are going to be pretty basic. Tomorrow's are going to be fun. He got kind of geeky and I watched them and I was like, I really, really, really like this. So we're going to have some fun tomorrow. So let's play Leo's labs. Give me a hashtag Google Professional Cloud Architect. If you're having a good time, maybe give it a like. Maybe share this with someone else so you can share the wealth of the knowledge. That takes a lot to put one of these on, and we want to do whatever we can to help you build the best cloud architecture careers, enterprise architecture careers, solution architect careers. So let's have fun. I guess back to the Google Professional Cloud Architect exam content, Chris.
Hello. In this lab, I will demonstrate how to create a service account. But what are service accounts? When you need to authorize one service to do something in Google Cloud, you need a service account. A service account is just like a user account, but instead of allowing a user to execute tasks, it allows services to execute tasks. For example, a virtual machine may run as a service account. The account can be given permissions to access the resources the virtual machine needs. This way, the service account is the identity of the virtual machine, and the service account's permissions controls which resources the virtual machine can access. Here, I will use the search bar and enter Google Service Account. The first link is Service Account Overview from an IAM documentation. I will click this link to open the document. Here is the Service Account Overview document. We strongly recommend you read the documentation to learn about the services you are going to use. Here, the document shows different types of service accounts, service account permissions, service account lifecycle, several different aspects of the service accounts. Here, under the What Next session, there is a link to a document, find out how to create service accounts. But before opening this document, I will use the second link here is to get best practices for working with service accounts. I will right-click this link to open the document in a new tab, and I will switch to that tab. Here are the best practices for using service accounts, and the document states, although service accounts are a useful tool, there are several ways in which a service account can be abused. And the document goes over privilege escalation, spoofing, non-repudiation, information disclosure. And to help secure service accounts, consider their dual nature. Because a service account is a principal, you must limit its privileges to reduce the potential harm that can be done by a compromised service account. On the other hand, the service account is also a resource. You must protect the resources from being compromised. This guide presents best practices for managing, using, and securing service accounts. Please read this document to learn how you can use and protect your service accounts. And it is important to mention that in these labs, I am not covering all aspects of the services I am describing or demonstrating. I am just demonstrating how you can start learning, start using the service, but you need to learn more about the service to cover all aspects. For instance, how the service is charged or the security aspects of the service, among other things. I will close this tab now and go back to the service accounts overview page. And now I will click the link to find out how to create service accounts. The second paragraph states, by default, each project can have up to 100 service accounts that control access to your resources. You can request a quota increase if necessary. I will scroll down to the Create a Service Account section, and here are the steps. But before executing these steps to create the service account, I will scroll down to the What's Next session, and I will right-click the link to understand how to attach service accounts to resources. I will switch to that document. And as usual, please read the document, learn the aspects of the services you are using. Or even before you use the services, you should learn all aspects involved. Here from the What's Next session, there is a link to find out how to attach a service account to a compute engine instance. I will click this link to open this document. I will reserve this document for later use, and right now I will go back to the Create Services Account document and scroll back up to the steps needed to create the service account. I need to use the Google console and go to the Create Service Account page. So switching to the Google console, I will use the top left menu, and from the IAM and admin section, I can access the Service Accounts page. Here, I can click Create Service Account, give a name to the service account. I will call this HTTP Access Service Account. And I'll click Create and Continue. And I will click Done. So here is the HTTP Access Service Account. And this is how you can create a service account. In another lab, I will demonstrate how you can attach service accounts to virtual machines and how you can use service accounts to make your systems more secure. Thank you for watching. See you in the next lab.
Okay, Leo, that was great. Can you tell everybody what's in the next lab?
Yes, in the next lab, I will use that service account to demonstrate how it can be used. One aspect of using a service account is to limit the range of virtual machine or services that one task can be executed on. In this case, I created an HTTP service account to allow HTTP access to a certain number of virtual machines.
Fantastic. I look forward to this. Chris, let's roll with the next lab.
Hello. In this lab, I will demonstrate how to attach a service account to a virtual machine. To do this lab, I need one existing virtual machine and an existing service account. If needed, refer to previous lab to learn how to create them. In the previous lab, I demonstrated how to create a service account, and I opened this document and I reserved it. And now I will use the content of this document. I will scroll up and here is the What is a service account section. The document brings some points for you to keep in mind when using service accounts. You can attach the same service account to multiple virtual machines, but a single virtual machine can only have one service account attached to it. If you attach the same service account to multiple virtual machines, any subsequent changes you make to the service account affects all virtual machines that use that service account. And here, under how Compute Engine uses service accounts, there are two types of service accounts: the user-managed service account and the service agent. A user-managed service account can be attached to a Compute Engine instance to provide credentials to applications running on the instance. These credentials are used by the application for authentication to Google Cloud APIs and authorization to access Google Cloud resources. The service agents are used by the instance to access internal processes on your behalf. In addition, you can create firewall rules that allow or deny traffic to and from instances based on the service account that you associate with each instance. I will scroll down a little bit more to this section attaching a service account to an instance. And it says you can attach a service account to a Compute Engine instance when you create the instance or later. Only one service account can be attached to an instance at a time. If you attach a service account to an instance that already has a service account attached, the previous service account is no longer used by that instance. I will switch to the Google console now, and I will access the virtual machines instance page. And I will check the service account associated with each of the virtual machines I have right now. I will open the VM1, and the service account associated with the VM1 has the ID with some numbers -compute@developer.gserviceaccount.com. Let's check the service account attached to the VM number 2. And it is the same service account. and checking the VM3. It is the same service account. So this is the default service account created when the virtual machines are created in each project. The number will be probably different from project to project, but the remaining part, the compute at developer.gserviceaccount.com, will probably be common for all default service accounts created when the virtual machines are created. Going back to the service account document, I will click the link to change the attached service account. I will scroll down and remind you to read the documentation, learn about the services you are going to use. And here under the attach the service account and update the access scope, the first statement says, to change a virtual machine service account and access scope, the virtual machine must be temporarily stopped. So I will go back to the console and stop the virtual machine number 3 because I want to update or to change the service account attached to this virtual machine. Going back to the document, it shows the steps needed to change the service account associated with the virtual machine. Let's go back to the console and hit refresh to check if the virtual machine is already stopped. And then with the virtual machine stopped, I'll click the name of the virtual machine to open its details page, and then I will click edit. Now I can scroll down to find the service account. And then I can change from the compute engine service account to the service account I created. Let me go back to that page to see the name of the service account I am going to use, and it starts with HTTP access service account. So I will select from here HTTP access service account, and I click save to save the changes. Now I will verify that the service account was applied, and it's applied. I can click start resume to restart the virtual machine with this new service account attached to it. I will go back here to the virtual machine instances page. In this lab, I demonstrated how to attach a service account to an existing virtual machine. Another option to use service accounts with virtual machines is to select the service account when creating the virtual machine. This way, instead of the virtual machine being created with the default service account, you can select the service account in the creation process, so the virtual machine is already created with the correct service account. In the next lab, I will demonstrate how to create firewall rules to restrict HTTP traffic to specific virtual machines. Thank you for watching, and see you in the next lab.
Thank you for that, Leo, and thank you, everyone. Leo, could you talk briefly about some of the fun upcoming labs you have in the next couple of days?
Sure, Mike. The next content topics are about networking. And when we create, in this case, I already had 3 virtual machines created. And using the cloud providers console is very easy to create virtual machines, to create managed services. It doesn't require much work, but we need to understand the underlying technologies that allow to create those virtual machines, those databases, for instance, managed databases. And the next labs will show how to create this infrastructure, how to create a custom VPC, how to create custom subnets with specified IP address ranges, and then how to create the virtual machines, the instances inside those VPCs, and also using how to use load balancers inside those VPCs to direct traffic to different virtual machines.
Sounds fun. So I'll describe the technology, how the technology works, where it fits together, and then Leo's going to build it. We'll have some fun with that. And I love the way Leo demos technology. One day he demoed how to build a cloud to our students, and I saw that, and it was just so nice that I was like, Leo, we got to get you to do this. So, Leo, thank you for that. For everyone that's here, we hope you've enjoyed the Google Professional Cloud Architect Bootcamp we're doing to prepare you for the Google Professional Cloud Architect certification. This is day 2. You can still go back to see day 1. We've got 2 more weeks of this stuff. And I don't know, gives me a chance to get my geeky on since I don't get to do that very often as a CEO, and I enjoy it. So I hope you're all having fun. If you've not given the video a like and you did learn something, maybe give it a like, maybe subscribe to our channel and hit the bell to be notified of new videos. Maybe share this with a friend. If you've got a friend that wants to learn something about Google, please share this because we really want to help as many people as we can with this free Google Bootcamp. So please share that. As a reminder, I'm going to come on at 11 a.m. tomorrow. I'll be live and free. You can ask me any career question you want about any tech career. Want to know the impact of anything? We can talk about it. It's totally free. I'll be doing it at 11, and we'll be back tomorrow at 2 p.m. to go through this again. And on Thursday, I'm going to host a How to Become an Architect webinar. It'll be on Zoom. We'll go over the role. We'll talk about what we do. We'll talk about the skills that we have, and we'll make sure that you understand and you can ask any questions you want. Thank you for saying that we were clear. That was our goal, to kind of clarify some of the complexities and some of the mystery around computing and all the mysticism. So I hope we've done that. So been really great to see you. Hope to see you tomorrow twice, once in the question and answer session for the careers, once on the webinar, and then hope to see you on Thursday. So look forward to seeing you soon. So nice to spend the afternoon. Welcome, everyone. We are back for day 3 of our completely free Google Professional Cloud Architect Bootcamp to prepare you for the Google Professional Cloud Architect certification and exam. I'm joined here by Leo Paredes. He's a member of our team, a very senior member of our team, and he and I will be your instructors throughout this program. In today's program, we will have about 2 hours of technical concepts and about a good strong 1-hour lab from Leo. And for the next few days, we're going to have some good, strong labs from Leo, which he can talk about in a little bit. But today, we're going to get involved in, obviously, our architectural components, but also a little bit of the tech and have a little bit of fun. If you've just joined us, and this is day 3 for some reason, and you just didn't know about it, day 1 or day 2, you can go back and see day 1 and day 2 on our YouTube channel. I'll have our team behind the scenes drop the links to those 2 things for you. I also want to let you know that we've got a completely free study guide, this 550-page study guide that the team made from my notes that I was going to use to teach this program. And again, you can sign up for it. It is completely free. It is in the chat box as well as the description of this video. And I want to let everybody know that tomorrow at 11 a.m., we're going to have our How to Become an Architect webinar. We have one every single week, but we're going to run this at 11 a.m., which is going to be earlier than normal. And we're going to do that because we've got this free boot camp in the afternoon. So I hope to see so many of you in the How to Become an Architect webinar. We'll talk about what we do as architects, what we really do versus what people think they do, because people think we do something different. They learn the wrong skills, and unfortunately, they don't have the skills, and I want you to get hired. We'll talk about what hiring managers want. We'll talk about how to get past HR when you don't have a perfect resume and still be able to get hired, and I will answer any questions you have. So come and join us. You want questions about, you want me to assess you, see if you're ready, you want me to check your LinkedIn profile, anything we can do on these free webinars, we will do for you. So, Leo, before we begin, you want to talk about what you're going to be demonstrating today around 4 o'clock or somewhere near that time when the time comes or so?
Sure, Mike. Today we will have some labs about VPCs, the virtual private cloud, the underlying infrastructure needed to create virtual machines and other services in the cloud.
Oh, networking things, my favorite and what I think is most fun, but I'm a network architect. So sounds great, Leo, when we look for that. Everybody, let me know that you are here. If you've just joined us, maybe invite a friend. Maybe let me know you're here with a hashtag Google Professional Cloud Architect in the chat box. Tell me where you're from. I'm over here in Port St. Lucie, and it is looking like it's going to be pretty bad storm-wise. So at some point, I have to find a way to get my cat in because she's outside running around chasing things. Leo, where are you today?
I'm in São Paulo, Brazil, Mike.
Well, sounds really nice right now. So Leo's in Sao Paulo, Brazil. Chris is over there in that Tampa, St. Petersburg area. But where are you? Let us know in the chat box as well. Awfully shy. No need to be shy. Architects, we talk to people all the time. It's like go meet people, build a relationship, ask them about their problems. So don't need to be shy. Adrian, you're in Phoenix. Actually, that's a nice place. I've been in there in the summer. Nice and hot and dry. I had almost no allergies there. It was kind of great. Adam in Los Angeles. I've spent some time there. I just got back from there, actually. I mean, technically, I was in Beverly Hills, but I was staying for most of what I had to do, and then I stayed in Santa Monica, which I've always loved. Daryl is in Chicago. Tish is in Atlanta. Love that. Actually, I love Atlanta. My wife and I are always going there. Either we're in Atlanta, we're in Peachtree City, we're in any of the places around the Atlanta. We always go to Alpharetta. And Darnell in Chicago. All right, let's begin.
Okay, now we get to some of the fun part, the networking. And the next section of preparation for the Google Professional Cloud Architect exam is networking. Now, I can't go into a huge networking course during this program, but networking is going to be very critical. So I'm going to give you a couple options. On our YouTube channel, we have a free CCNA boot camp, which will give you a lot of information on networking. We have subnetting workshops. We have BGP workshops. And please do check them out. There's a set of networking labs that you can watch through, but we walk you through so you'll really learn networking a lot more than we could ever cover in one of these exams. So please go check that out. I think it'll help you so much. So networking is the ability for the systems to actually talk to each other. And without a network, we have absolutely zero. If I had one computer here sitting in one room and there was no network and another computer next to it, the two couldn't talk to each other. So keep that in the back of your mind. For everything to work, we need a network, and the network needs to be well planned and fully operational. So in the cloud, the network's going to connect our resources together. You're going to need a network to connect to the cloud, and that's typically where we're going to be dealing with a lot of networking concepts. Now, these will still be basic networking concepts, but we're going to get involved in a lot of networking concepts. So let's have fun. The first thing I want to talk about is your three kinds of networks you'll typically work with. And we're going to draw them out as LAN networks, which are local area networks, metropolitan area networks, and then wide area networks. And then I'm going to draw it out architecturally the way we would typically connect to our cloud providers so you could see this and understand before we begin the networking discussion. So we have first this concept of a local area network. And a local area network is what you have in a local area. So typically speaking, inside of a building. Now, we could have two buildings next to each other, and we can have a piece of fiber optic cable under the ground, and that's still considered a local area network. But a local area network is going to be where your things are typically. So I'll give you the example here is here we've got the building. And the building's going to have a bunch of routers. And then the building's going to have some switches. So let's just say we have routers and inside of the building. And then we have switches inside of the building. And our servers plug into the switch. For example. And we could have users on another set of switches, and that we can have some users here. And what will happen is the users will be able to access the systems, because they're plugged into the switch, which is plugged into the routers. The routers are connected to the switches. So a user here on the local area network wants to access something on a server, and they do. Now, you won't know it, and they won't really talk about it, but you want to know exactly how the cloud providers operate? They have their buildings called their data centers, and inside of their data centers, they've got a whole lot of routers and switches, and they've got their servers and their storage plugged into these switches, and that's how everything works. Now, that is what we called a local area network. Now, the next thing we have is something called a metropolitan area network. Now, most people refer to the local area network as a LAN, and typically speaking, you hear a metropolitan area network often called a MAN. I didn't make up these terms. And realistically speaking, what is your typical metropolitan area network? So let's say you've got a building, and then you've got another building that's, say, 30 miles away, and then you've got another building that's, say, another 30 miles away. And what you do is you get these underground fiber optic cables between your organizations. And this is called the metropolitan area network because basically it's over a city. Now we're going to talk about a wide area network. And here's a wide area network. We've got a New York office. We have a London office. We have a router on both sides. Oops, didn't mean to do that. And we bought a 10 gig Ethernet link, private line in between these environments. This is called a wide area network. But you know what also is? I'm going to show you. And the reason I drew this out is so you would get it for cloud computing. So let's say this is the customer. And they want to access their system securely, which most likely they will be, meaning not over the internet, over their private environment. And their critical systems, they're not going to want to be reachable over the internet. So let's say you've got your systems and over here, and it's the cloud provider. In this case, it's the Google Cloud because we're doing the Google Professional Cloud Architect certification. Now, in most cases, it'll be multiple cloud providers. But here you do. You've got a connection on both sides, and you need a wide area network that you could use to the cloud provider. Now, you could create a VPN tunnel through the internet. You could get a private line between these two. And if it matters, you're going to use a private line. And all of a sudden, now you're here connected to the cloud provider, and you've got a local area network in your customer site where all your users are plugged into that are in the environment. And look at this, and I want you to see this. So I'm going to put user. Now, because we have a wire between us, or the equivalent of a wire, all the users in this LAN are not traversing the internet, which is a terrifyingly scary place to get their information from the cloud provider. If you wanted to manage the systems, you didn't need a Bastion host. You could do it directly from the local area network and the wide area network connecting the two. So this is your network that you could have. Now, there's options we could use here, like a private line, IPsec VPN, a software-defined WAN, a SASE WAN. Obviously, that's a lot of architectural training that's way, way, way beyond the scope of this. It's in our architecture courses. And there's also some video discussions of these types of wide area network technologies that you can see on our YouTube channel. But if it need to get deep, it's inside of our architecture program. So those are the three kinds of networks that you typically need. Now, how do we determine which one of those we need? It'll be based upon the kind of access we need. And realistically speaking, we would use a private line if we need guaranteed bandwidth. We would use a VPN if we don't need any guarantees and we want to use our internet connections. And often a VPN is much faster to set up and it's often potentially cheaper. We'll get to these wide area network connections later, but I didn't want to start a discussion on networking without actually getting there. Which brings us to the virtual private cloud. Remember, the virtual private cloud I showed you on the first day is your virtual private data center. It is a private network that you've carved out, or the cloud provider has carved out just for you inside of their systems, logically created. This is where you're going to put, because it's your virtual private data center, this is where you're going to have all your network stuff. And because of your network, all the other stuff will be logically plugged into your network. So this is where you'll put your IP address ranges, like your CIDR range or subnets. You may have access lists, your firewalls, load balancers, all that stuff. All the same networking that you would ever have in a data center is going to be identical same networking on the cloud. Other than in the data center, it's going to typically perform faster, and it's going to be hardware based. And in the cloud, it's all software emulated versions of the same networking thing. So keep that in the back of your mind. Now, Google has a global network. Obviously, they've got data centers all over the world, and they also have global networks. So you can create your virtual private cloud across multiple regions and give yourself a single network of resources. Or you might want to separate it out for security purposes to not all be in a single virtual private cloud. Limit blast radius, what have you, segment your system, but you do have the ability to do that. Now, when it comes to putting IP addresses, you're going to be like any other network. You'll have your CIDR range, and maybe I'll map this out for you to kind of explain this the way it would be done in networking. So typically speaking, you'll have your CIDR range, and I'll give you an example of what that would be. So if we had the 172.16.0.0/16 CIDR range, what does that really mean? It means this contains every IP. Well, let me change that to 172. So we stay with private addresses. It means that every IP address from 172.16.0.1 all the way to 172.16.0.0.255, which would of course be the broadcast address, is all contained inside of this. Now, here's something to know about networking, and you'll see why we have to subnet it. And again, we've got a multi-hour subnetting course completely free on our YouTube channel, so please do check that out. But what we would typically do is we would then further take this down to something smaller. So we might use for a LAN segment a /24. So for example, if all we needed was LAN segments, we could basically create 172.16.0.0/24. And /24 is typically a good size for a LAN segment because it gives you upwards of 253 hosts you can put on a segment. And even if you think you only need like 50 servers on a segment, you may add capacity, you may want auto scaling. So a lot of us network architects use what's called a /30 on a WAN traditionally, because there's only 2 IP usable addresses on that subnet. And realistically speaking, we didn't waste as many addresses. And I'll show you next why we have to subnet. But what we could do is we could use this as a single subnet on one link. And then the next LAN subnet, we could use a .2. And then the next one, we could use a .3 if we wanted. Now, the planning of this out takes time. It's typically a CCIE level or better skilled in how to plan these IP addresses. And if the IP address plans are done wrong, the architecture will fall apart. It's like, because the IP addressing affects the routing. And it's like, imagine planning a street, planning a city, and not thinking about how many people would be on the streets and if they would even drive on the streets. So we can see cities that are old, which can't really accommodate cars very well because no one planned on cars being there. Same thing for IP addressing. So we would further subnet these down. Now, why do we have to subnet things? We have to subnet things for this reason. Every interface on a router or a switch has to be on a different subnet. So I want you to understand this. So this means that if this is a router and the router has four ports on it, and each port is obviously on a different subnet unless it's a switch router. So let me just draw 4 LAN segments on here, and I'll show you what I mean of why we have to be very diligent with IP addresses. Bear with me. I'm going to draw another. Each one of these is what you would, with the standard graphic, if you will, for a LAN segment. So let's just say we didn't use subnetting, and I want you to see what has to happen. So every subnet has to be, every interface has to be in a different subnet. So imagine for right now and these are public addresses. We're not going to use them. This is just for an example purpose. Imagine if let's not even do that. Let's imagine we put 10.0.0.0/8 on this link. Now, the 10.0.0.0/8 actually has approximately 16 million usable IP addresses in it. But if we put that on this interface, we couldn't use any of those addresses ever again. So that might mean we would need to use, let's say, this is now we're getting into a public address, so we're just going to ignore it. Let's just say this was 11, and let's say this subnet was a 12 and /8, and then let's say this one was a 13/8. Now, we basically used 16 million plus IP addresses on this link, another 16 million on this link, another 16 million on this link, and another 16 million on this link, which means we just burned through 64 million usable IP addresses that we could have used like that. So by comparison, if these were WAN links, not LAN links, but what we typically use is a /30. So imagine this, 172.16.0.0/30, and that would give us in that case we'd have the usable addresses of .1 and .2. You can check out our subnetting video to learn why. Now imagine that this next one, for argument's sake, we used was .4. So far we've used a total of 4 IP addresses here, another 4 IP addresses here of usable addresses. Now in the next, let's assume we used another /30 on this segment over here. Let's bear with me. And then you could see how, let's make this a .8. And then of course we need one more subnet to make this work. That's going to be the .12 subnet. So after we subnetted this down, instead of wasting 64 million addresses like we previously did by using the CIDR range, ultimately what we did is we burned 16 addresses and we needed 8 of them, which isn't very wasteful, versus previously we burned over 16 million and we only needed to use 8. That's why we subnet. And when it comes to anything on a network, it's going to need an IP address. If I sent you mail to your house and you lived in 123 Main Street, let's say Main City, Georgia, I just made it went up at postal code 123456778, and again I made that up intentionally so we didn't use anything real from someone, but that identifies you. That's how the mail delivery service knows how to find you, or the postal service, wherever you live. Every IP address needs a unique address. Internally, we use private IP addresses. And you can learn more about the private IP address space if you want to read the Internet Engineering Task Force, RFC 1918. And it specifies the private IP address space, which is the 10.0.0/8, the 172.16.0.0/12, and the 192.168.0.0/16. Those are the private address spaces that are out there. And you'll use that internally. Now, anything that is going to be external and needs to be reachable by the internet will need a public IP address, or at least the load balancer in front of it will need a public address, or something to that effect. Now, Google can let you use an automatically dynamically signed IP address, or you might want to statically configure it so you know exactly what the address is going to be, because you might need to configure certain things in your firewalls and other things along the way. So you've got both options. Now, we can create firewall rules, which will basically block network traffic like a packet filter. And users can assign firewall rules to allow certain things. What do I typically mean by this? I will show you. We can say, let's say we have a server, and it's an internal server. Let's say the only subnet that should ever be able to reach this server, that should ever be able to access it, is 192.168.2.0/24. And this particular subnet is where the developers and systems administrators and everybody that needs to access that subnet actually sit. So what we can do is we can create the equivalent on all networks of an ACL, an access control list, which is going to be a non-state listing or an actual stateful firewall, or even a next generation firewall or any kind of firewall we need. We can say on this one, permit 192.168.2.0/24, so we know it gets the entire subnet, to be able to access port 443 on the server. And then we would put the server. And then what we would do is everything else would be blocked. So one of these users tries to access this server, and they're allowed. Now, all of us, the next thing you know, we get a user, and this next user is coming from this IP address. And as soon as that packet hits this firewall here, it's just dropped. Now, we'll have the ability, typically speaking, in cloud computing to protect subnets, to be able to protect specific devices. There are a lot of firewall rules and types of firewall things we can apply on the cloud provider. But I wanted you to understand. So I thought a basic visual would possibly be helpful. So I hope it was. Now, on the cloud, we're also going to be needing load balancing. And load balancing is not new to the cloud. Load balancing is something that's been around forever and ever, which we've used in the data center, and we'll talk about what that is. Load balancing enables you to distribute traffic to more than one device. Now, why might we use this? Well, load balancers themselves improve performance, and they also improve availability. And we use load balancers to distribute traffic. Let me give you an example. I'll whiteboard some with you so you understand. Imagine an environment right now where we have one big server, one super powerful server. And this is a super powerful server. And right now we're operating at 3% capacity. And this server can go and has 97% more capability. Well, we don't want it to go that high, but let's just say this server's got, we never wanted to go above 90%, or actually we don't want it to go over 80%. So let's say we have 77% additional capacity left in the server. Well, what happens if the server crashes and goes away? What happens if the server's dead? Well, guess what? Our application is dead. The users of the application is dead, and our systems are down. So this may not be the most optimal situation. What might be more optimal, for example, is we have this load balancer. And in the cloud, the load balancers are high availability devices that don't go down. In our data center, we would use 2 data centers. But now let's say we have a large number of smaller servers, for example. Now what happens here is now we have 4 servers instead of just single. Now this is a logical device, and in the cloud it could be distributed across 100 different servers, so they don't typically go down, so you don't worry about this being a single point of failure in the cloud. In a data center we use redundant load balancers because they're real devices. But now if one of these servers goes away, the rest of the load balancers take over the load. So how is this going to work? And this is going to work in DNS very similar ways. It's going to work with our load balancers. So what's going to happen is the load balancers themselves are going to do some flavor of a health check. Server 1, are you there? Yes, I'm here. Everything's good. Server 2, are you there? Server 2 says, yes, I'm here. Server 3, are you there? Yes, I'm here. Everything's happy. Server 4, are you there? Everything's happy. I'm doing good. Now this continues to occur. So let's say server 1, are you there? I'm here. Server 2, are you there? It doesn't respond. So it checks on server 3. Are you there? Server 3 is there. Server 4, are you there? Yes, I'm here. Now again, the load balancer checks server 1. Yes, I'm here. Server 2 does not respond to the health check. What's going on with server 2? Server 3, are you there? Yes, I'm here. Server 4, are you here? Yeah, I'm here. Server 1, are you there? Yes, I'm here. Server 2, no response. Okay, not load balancers now says, this server is dead. Don't send any more traffic to it. So the load balancer marks it as something, and every load balancer has its own way that it does it. But basically it says, this server's persona non grata, don't send anything to it. And now the load balancer sends to the other servers. Now, potentially speaking, you could have auto scaling and add an additional server because one server's even down. And that basically can further self-heal your environment, but that's what the load balancer is doing. Now, we're going to have two kinds of load balancers that we can typically deal with in all cloud environments. And we're going to have network load balancers, and we're going to have something called application load balancers. And they are similar in function, but they're slightly different, and I'll explain the difference. A network load balancer is not a highly intelligent device. So when a packet comes into the load balancer looks at its TCP, with the protocol, TCP, ID, like UDP, ICMP, the source address, the destination address, and poof, it sends it to the servers. It's not looking at that much. It's looking at certain things, layer 4 type information. And because of that, these load balancers are fast. They send traffic at an alarming, blazingly fast rate. So imagine if your servers have 384 cores. You're going to want a network load balancer to deal with these blazingly fast servers. Now imagine if this wasn't a server, but this was a firewall or a route that you were load balancing amongst 4 firewalls, because no one firewall was strong enough for you and you needed high availability. Now, again, you're still going to use a network load balancer because networking things have to be fast. So we use network load balancers when we need speed. Now, it's not looking a lot. It's looking into the headers, the layer 4 stuff, source, destination, protocol, port, that kind of stuff. So because it is fast, and I ask you, how fast can you do 2 plus 2? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Pretty easy, right? It's not complicated. Now, the application load balancer looks into much more. It looks deep into the packet headers. It could look at the HTTP or HTTPS method routing, push, get, what have you. It can dive deep. And because of that, application load balancers are highly intelligent, but they're fairly slow. And they're slow because they're doing a lot of work. So if the network load balancer was 2 plus 2, which we did was pretty quickly, what if this was calculus? You can see you can't get out calculus problems as fast as you can. So where might you use the application load balancers? Small servers, little mini servers that you might have. You might use an application load balancer to load balance. You might also use them to load balance in between containers. And realistically speaking, here's a container environment. Now, what do you do if you need speed and performance? Well, we might do something like this. We might actually have a network load balancer. And we might have several that load balances between several application load balancers. And then underneath that, we could have multiple microservices or servers. So let's just call it MS. We'll assume they're microservices. And not that that's an official thing, but we're just trying to make something to make this diagram. And by doing that, the application load balancer could load balance in between these microservices, for example, with a great degree of intelligence. And we still have the speed of the network load balancer, so we can do this as fast as we possibly can. And that's common as well with load balancing. So these are what load balancers are.
Okay, we're back. Hope everybody enjoyed the discussion on load balancers. If you did, let me know. Let me know you did. Maybe a hashtag load balancers in the comments section below. But I wanted to take a short break to see if anybody had any questions they'd like us to answer. And if not, we'll obviously get back to the content, but I'll give you a minute. And while I wait to see if anyone asks questions, I want to remind everyone that there is a free e-guide that goes along with this. And that free e-guide is available for you to sign up for. It's about 550 pages to help you pass the Google Professional Cloud Architect exam, since this is a Google Professional Cloud Architect bootcamp. I also want to let you know that tomorrow at 11 a.m. we're going to have a discussion live on Zoom, how to become an architect. We'll talk about what does a cloud architect do, the real cloud architect skills, how to get hired, for example, when you lack experience, how to get past the HR people that would tend to auto deny you. So we'll be talking about those. So, that's good. Seems like people are learning about the load balancers by the hashtag load balancers. I like, which makes me very happy. So I'll give it another 30 seconds to see if there are any questions. If not, maybe register for our webinar. Maybe give us a like if you're having a good time. Subscribe if you're learning something, and hit the bell to be notified of some new stuff, because we have a new video every day to help you in your architecture career. Well, maybe give me a hashtag Google Professional Cloud Architect so I know you're awake, alert, and oriented. And Chris, let's roll back with the content.
Now let's talk about connecting to the cloud, that wide area network. We're going to discuss it a little further, and we're going to discuss our two architectural options and how they are different. I previously discussed what a private line is, and here's the way they typically operate in cloud computing. You typically have your building, and what you typically have is you have a switch or a router that connects to the cloud provider. I'm going to call it a router, layer 3 switch router, whatever you have. You typically connect to a location, which is typically called a point of presence. And inside of the point of presence, you basically have your customer edge equipment, which is your stuff. And you basically bought this connection. And then they typically have what's called and then they typically have the provider equipment, the provider edge equipment. And then typically, of course, you've got the cloud provider. And typically the way this works is your cloud providers are going to have very big, fast connections to these internet service provider points of presence. And you'll typically buy a wire from you to this this point of presence, this wide area network point of presence location. And ultimately what will happen is you'll have to get a wire that connects your switch to the provider switch, which is called a cross connect. So this is your private line type environment for the majority of the cloud providers. And that's why I'm not using any specific vendor terminology here. I just want you to understand the way most cloud providers do this. Now, what you have to understand is this. This is what you bought. So if this was a 10 gig link, you're guaranteed to get 10 gigs all the time. If this link is 2 milliseconds across, it's going to always be 2 milliseconds across, because basically you bought a wire, even if it's this convoluted wire sort of thing. Now let's compare, and this is a private line. Google's got its own name for it, which we'll call it, but this is what we're really talking about. It's a private line, and this is what Google calls a cloud interconnect, realistically speaking. But private wall line, AWS calls this a direct connection. Azure calls it express route. The marketing people really make up some funny name for a private line. Now, the alternative we have is basically a VPN, and I'll talk about how that would work. So let's say we have a campus over here, and we now want to connect to the cloud provider. Now, we are connected to the internet. In this particular private line environment, and I'm going to draw a little line between the top and between the private line architecture up top and the wider and the IPsec tunnel beneath us. Now the cloud provider is also connected to the internet, and what we do is we use our routers, and basically what we're doing is we're typically creating a VPN, which typically is secured with an IPsec tunnel. And now what happens is we're using the internet as the connectivity between us and the cloud provider with an IPsec tunnel. Now, the key to remember here is you pay for this. So if you bought two 10 gig links to the internet, this means you have two 10 gig links to your internet service provider. Now, it does not guarantee that the internet has 10 gigs available even to get your traffic from point A to B. You only get and buy that connection to the internet. The internet is what's called best effort traffic, meaning if it's available and there's space, your traffic will be thin, meaning if there's not, your traffic will just get dropped. So the key to remember with the VPN, it's very elegant and easy to set up because we probably already have internet. The cloud provider has internet, and we just create this tunnel, which is typically limited to a couple gigabit per second. So it's not going to be the fastest link. And it's hoping that the internet isn't busy. So you can't use this for any mission critical traffic. Now here we bought a guaranteed level of performance, throughput, and latency with our private line here. So this gives us different options. So understand we need some connection to the cloud to be able to access it. And these are the two primary architectural options. So we also need to talk a little bit about the domain name system. And the domain name system is going to be a critical component of networking. And its domain name system is, realistically speaking, only doing one thing. It's translating a friendly name into an IP address. So it's probably very easy for you to remember www.google.com. I'm sure it is, but it would be pretty hard to remember the IP addresses of certain businesses. So that's typically why businesses and organizations use DNS. It provides the name to IP address matching. And Google has their own DNS. And it is a high availability DNS system. It's managed by Google. It's fast. It's reliable. And it's going to be there for you. So Google has that. And for advanced traffic management, they offer something called Traffic Director, which will provide dynamic routing for service mesh deployments and really does provide some optimal performance and availability for microservice-based architectures. But I want to make it clear, if you only use Google's DNS and Google were to go down and you had systems on 3 clouds, your DNS for your other clouds or the DNS that might send your traffic to other clouds would go down. So think architecturally, can you use a single cloud provider's DNS services? And Google has great DNS services, or do you need more reliability? Now, networking is not new to people. Even before we had these IT networks, people automatically made their own networks anyway. They would create people in their environment. They knew how to talk to them. For example, at one point, they'd live in a community and talk to each other. At another point, we had the phone and we could call each other. But this networking thing is not new. It's just changed. Now, we can think of modern networking and the internet, and it all started from ARPANET in about 1969, which was the birth of the internet. At the time, the internet was a military tool. It was an academic research tool. I mean, really pretty much the U.S. government, that was it. And a couple other governments, it was a science project. And now at this point, it's probably one of the most impactful innovations of our time. Global data sharing, go to global collaboration, working in any part of the world. So the internet has a massive impact on our lives. And when we're dealing with networking, we can think of private networks, which we purchase internally that we own, and the internet is that global network that we have. So if we think about it that way, we always had networking. So what is cloud networking? Basically, cloud networking is a software version of everything we've already been using, a software-defined version of what we're using. So while the cloud providers have their own networks, the physical infrastructure, the routers and switches that happens, when we get our environment, we're getting a virtual network created in software that's actually running on their servers. So kind of hope this makes sense. So now we're typically dealing now because now we're dealing with networks, and because we're now dealing with softer boundaries of the internet compared to other networking environments, what we're realistically talking about, we may need to use zero trust, which works on the concept of assume that you're breached all the time and don't trust anyone, and microsegment your environment and encrypt your environment, which gives you authentication, which gives you making sure you know who you're talking to when you don't have a man-in-the-middle attack and the data is encrypted so no one can see it, and you've got data integrity checks to make sure the data hasn't changed. So, there's going to be a lot of what we're dealing with zero trust and cloud computing. There are some differences in cloud networking, and that really changes a shift in your perspective because it's virtual. We also have to understand that in cloud computing, the networks are still software and they don't have anywhere near the capabilities that we have in the physical data center. So we're going to be limited in what we can do. We're going to have less features than we would traditionally have because the cloud provider is kind of a jack of all trades that gives you a little bit of everything. In the data center, we can buy specific to networking devices. So keep that in the back of your mind. So AWS has been in this business a long time, since about 2008. Google has been in massive compute for a very long period of time. Remember on that first day I drew a cloud for you? Now think about Google's data centers even before the cloud, making YouTube, Google Search, Gmail, and every other application they run. Millions and millions of servers, you can imagine, are being used to this, let alone the number of servers that are running their AI and their algorithms. So there's just so much going on. So what happened is we moved, in many cases, the data center, the physical data center, to the cloud. So that's what we're dealing with Google's cloud. Now, with regards to the cloud, we also have the concept of a content delivery network. And Google has a content delivery network. It's an excellent content delivery network. Of course, there are other content delivery networks that you can think of. And let's talk about why we will use a content delivery network and actually what it actually is. So let's whiteboard this. A content delivery network is going to be a network of servers that a provider has. For example, so let's say we've got a provider over here. And the way the internet works is there's going to be all these little points of presence all over the world. They're called POPs. And I'll show you what typically happens in these points of presence. And I'll show you why we often use content delivery networks. So the internet will have all these points of presence. And what's going to be coming inside of the points of presence? Other internet service providers. They're going to use this as a hangout, meet up kind of room. So, for example, let's say, and these are all going to be separate ISPs. Bear with me 1 second to draw it out. So let's say we've got this one. I'm going to use this one here. Let's say we've got another one over here. And then let's say we've got another big provider over here. But in this case, so let's say this was AT&T. And let's say this was Verizon. And let's say this is NTT, Nippon Telecom, a Japanese telecom. Oops, you can't really see that. So let's just call it an N. So what happens is all these providers have connections to this building. And all that's necessary in the building for the providers to talk to each other is running a cross connect, or it's just a cable to do this. So that's typically an internet point of presence. Now imagine this. Now you've got a content delivery network provider. So let me call it CDN. Now the CDN has a couple of things. One is they have fast networking connections. Let me just make this big, to all these internet points of presence. So they've got a fast network in between them. And in addition to the fast network, what they do is they put caching servers. So we're going to put a caching server in each point of presence. I'm going to call it CS. And by doing this, let's say you're a Verizon customer. As you get your traffic, let's say you want to access something. So you want to access something. So you go to a website. Because you're on Verizon, you hit your Verizon Internet Service Provider, but your website's hosted on AT&T. So what typically would have to happen is your routing would go to back to AT&T where the website's hosted. So you would go to Verizon. This would be your local point of presence, and all of a sudden you would go from your website, Verizon site, all the way to the AT&T site, and then your traffic would come back. So what's going on here is we're using up AT&T's bandwidth to go from this point of presence all the way there. Now, AT&T wants to save as much of this network as possible, and you don't want the latency time of reaching AT&T. So let's say we've got the user who's on Verizon, and all of a sudden they hit the Verizon content delivery network, and your information is already sitting here on the caching server. You don't even have to leave your internet point of presence and have to go wherever the source of the server is. So that's why we typically use content delivery networks. We use content delivery networks for two other reasons, and we'll talk about what those reasons are. Here's the first reason. So let's say here's our server. And let's say, here's our cloud and the server's well, let's not even worry about where the server's hosted. But let's say our server's here. Let's say we've got an Athens location. let's say we've got a Nepetamos location, which is my village in Greece. And let's say we've got a Crete location. Yeah, the island of Crete. You may have heard it be called Crete from non-Greek people. So let's say I've got a user in Athens, and here's the CDN. Now, obviously, it's not going to be one thing. It's going to be these caching servers. So all of a sudden, I've got a user in Athens. Let's say this is Nikolaos. And Nikolaos wants to get access to a web server. So Nikolaos is the first person today to want to access that web server outside of Athens. So Nikolaos goes to his browser, and he goes to the web page. It's not located in the Athens Content Delivery Network, so it goes all the way back to the source. The server then responds, and then it's seen by the Content Delivery Network, and it's cached at the Athens location at the Content Delivery Network, Athens cache. And now the information is here. Now Nico's finished his work, but now we've got someone else that wants to use the system. We've got Dimitri who wants to use the system. So now Dimitri wants to use the system. He's also in Athens, Greece. Dimitri goes on his browser to the same website that Nikolaos just went to, and immediately his traffic hits the Content Delivery Network point in Athens and is immediately sent back to Dimitri. And now Aguilo wants to use the system, so Aguilo uses the system. He's also in Athens. He hits the local Content Delivery Network and his website come back. So what you can see is not only did the web server only have to handle one web request out of the 3, but the latency has also been reduced by storing it locally at the Athens part of the Content Delivery Network, which means the user experience was better and there was less work on the server, which means I can scale better. Now, here's the other thing that we want to talk about. So let's assume we've got a bad guy, bad girl, a couple of bad people that are trying to cause an attack, and somebody launches a DDoS attack towards that web server, and they send a bunch of 50,000 TCP SYN connections very quickly, and all of a sudden it hits the Nepetamos part of the CDN, and the Nepetamos part of the CDN says, this is bad traffic. I'm not going to send it to the server. I'm not going to overwhelm the server. I'm just going to drop it here. So from a distributed denial of service protection, we get a lot of mileage out of our content delivery networks. So I hope that makes sense why we use content delivery networks. It enhances scalability. It enhances performance by reducing latency. It decreases server costs. It decreases the wide area network transfer costs in many cases, and it helps protect against DDoS attacks. So all in all, big wins for content delivery network. So let's talk about Google's network. It is global. It serves billions of users. It supports internal applications, public applications, whatever you need. So public applications would be things like Gmail and YouTube, and customer applications. And this is connected to everybody. Now, Google also has a lot of data centers. In fact, they've got 22 data center regions, 67 zones, which are data centers inside of them, 140 internet points of presences, and 800 global cache nodes. So they've got a lot of cache systems that are already out there in a reasonable number of points of presence. So they've got their own network. And it's a big network, and they've got a lot of infrastructure. And when they're selling you cloud computing services, they're selling you access to a network and a data center, which is cloud computing. We talked about what are points of presence, and Google has edge points of presence as part of their data center. And, we talk about how the user requests will be routed, and they will be routed, typically speaking, to the place with the lowest latency. So there is that. Now, Google as a global network has what you call a Juniper network fabric. And that's Google's custom networking hardware system. Juniper provides immense bandwidth and scalability. It delivers more than 1 petabyte per second of total bandwidth. And that allows 100,000 servers to exchange data at 10,000 gigabit per second each. So it's a pretty big, pretty powerful network. This network throughput is so big that it could read the entire contents of the library of contents in under 1 1/10 of a second. So that's how much data you can push on it. But again, you got a lot of users pushing on it. So don't exactly think it's that big and that scary when you consider the number of users using it. So we can talk on Google's network. We can talk about the Andromeda virtual network stack. And that is Google's software-defined networking stack that abstracts the underlying in-network infrastructure and the data center hardware. It ensures secure, private, and efficient business operations for Google and its cloud tenants because it's keeping everybody separate. It's all software-defined networking. It's all in software. And Google likes to say that their iterative improvements with Andromeda have led to significant performance gains, such as a 3.3% increase in virtual machine to virtual machine network communication. So that's pretty big. They're constantly, obviously, improving their network. As they need more and get more customers, they're going to constantly have to keep upgrading the capacity of the network. Now, generally speaking, with networking, we should encrypt our data often. If we're on a public network, we have to encrypt our data. And if we're on a private network where no one has access to it, is it questionable? Do we need it? Questionable. But we might still want to encrypt it to make sure the endpoints are who they claim to be and that the data hasn't been changed along the way and provide a non-repudiation trail. So we might want to do it anyway. So think about that. Now, Google will encrypt and authenticate all network traffic in transit when it flows outside of the boundaries and it's not controlled by them. Like I said, you don't necessarily have to encrypt internal traffic data in the private network, but once it goes to the internet, it must be encrypted. Now, generally speaking, security professionals, we would question the lack of encryption for data in transmit, potentially on the Google Cloud in a multi-tenant environment, but the reality is we can encrypt our IP traffic across their network anyway. So by doing this, we're there. But generally speaking, keep that in the back of your mind. If a cloud provider is not encrypting things, a packet sniffer or protocol analyzer could see traffic, and we're subject to things like an ARP poisoning attack or an ARP cache poisoning attack. So there is that. Now, it's very hard to encrypt an entire enterprise network because that will take a huge impact on speed and performance. So make sure your data is actually encrypted. Google provides what's called encryption in transit, and that's with something called Google Front End. And that's going to be a reverse proxy that's going to protect Google's backend services. When a user will send traffic to Google, it'll reach the nearest edge node, and then it'll be routed through the Google Front End. And that way the Google front end can authenticate the user. They can ensure the integrity of what's being sent, and they can use encryption in transit. And that's typically TLS security, specifically boring SSL. Let's talk about protection inside of Google's boundaries. Inside Google, we may have data that needs various levels of protection. And the data that remains inside of Google's physical boundaries is generally going to be authenticated and tamper resistant because it's already inside of the system. But when data leaves Google's physical boundaries, now the network is not completely trusted. It's considered semi-trusted, and therefore Google will enforce authentication on encryption in transit, which is great. Now, with regards to encryption in transit, let's talk about some application layer security. So Google will use remote procedure calls for service-to-service communication. And this means these calls are going to be, these Google remote procedure calls are going to be authenticated, which makes them tamper resistant because you know who they actually are. And they're encrypted in transit using AES encryption for any calls leaving the physical boundary. So within Google's boundaries, the focus is authentication, ensuring that the data is tamper evident. But when it leaves it, it's making sure that it's encrypted. So let's talk about encryption in transit. Let them think about internal security controls. Google will attest and rigorously test their internal security controls to prevent any kind of insider threats. And you have to hope they are, but you have no control that they're doing what they say they are. Google maintains high levels of audit and compliance of these controls. Absolutely. So let's think about some additional security measures. We may have multiple tenants on the same environment. And we'll talk more about tenancy and virtual machines, but I'll give you a little information on what I mean by that right now. In the cloud computing environment, we might actually have a server. And let's say this is the physical server. Now, the server is going to have a hypervisor, and that's going to be what's going to separate you from your clients. Now, that means that you're going to, in most cases, have multiple companies here. So let's say this is this is a Cindy company. So her virtual machines, or Cindy's company's virtual machines, are going to be here. Now, Cindy has a nemesis. We call her Caddy. Caddy seems like a very nice cat, but Caddy comes every day and Cindy is terrified of her. So that's Cindy's nemesis. Now, we could also have a cat. Let's say it's an orange cat. I've been meaning to get an orange cat or an orange Maine Coon. So let's just call this the Maine Coon that we don't have yet, that I would like to bring home, but I don't think my cat would be happy about it. So I haven't done so yet, but I've been meaning to do so. So let's say we've got these 3 different businesses or on the same system. In theory, and meaning most of the time, realistically speaking, Cindy should never be able to see Caddy's traffic, or Maine Coon shouldn't she see Caddy or Cindy. They are logically separated by the hypervisor. Now, if the hypervisor was attacked, the concern is always the virtual machine escape, that you could leave Cindy, hack the hypervisor, and go into Caddy as well as the Maine Coon. It should not happen. But under high security circumstances, a company may not be on a multi-tenant server. They may mandate that the server is dedicated to themselves, because these attacks shouldn't be possible, but they still could potentially occur. So I kind of hope that makes sense. So make sure you're using encryption. Make sure you're securing everything that you possibly have that's under control for you.
Okay, well, we are back. We've been having what I think is fun, but then again, this is the kind of thing that I actually enjoy in life. So I hope you are all having a good time. Now we're here to answer any questions. It looked like 1 or 2 popped in, so we definitely want to answer that. And if you have any questions, let us know. But Chris, I saw 1 or 2 questions come in. If you want to bring them in. Could I elaborate for the audience the differences in load balancing strategies, specifically when it comes to managing access across cloud native services, internet facing endpoints, and cloud adjacent services? So why don't I do this in production by Inc? What if I walk through every kind of load balancing that we've been using for the last 30 years that exist in absolutely every data center, in absolutely every cloud provider in the entire world? And I think we can do that in about 5 or 6 minutes. And that way you'll understand them all. So let me walk through this from an architectural perspective. I'm going to start with the kinds of load balancing we use and where we use them. Now, the first type of load balancing I want to show you is load balancing between clouds. Now, let's say I had a publicly facing website. Let's say the website is Go Cloud Careers and it's in 3 different clouds. So what I would do is, obviously, DNS, we would register Go Cloud Careers. Say it, hold on, CRERS.com. And that would be the domain, and we would put that in the domain registrar. And then we would set up a routing policy that says send 50% of the traffic to our data center, send 25% of our traffic to AWS, and 25% of Azure. And what happens is the DNS will run a health check. Data center, you there? Data center, you there? Data center, you there? And if for some reason the data center doesn't respond, we mark it as unhealthy, and DNS will shift the traffic to AWS and Azure. Now, if our virtual machines or containers running our websites are in AWS and Azure, and our data center goes bye-bye, the auto-scaling groups in AWS and Azure will be able to auto-scale within 30 to 45 minutes to handle the capacity. So that's one type of load balancing we use. But let's talk about in our VPC. So in our VPC, you're going to have a lot of different kinds of load balancing. You may have a load balancer between virtual machines. This could be an application load balancer, network load balancer, or both. We may be using an application load balancer to load balance between containers, for example. We might be using an API gateway, which basically also does load balancing to load balance between microservices. And we might be using a network load balancer to load balance between our virtual firewalls that we're going to use to connect our VPC to the internet. But and there's a reason I want you to show you the rest of it is it's all load balancing. So if we go to the servers that AWS, Azure, Google, or the server sitting in my home, you're going to know most of them are going to have what's called a RAID card in that. And the RAID card is going to load share between various hard drives. For example, if you've got in this drive if you've got 6 drives, and each one is 4 terabytes, you can have this basically have spread the load across the drives. So if you have 6 4-terabyte drives, you'd have 24 terabytes together in RAID 0, for example, and you would have 6 times the speed. Now, when you go to the cloud provider, and we're going to get into object storage, and block storage and file storage. But when we deal with the file storage the block storage, this virtual hard drives, here's what's going to happen. They're going to sit in these giant boxes, which are going to have RAID cards, and each RAID card is going to be connected to a whole bunch of hard drives. So we're going to see load balancing there via the RAID cards. But when the load balancer connects to the network, we might have 400 gig links or 4 800 gig links or whatever it is that we're using to connect the storage area network to the network switch. Now, we'll typically place them in something called the link aggregation group, and the switches and the devices will actually load balance between those links. But we might also use BGP or a routing protocol to load balance between this link or this link in our data center. But it's not just there. I mean, load balancing's everywhere, because now let's go break it down and go to a server. Modern server, let's say we have 2 64-core CPUs in it that we use in that virtualization. Guess what? We're going to load share across all of these CPU cores. The hypervisor will typically take care of that. Now, if you open up the server, you're going to see DRAM and banks, and we're going to be load sharing across them too. And if you're dealing with an AI computer, you're typically going to have a PCI interface that's going to load share between the various graphics processors inside of that same device. And to be fair, if we even connect our data center to the cloud, guess what? We might have 4 links up here from Verizon and 4 links over here on AT&T. And what we might do is put one subnet on the top link and one subnet on the bottom link, and then an aggregate route as backup for the top and bottom. And that way we could load share for these links. So what we're really doing here is we're basically load sharing throughout everything we entire do. It doesn't matter whether it's a microservice, a server, a network port, a network switch, it's all the same load balancing. So I kind of hope this. So here's the things that I want you to think of for load balancing to work. Something has to track these connections, right? So in DNS, we use a health check. In a physical load balancer, we use a health check. Across these links, we might have a layer 2 protocol. We might detect when a laser goes down. It could be keep alive is missed and a hold timer is missed in a routing protocol. So we always have to find and to detect a failure. And once we detect a certain number of failures, we need to know when not to use that. That's realistically speaking the components of load balancing. And why do we use load balancing? Well, I can load share across 6 hard drives. I've got more speed than if I only have 1. I can load share across 8 GPUs. I can do more machine learning or AI than if I had 1. I'm in my data center and I want to load balance across virtual machines. Well, I don't have a single point of failure if I have multiple virtual machines. So I can combine capacity and performance. So I kind of hope that answered your question there. And it said, perfect. This is exactly what you thought it was looking. Wonderful. I'm glad I got it. Can I describe the types of private lines to connect to a cloud provider? So, Darnell, let's whiteboard this. I like the question. So when it comes to private lines, realistically speaking, it's going to be one of 2 ways. And in reality, you're never going to know the difference. But let's walk through it. So you could have something that looks like this. Let's say you had fiber buried under a city. Let's say this is your building 1. And let's say this is your building 2, and it is 50 kilometers away, but you own them both. Now you could own, and truthfully, a piece of fiber optic cable under the ground. And what you're basically connecting to is you're connecting to an Ethernet card. You're connecting to a wire, and this is going to be an Ethernet handoff in both places. Now, the next way that you can basically get this is, and all this stuff is has been around for a while is you can connect to a phone company or a wide area network provider. And one of the options is they can create a switched wired connection for you where it'll just feel like an actual wire. And it'll be a wire that you plug into building 1 and building 2. This is your traditional private line. Now, in the old days, this was signaled electrically. When I started, the electrical engineers were the network engineers. I mean, all this stuff was signaled electrically in switches that opened and closed physical circuits. Now, what it is in today's world is, in most cases, the way these wire, and then I'll map it out for you. So let me just get rid of the fill. So what it is in today's world, and I was one of the people that helped design many of these things when this first became possible. When I was working at Riverstone, Luca Martini was at Juniper, Footer, and my friend and I were working on this at Riverstone. It was the creation of what was called the pseudo wire. So what you would do is you would connect to the service provider's wide area network via just standard Ethernet cable or a fiber optic Ethernet cable. On the far side, you would connect to the service provider's network. And inside of their network, it looked something like this. It was an IP network, and most of your private lines now are signaled this way because it's just so much more convenient. You've got a typical underlying network, say it's OSPF, IS, and by ISAS I mean intermediate systems to intermediate systems. The old CLNS routing protocol that's widely used for routing in today's world because it scales really well in the way it sends its LSAs. So what happens in today's world, many of these private lines look like this. So what happens is you basically buy what's called a pseudo wire. And what's happening is you connect via a real cable here, you connect via a real cable here, and then you're buying a virtual wire across the company's back, across the IP provider's backbone that's basically routing and electrical engineering signals sent into MPLS to be tunneled across the backbone. So that's typically there. So what does it really look like when we actually bring this into the cloud provider? Well, we're here in our campus or wherever our people are, and we ultimately buy a link to a point of presence. Now, a point of presence is a place where a whole bunch of internet service providers and wide area network providers actually coexist together. So AWS would call it a direct connection center. I think Azure would call it a point of presence. It's all the same thing. So what happens in the point of presence is you're going to have a device like a router or switch, your device that sits there. And the cloud provider is going to have a big giant or a bunch of connections that goes back to the cloud provider. And that's going to be your cloud provider. And this works for AWS, Azure, Google. It's all the same. And what happens is the cloud provider has their switch over there. So what happens is the provider has a switch that's connected to their network. You buy a wide area network link between you and this point of presence, direct connection center, meeting center, what have you. And then what happens is you get a letter of authorization for where the direct connection facility, the point of presence, is allowed to run a cable between your device and their device. So what happens is you've got a cable between yours. It's called a cross connect. And that cable, that cross connect takes you between yours and theirs. So now you might say, but Mike, what's going on? This looks like a big pipe over here. Are a lot of customers going to be on this? The answer is yes. So what you'll do is you'll add what's called the VLAN N802.1Q tag. So you will have the blue tag. Another customer that will be on here will say have a different color tag traffic. So this traffic will be, and that's how the provider will separate your traffic as it crosses their network. So this is exactly the architecture of how these private lines. But if this is a private line that's signaled via MPLS, if there's a private line that's just a wire, in the reality, it's the same. So basically you have an Ethernet private line, which is what you're using to connect to the cloud providers now, in most cases. Hope that helps. Now, if you didn't want to, and Darnell, if you didn't want to use a private line, you could obviously use an IPsec tunnel, a software-defined WAN, a SASE WAN. But in this case, we were asking about private lines. Well, I don't see any more questions. There were some good questions. I love to see these kind of questions. So we have one more video, and then after that, Leo's going to get a little geeky and do some labs with you. So I hope that should be lots of fun too. So let me know you're having a good time. Give me a hashtag Google Professional Cloud Architect. If you're enjoying the content, give it a like and signal the algorithm to send others here. Maybe subscribe and hit the bell because I'd love to see you in another video. All right, Chris, let's roll back to the content.
Now we're going to continue our networking discussion, and we're going to begin with the network service tiers you can get in the Google Cloud. So Google offers you several performance tiers, realistically 2, on how you can send your traffic through the Google network. And which tier you use will determine how much performance you actually get, what your latencies could be like, but there'll also be a higher cost to get better network service and a lower cost to get reduced network service or more normal network service. So we're going to talk about what those 2 service tiers are, but before I do, it's going to be necessary to talk about internal routing and external routing. So let me whiteboard that out for you. In internal routing, we have an environment that we own. So let's say this is our data center or the Google's cloud data center. I don't care. We're just going to, I'm putting on one of the links a data is just data center, so we can use it. It could be Google's data center. It could be our data center. It really doesn't matter. The key here is in a private cloud, and we're going to use this to explain the service tiers in a minute. Everything in this underlying infrastructure we own, which means if we know how much traffic is going to be coming into our systems, we have the ability to make sure that the routers can handle the traffic and all these links that we have are big enough to handle the traffic. And we can capacity plan and always guarantee that our traffic is going to get through our network at a certain period of time. This is private data center. This is the cloud networks provider. This is all networks that are owned by a single entity. They can guarantee performance if they want. Now, in this separate environment, I actually drew internet routing. So let me call this ISP-A. And I'm going to draw this picture as ISP-B. And then I'm going to give you show you ISP-D. And then you're going to see ISP-C. And here's the reason why I want to show you this. Internet traffic is considered best interest, best effort, meaning there's no guarantee the traffic will ever get there, and there's no guarantee of the performance. It's best effort. Now here in a private network that we own, we can guarantee it because we can make sure that we have the capacity for everything. It's all under our control. But the internet is a collection of thousands of internet service providers that are connected to each other. And the way internet routing is, let's say we've got a user, and this user is a cat. Let's call it a Maine Coon cat. And in this case, we've got a user that wants to use the internet that is a tabby cat. And the tabby cat wants to talk to the Maine Coon cat. So the way internet routing is, if the tabby cat is connected to the internet service provider C, and the Maine Coon is attached to internet service provider A, what happens is the tabby cat goes to their local internet service provider. It says who has a route to the network where the Maine Coon would be, and it looks in its routing table and it says, I have to go to ISP-D. So it forwards the packet to ISP-D, and ISP-D says, who has the subnet? And it says, oh, I'll send my traffic to ISP-A. But see, ISP-C, ISP-D, and ISP-A are all different companies. So because they're different companies, the problem lies in the following. How do I guarantee is this link between internet service provider C and D could be fully saturated, or it could be small, and it may not be enough to meet the needs. Or let's say the link between the tabby cat and her internet service provider is strong, and it gets there fast. And even the link between the internet service provider C and D is great. We have no guarantee of the performance of ISP-A. So when you understand that, you'll understand that internal systems we can guarantee because they're under our control. Whereas external systems that are not owned by us, we have no control. So what does this mean? It means Google offers a premium tier of networking service that's going to leverage much of the Google's private network, and it's going to use more intelligent routing, and I'll walk you through it. So normal routing is a router sees the fastest opportunity to dump its packet, and it sends it to the next router. That's normal routing is called hot potato routing. Google can use cold potato routing, which is a little bit smaller, which is going to keep it on its network longer until it reaches the best place to give it to the internet. So that's what we're talking about with the premium service tier, and I will actually whiteboard it out because I really want you to understand those. Okay, so let's whiteboard this out. Now, you'll recall that I said what's under our control, we can guarantee the performance, but the internet is out of our control, so we can't guarantee its performance. So your VPC is obviously connected to the Google data center. It's in the Google data center. So I'm just going to draw a little link as if it looks like it's linked to the data center. It is. It's sitting inside the data center, but just for easy purposes. Now, this data center is the cloud provider's data center, and it's under their control. Now, this data center has the ability is connected to the internet all in so many different places. It'll have many internet service providers. There's many points of presence and internet peering points where Google Cloud is going to be on the same way all cloud providers would be. So there's two ways the data could be sent. In hot potato routing, which is going to be more of a standard tier, which we're going to talk about next, if we have data that needs to reach something on the internet from our VPC, it's going, or an internet user would be trying to reach it, it's going to get to the internet as fast as possible, which would be in San Francisco, and then route it all across the internet to where the user is. And let's say the internet here is in Palm Beach. This would be hot potato routing, where this router passes it, that goes to this router, and then the internet routes it to the end. That is standard routing that you would get in more than the normal performance tier. In the premium performance tier, Google does something very cool. What they do is they route their traffic all the way over their network where they can guarantee the performance, and then it actually leaves the network closest to the end user. So if I have a user in Palm Beach and this website set up at the west coast of the US, if the traffic is going to take the entire Google network where the performance is great, and it's going to only leave the internet and hit the internet in Palm Beach where the user is. So typically speaking, you could get a lot better performance as traffic would go in and out in the best path. So that's typically what you're getting with these premium network service tier, efficient routing. Now, the premium network service tier also provides some additional cloud networking features, global load balancing, and it gives you the ability to provide better performance. So now let's talk about our standard tier. Now, this is going to be cheaper, but you're not going to get the same performance. This is going to use that hot potato routing that I talked about. I'm going to show it again just to make sure you've got it. And in this case, you may also not have access to all of the networking features. Here we've also got lower performance. So please understand, cloud networking has already reduced features from what we had. So, if you're in that standard tier, you're going to get a lot less features potentially that we normally had and lower performance as well. And let's go back to show you why. In the standard performance tier model, instead of that intelligent routing all the way across the internal network to get to the closest ISP to the user, now, and that would be the cold potato routing, now we're using hot potato routing. So here's the normal service. Leaves your VPC and finds the closest point to get to the internet, leaves, regardless of where your internet user is. So that's why this is going to be a lower level of performance. So if we think of it, with the premium, we get better performance, we get better routing. With the standard, we get lower network performance. We get a higher service level with the premium, 99.9%. 99.99%, which is pretty good. That means 52 minutes of downtime per year, approximately. By comparison, on the standard tier, we get 99.9% availability, which is much less availability. So if we need high performance, a global footprint, and an experience and better networking features, we're going to use the premium tier. But if we're a smaller organization and we're willing to reduce some network performance, then we could use the standard tier. So let's now talk about the virtual private cloud, subnets, regions, and zones. And we introduced the concept earlier, and we'll talk about it some more. So the VPC is effectively your virtual private data center. And that's where you're going to put all your cloud stuff, like your virtual machines. And what creates these virtual private clouds, your virtual private data centers, your virtual hotel room inside of a hotel, if you will, is it's really a software networking functionality and network function virtualization. And this is basically software that creates software versions of traditional networking things. So what you'll see in any VPC or VNet for the most part are things like load balancers, access lists, routers, routing type features, and typical networking things. And because nothing can talk to each other without a network, your virtual machines wouldn't be able to talk to each other without a network. The containers in Kubernetes couldn't talk to each other without a network. Nothing could ever work without a network. So your VPC, you're going to put a lot of different things. So when we talk about a virtual private cloud, like I said, virtual private data center, let's talk about what you're going to get. You're going to get load balancers. And you'll have that. We'll talk about we'll talk about every technology you need to know for this Google Professional Cloud Architect exam. You'll have multiple WAN connectivity options to connect to other places, other clouds, your data center, what have you. And that means you'll typically have a private line, some form of a cloud interconnect or a dedicated interconnect. We'll talk about these kind of things, the dedicated internet connect. And you have VPN tunnels like an IPsec tunnel or a TLS tunnel. Now, in Google, VPCs are global resources, meaning they're not going to be tied to a specific region, which is a geography, or a zone, which remember is just a data center in the Google Cloud. And it will provide project boundaries. So VPCs are going to be created within projects, and they won't typically allow cross communication. And they definitely don't by default. So the point is, we put our VPC, it's a boundary. It's a segmentation or a micro segmentation of our system, depending upon how many of these we use. Now, of course, if we're dealing with routing, you'll have to put your servers in a various subnet, and your network will still have a global CIDR range or classless interdomain routing range. So that you'll have in this particular environment. And of course, regions are a large geographic area, and a zone is a data center inside of a region. So a region is going to be that big geographical area, and it'll contain multiple data centers called zones. For example, there's a U.S. East region located in Ashburn, Virginia, and there's a couple of zones in there as well. So a zone is going to be an isolated location inside of a region that's going to be usually a single data center. And zones within a region are designed to be isolated from each other to protect the impact or an outage from one zone to another. Theoretically speaking, if we've got one data center and we've got another data center and they're independent from each other, we shouldn't have problems. But do they share networking? Do they share routing? So they're still connected and they can still have problems from one to the other, even though the theory is that they shouldn't. Now, the point here is, you don't want to put all your eggs in a single basket when it comes to availability. So if we have a zone, we have a region which is going to be a relatively large geographic area, it doesn't make sense to put it into only one data center. Split your load amongst multiple data centers, and that way if one data center goes down, you've got another to back you up. And if we had one zone here and one zone here in a non-super high availability environment, but a relatively high availability situation, and the one zone went down because the data center went down, the second zone could use auto-scaling and come up to full capacity, theoretically speaking. So, that's one option, and that's why we're talking about zones. Other providers call them availability zones. They're data centers. Now, let's talk about fault tolerance and redundancy. So if you're building a critical application, you can't have any single points of failure. Many people would say that a single cloud is a single point of failure because there's cloud shares to some degree a common network. There's control planes across that have to integrate to all clouds. So if you had a major network outage, a major hacking event or or a control plane failure at the cloud provider, you could be in every availability zone and every region in the world, and you're still down because the cloud provider is down. So many organizations use multi-cloud. But the key here is we have to think about everything in higher availability systems. No single points of failure. Redundancy everywhere. So redundancy in your connections to the cloud provider, redundancies in the routers that connect to the cloud provider, redundancies in where your systems are plugged in, and how many circuit breakers they're plugged into, and what your power looks like, and what your cooling looks like, and what your change control processes look like. Because you could have everything perfectly designed, and you could have a user puts the wrong thing on the system, and it can take everything down if they didn't understand the impact of their work. So when it comes to real high availability, we're going to be talking about so many other things, typically speaking. Now, we also have to assume outages are going to occur. So you should plan what happens if this availability zone goes down, or this cloud provider goes down, or this link goes down, or this power supply on your router goes down, and see what the impact is. Now, if it's a router with two different power supplies on two different circuit breakers attached to two different generators, and one power supply goes down, you're not out. You get a notification about it. You swap the bad power supply for a new one, but you're still running on the alternative power supply. So we always have to design, you could almost call it outage planning. You have to think of every kind of outage that would occur in your high availability design, and then figure out how you would mitigate that. And when you're dealing across 20 different domains, you're going to need an architecture team. So we're going to have to think about IP address planning. And that means we're going to obviously have a CIDR range for our environment. And that means we're also going to have subnets. Now, if the CIDR range is designed elegantly, the routing will be beautiful. If the subnets are designed elegantly, the routing will be beautiful. If the subnets are designed improperly, we will always have problems. So we have to be careful how the subnets are there. This is going to be more the work of a network architect to really be thinking about subnet planning and route planning ahead of time, but keep that in the back of your mind. But we'll have to create a CIDR range, and then we'll have to create a subnet. So for example, I know I did this a little earlier, this could be a CIDR range, for example, 192.168.0.0/16. So this by itself, this block, has about 65,000 IP addresses inside of it, depending upon how it's subnetted. So this is going to be a CIDR range. And then this gives us, which all the IP addresses are going to start from. I'll draw them out for you. If they were all going to be in the single CIDR range, which they couldn't be, and I'll show you why they couldn't in a second. But this means that this range will give us IP addresses of 192.168.0.1 all the way to this broadcast address, which would be 192.168.255.255. So that's a lot of addresses, and that's the address range. But a subnet might be this, 192.168. Let's say 1.0/24. And then another subnet would be 192.168.2.0/24. And another subnet would be 192.168.3.4 or 0. And I could do this all the way to 255, realistically, or 254. So /24s. And I could do that. But, oops. And I could do that. And I've got a fair number of these that I'm actually talking about. So this is really what we're actually talking about. The kind of ability to take this big thing and then chop it into many other different things. And these subnets that I've given you could also be chopped down into other things if we went into smaller subnets for WAN links. And that's how we're going to start with a CIDR range or a big address block, and it'll be subnetted down so we can do things properly. Now, I'll show you what I mean by good addressing, and I'll show you what I mean by bad addressing. This is going to be good addressing, and I can show you why. If in here we have 192.168.0.0/16, and over here we have 172.16.0.0/16, and we have a link between them. This is a beautiful situation. And the reason this is a beautiful situation is going to be as follows. All that needs to be sent for this traffic to reach each other is this route has to be sent. Let's call this our data. Let's call this our range on GCP. And let's say this is our range on AWS. But ultimately, when we send our BGP routes, the Google Cloud or your VPC on the Google Cloud would need to tell, realistically speaking, AWS of only one route, the 172.16.0.0/16. And it's going to be smooth and easy to set this up. And by comparison, AWS would only need to tell the Google Cloud about, or your VPC on the Google Cloud about a single route. And it's going to be 192.168.0.0/16 will be the route that's sent. This is simple and this is so elegant. And when we have this, we never have any challenges. Here's where things go wrong. Let's create another one. Let's put this here. See if this thing goes away. Okay, so here's where people get it wrong. They do this 192.168. Let's move these addresses, and I'll show you where we get in trouble. So if in here they put a 192.168.1.0/24, and then they get a 192.168.3.0/24, and then they get a 192.168.4.0/24. And let's say at the same time, somebody also used the 192.168 segment over here, and they decided to just divide it in a way. But over here, what they did is they did 192.168.2.0/24, and then the 192.168.5.0/24. Well, we have a problem now. And the problem becomes is this CIDR range, which you really want to send this 192.168.0.0/16, you can no longer send that route over to Google because Google also have routes in that same domain. So what this means is you'll ultimately have to send every single route along the way. And the cloud providers have limitations on how many routes you can actually send them. And when you do it this way, what will ultimately happen is you'll get too many routes in the routing table or the memory of the routers, potentially speaking, and then they crash, and then your entire network falls apart. And it used to happen much more with weak or inefficiently powered routers. So we have to be mindful about how we actually address these things. Okay, so that's elegant addressing versus non-elegant addressing. Again, if you're going to be a cloud architect, and that you're going to have to know how to create an architecture team and get the right architects here, and the network architect can help you. So your CIDR, your classless inter-domain routing will give a range, and then the subnets will be something inside of that range. If you're new to subnetting, we've got some subnet webinars. My team will pop that in the chat box for you to learn more about subnetting. Now, inside of your organization, you're going to be using private IP addresses. The same private IP addresses you would use in a data center. And they are the RFC 1918 private IP addresses, which are going to be the 10.0.0/8, which we talked about earlier, the 172.16.0.0/12, and the 192.168.0.0/16. Now we have to understand that we have private addresses. They're not going to be reachable from the internet for the most part because private addresses can't be routed on the internet. So we want to use private IP addresses whenever possible, and we want to keep our intranet subnets protected from the internet. Now, the only time we ever want to expose something to the internet, ever, is if it must be reachable on the internet. And if that's the case, then we need to do a lot to go protect that system on the internet, and ideally keep it out of our internal systems with a good, strong demilitarized zone, for example, for the security professionals amongst us. Now, Google Cloud, like others, also restrict certain IP ranges. They have certain IP addresses that are reserved for Google's APIs, services, and internal functions, so you can't overlap with them either. Now, we're going to talk about traffic types on the internet, and basically we're going to have egress traffic and ingress traffic. So let's talk about ingress and egress traffic. Ingress traffic is traffic that is coming into our domain or our network, whereas egress traffic is what's leaving our systems and going out. So ingress is coming in and egress is going out. And that's going to be ingress versus egress traffic. Now, you have to understand that certain cloud providers allow certain types of traffic for free, certain types of traffic that they charge for, and this changes constantly. So you're going to have to check. Generally speaking, ingress traffic is free of charge, and egress traffic, depending upon where or what kind of egress traffic, they typically charge you for. So if you think of an external website, that would be all egress traffic for the most part. The ingress is the request for the website, and the traffic going out is egress traffic. So you have to understand that and evaluate it and look at the specifics of your situation. Now, for anything to work ever, you need a network. And what routers do is they route traffic from one subnet to another. And we can use them to route to egress outside of the system. We can use them to route across our systems. So in networking, we're going to have a couple of different kinds of routes. And remember that routers look in their routing table to determine how to get traffic to its destination. So let's draw it out. Let's talk about the kind of routes you'll typically have inside of the Google Cloud. So in this environment, what you can see we have a network. And the network itself is going to have some routers. And the routers themselves will have what's called the routing table, which is going to be a map to get to the subnet. And there's going to be typically two kinds of routes you'll have in the routing table. And you'll have something that's what you'll see called the subnet route. And it's going to look like 10.0.0 /24. And let's call this link GE0. So let's assume that we had a gigabit Ethernet link on this router. And this link itself is called Gigabit Ethernet 0 in the routers world. And what you'll see is you'll have a routing table that's going to have two kinds of routes. And it's going to be, how do I reach a specific subnet? And where do I go when I have absolutely no idea where to go? So that's called the default route. And default route says, if you don't know where to go this way. So that's typically reserved for internet connectivity. Now, there's other times where we might use a default route for everything and then have routers that have more intelligence. But for the most part, a default route is used to connect you to the internet, because if you don't have a route to it in your external network, it's probably destined for the internet anyway, so just send it to the internet. So that's typically what we're dealing with in environments, is the routers themselves will build a routing table. So let's say this router over here has this route in its routing table. And then what this router will do, it says, if I need to reach the 10.0.0/24 subnet, go this way. And it'll typically give you the port that it egresses to or the next hop IP address, which in this case will be router 2. Then router 2 will have to look in its routing table, and it too will have a route which is going to send it to the next router. That router will look and say, do I have a route to 10.0.0.0? And it says, I'm directly connected. And what the router will do is it'll do what's called an ARP. Who has the MAC address for the IP address that they're looking for? And then it'll be sent. The host will respond, and then the traffic will reverse its path back with assuming the routes are in the routing table. So that's normal subnet routing. And a default route is when you don't know where to go. So if I know where to go, follow the path. If I don't know where to go, send the traffic to the internet or another location wherever it's pointed. That's called a default route. So in the Google Cloud, you'll use both, and you'll be getting in your VPC virtual routing. And that virtual routing is just going to be just like any other router in the world. The only difference is it's going to be software-based, and it'll be in your VPC. Now, you can create custom routes. which is that tells you, manually defines where you want your traffic to be sent. And you would always be doing this in networking. So nothing new here. So we also have firewall rules, and we have firewalls from the Google Cloud. The point is, firewalls are security appliances, and they're there to protect the perimeter of your network. And we're going to have multiple firewall options with regards to the Google Cloud. We have firewall components that protect our networks. We can potentially protect certain protocols, port numbers, source and destination. So it's going to be like any other firewall. So let's whiteboard it out. Generally speaking, you've got a firewall like this that connects to the internet. We'll call it a firewall, but it can also be between subnets. It can be anything that you want. But the point here is, and we're going to use lots and lots of these firewalls. Let's say it's for the internet. And the point of using the firewall is this. The firewall will not let traffic enter our protected environment behind the firewall. So we configure a policy on the firewall. And what I mean by the policy on the firewall is it allows our internal traffic to go out to the internet and return back. And the firewall is watching our traffic, so it knows to allow it back. It's called stateful. And that's great. But if an internet user tries to connect in, they won't be allowed. So we typically create what's called firewall rules. Now, you may hear the concept called the demilitarized zone and security, which obviously we're going to have all over the place. And what the demilitarized zone would be is, let's say we had a specific subnet off of the firewall. Everything internal to us is private IP addresses. So let's say our organization is using the 10.0.0.0/8 address space internally. This is a public subnet, so I'm just going to call it public IP address, so I don't use anybody's real address. Public subnet. And on here, let's say we have the load balancer of the public website, load balancer public IP address. And what we'll typically do is we'll create the firewall rule that will say, allow traffic of any of whatever source address is potentially limited to a certain environment through the firewall that are reaching this web server, or what looks like a web server, the front end of the load balancer's IP address. Any TCP traffic destined at port 443. That's web traffic. So realistically speaking, this firewall would only allow web traffic to this server or group of servers that's sitting in the internet. Those servers will obviously be hardened and protected because they're sitting on the internet, and yet no internal traffic can come inside of our environment. And that's why we create this demilitarized zone, to put things that have to be on the internet and not allow openings through the firewall for the internal to allow in our internal environment to be seen past the internet. So that's why we're using firewalls. We can be using firewalls to protect us between other companies we do business with. We could use a firewall between VPCs if we want to connect our VPCs, but we're going to be using a lot of firewalls. So we want to enhance our security. We want to micro-segment our environment, and we don't want systems talking to each other that shouldn't be, because it increases risk. We can apply firewalls to routes to roots. We can do it to specific virtual machines. There's lots of firewall type options we'll actually have that we can work with. We also need to think about networking. So we need to intelligently plan our IP address subnets. We want to use the right size subnet. For example, if we had a subnet that could support 65,000 users, but we could never put more than 500 systems on a subnet because of broadcast traffic, then that would be a big waste of IP addresses. So we need to design our subnets right and provision and use the right size subnets. And don't waste IP addresses, and don't put our IP addresses in the wrong places. We need to plan this carefully. You're going to need a network architect's help for this. So remember, firewalls are going to act as critical security controls, ensuring only authorized traffic or allowed traffic can enter or leave a network. So we can do this. When it comes to security, trust nobody. Just assume everything is dangerous and you're inherently insecure, and you're going to have to design a lot of firewall rules, a lot of security principles to meet these needs. Now, there are this concept of network tags. These are likely to be tested on the exam. So the kind of tags that we're actually putting on these things. So network tags is the ability to apply firewall rules to a root or something like that. So be able to think about being able to apply these tags or firewall rules. So we might use a tag to target or exempt a certain virtual machine from a specific firewall rule. So the tags give us some control in our firewalls to be able to label certain things to exempt maybe only this subnet can talk to the internet, this server on this subnet can talk to the internet, and all the others can't. So I kind of hope that it helps make sense.
So now we're going to be getting into the fun time real quick. Leo's got labs which she can talk about, but I just wanted to see if there were any questions. So, Leo, you want to talk about the next two labs that are coming up while we see if any questions come in?
Sure, Mike. We will basically demonstrate how to create that virtual private clouds. What is the underlying infrastructure needed to create the services in the cloud? And then we will create some virtual machines to show how things work inside the VPC.
All right, well, that sounds fun to me. So we'll get to that in a minute. Just a reminder that if for some reason you just joined us today, right now, we have the first 2 days available on our YouTube channel. You can go back and see it. We have a completely free guide that goes along with this. It's about a 550-page guide to help you pass the Google Professional Cloud Architect exam. It's a study guide for the Google Professional Cloud Architect exam that my team made. So make sure you sign up for it. Team just dropped it in the chat box. And also then on tomorrow, we're going to have a fun how to become an architect webinar. We'll go over the architect role, what we do. We'll talk about why it's safe from AI and one of the best roles moving forward. We'll talk about how to bypass HR, and I'll answer any question you want. So sign up. My team dropped the link for that in the chat box. It's all free. Get to meet you on Zoom, and I love meeting new people. Leo, are you ready for the labs? Anything to address, talk about before we go?
No, we are ready.
All right, well, let's get a little geeky and see Leo build this. I always love getting to see these demos. I'm an architect, see, we don't touch the tech in our lives. We're all about design, so it's fun every once in a while to see someone that's really capable with a lot of engineering background like Leo has 20 years build it. So let's get to Leo's labs.
Hello. In this lab, I will demonstrate how to create a virtual private cloud or VPC. I'll start here from the page cloud.google.com, and I will click the Docs option here on the top to open Google documentation. From the left side menu, I will click Networking, and then I will click Overview of Networking. The networking overview document or page opens here. And under the Explore Networking in Google Cloud, there is one document for the Virtual Private Cloud Overview. I will click the link to open the document. Here is the Virtual Private Cloud Overview document. There is a diagram here showing some regions and availability zones. And here there is one link for more information. See VPC networks. I will click this link to open the VPC networks document. This document explains what a virtual private cloud is and why this is needed when creating your IT systems in the cloud. And it also highlights what a VPC network does. It provides connectivity for your compute engine virtual machine instances. It offers native internal pass-through network load balancers and proxy systems for internal application load balancers. It connects to on-premises networks by using cloud virtual private network tunnels and virtual LAN attachments for cloud interconnect. It also distributes traffic from Google Cloud external load balancers to backends. Projects can contain multiple VPC networks. Unless you create an organizational policy that prohibits it, new projects start with a default network, and this default network has one subnetwork in each region. I will scroll down this document. read the document to understand more about the virtual private cloud. And here we have a diagram that shows the VPC network in blue, some regions in green, and some availability zones on yellow. The subnets are in pink, representing the subnetworks inside each region. This labs works best if you have clear the concepts of regions and availability zones in the Google Cloud. If you need a refresher, please refer to the bootcamp content or to the Google documentation. You can use the search bar here, but I will right-click here to duplicate this page. And then use the search functionality to find regions and zones. The first link is the document about regions and zones. I will close this tab and go back to the diagram. And right now we will create this basic or minimum infrastructure for the virtual private cloud network. I will scroll down to the What's Next session. And I will open the Create, Modify, and Delete VPC networks and subnets in a new tab. I will right-click and open in a new tab, and I will switch to that document. I will scroll down a little bit, and here there is some important information about creating an auto-mode VPC network. And the important information reads, production networks should be planned in advance, and custom mode VPC networks are better suited for most production use cases. The first infrastructure we are going to build is an auto mode VPC network. This is just to compare the auto mode with a custom mode, which is recommended for production use cases. The first step on creating this virtual private cloud is to go to the VPC networks page. I will switch to the console, and from the top left menu, I will select VPC network and then VPC networks. Here is the default network, and as the documentation informed, it creates one subnetwork for each region. There are 41 subnetworks in the default VPC for this project. I will click Create VPC Network to start the process of creating the VPC network. I will name this Auto Mode VPC. And I will not explain all the aspects or options for creating this VPC network. Please read the documentation to understand the different options on creating VPCs. Here, the subnet creation mode, I will change to automatic, and this means this auto mode VPC will create subnets for me. I will not have control over any aspects of the subnets that are going to be created. Here I can select some firewall rules, for instance, to allow ping to test the connectivity and to allow SSH for communicating with the virtual machine. There are some firewall rules that are created by default. A deny all rule for ingress traffic. This means any requests that are coming from outside your virtual private cloud will be denied. and a allow all for egress, or any request that is created or originated inside your VPC, those requests are allowed by default. So all requests going out from your system are allowed. All requests coming into your system are denied. Here there are more options for dynamic routing modes, best path selection modes. I will leave them as they are, and I will click Create. Now, the auto mode VPC is created. I can click its name to show some details about this VPC created using the auto mode. For instance, the subnets were created and some firewall rules were selected. I can click here to open the firewall rules that were selected. And this is it for an auto mode VPC creation. I will go back to the VPC networks page, because now I will show the difference when creating a VPC using the custom mode. I will click Create VPC Network button and enter custom mode VPC as the name for that VPC. And here under the subnet creation mode, I will leave as custom, because now I will customize the subnets. And here is the subnets part of the configuration. I will enter a name for a new subnet. I will call the first one subnet 1, and I will choose the region US West 1 for this subnet. I will leave it as a single stack IPv4, and for the IPv4 range, I will enter the IP address 10.240.0.0/24. I will accept the other options here and click Done. This is done for one subnet. I will also create another subnet. So I will click Add Subnet to create this subnet 2. And this subnet will exist in the region US East 1. The IPv4 range for this subnet number 2 will be 192.168.1.0/24. I will accept the other options and click Done. I will select the ICMP and SSH protocols to be allowed by the firewall on this virtual private cloud. I will scroll down, accept the other configurations or settings, and then click Create to create this custom mode VPC. Now the custom mode VPC is ready. I will click its name to open the details. And as a comparison, this custom mode VPC has only 2 subnets, and the subnets, they have one specific range of IP addresses because I entered that information when creating the subnet. So the custom mode allows for more control over the infrastructure or the network and the subnetworks you are creating. I created this custom mode VPC with 2 subnets. This is not rare that organizations need to create more subnetworks or more VPCs. In this case, let's say there is a need to create a new subnet. How can we create new subnets once the VPC is already created? We can click the Add Subnet button over here, and then we enter the name of the subnet. I will call this subnet 3. The region will be US East 1. And there are some different options now, but I will leave as none as the purpose of this subnet. It's not use specific at this point. I will enter the IP range for this subnet, that is 10.2.0.0/16. I will accept the other options and then click the Add button to add this new subnet to the existing custom mode VPC. So this is a basic configuration for a custom mode VPC. If we go back to the VPC networks page, we see that there is a default VPC that was created when this project was created. There is an auto mode VPC that I just created some minutes ago. And there is the custom mode VPC, which allows for more control when creating the subnetworks inside the VPC. The information I used to create this custom mode VPC with its subnets is basically the diagram we have in this document. I use the regions and the names of the subnets with their IP address ranges to create the VPC as it is shown on this diagram. In a future lab, I will create the virtual machines inside the different availability zones following this diagram. In this lab, I demonstrated how to create virtual private clouds. I created one using the auto mode, and I created a second one using the custom mode, which allows for more control when creating the subnetworks inside the VPC. As I will use this custom mode VPC in the next lab, I will demonstrate how you can delete a VPC by deleting the auto mode VPC. To delete a VPC, you need to delete all the resources inside their subnets. This means network peering connections, cloud VPN gateways, cloud routers, serverless VPC access connector, and their connected services, firewall rules, and custom static routes. As I just created the auto mode VPC, I don't need to delete those resources before I can delete the VPC. To delete a VPC, you click its name, and then you have the button to delete the VPC network. Click that button, and I need to type in or copy the name of the VPC to this field, and then press the delete button to confirm I want to delete that VPC. In the next lab, I will finish creating this VPC, creating the virtual machine, and allocating them on the subnets and availability zones. If you are going to do that lab, don't delete the custom mode VPC yet. Leave the custom mode VPC because it will be used in the next lab. If you don't plan on doing the next lab, you can delete the custom mode VPC now, following the instructions that I will demonstrate now. I will now demonstrate how you can delete a subnet and how you can delete a complete VPC. Let's first try to delete a subnet without deleting the virtual machine. I click the subnet name, and I can click the delete icon here on the right to delete that subnet, reminding that there is an existing virtual machine in that subnet. Or better, there are two virtual machines in subnet number 3, and here is the error. Let's go to the virtual machines page, and for the subnet 3, we will delete the VM3 and the VM4. Now the virtual machines are deleted. Let's try to delete the subnet number 3. Now the subnet 3 doesn't exist anymore. This is how you can delete a subnet you have no use for it anymore. I will go back to the VM instances page, and since I will demonstrate how to delete a complete VPC, I need to delete these virtual machines. And if there were any other services being used inside the subnets on this VPC, I would have to remove all the services as well. See the documentation to verify the specific services that must be deleted before you can delete the VPC. Now that the virtual machines are deleted, I will delete the VPC. To delete the VPC, you click its name, and then you click Delete VPC Network. You need to type in or paste the name of the VPC on this field, and then click Delete to confirm you want to delete the VPC. Now the custom mode VPC is deleted. In this lab, I demonstrated how to create virtual private clouds networks. I created one using the alpha mode, and I created a second one using the custom mode that allows for more control on creating the subnetworks. I demonstrated the whole cleanup, how to delete a subnet, and how to delete a complete virtual private cloud network. Thank you for watching.
Okay, welcome back, everyone. So we're here to see if anybody had any questions of Leo as it pertains to this lab. And if not, Leo, what's the next lab on?
Well, the next lab will be where I demonstrate how to create the virtual machines. I copied the end of the next lab to this lab because I wasn't sure they would be presented back to back. But
Okay.
now we will present the lab showing how to create the virtual machines inside that custom mode VPC.
Okay, good. So you're gonna take the virtual private data center that you created, and now you're gonna put some stuff in it.
That's correct.
Fantastic. Love it, Leo. Everybody give me a hashtag Google Professional Cloud Architect. Maybe if you're here, give the video a like. Maybe subscribe to the channel if you're not a subscriber. And Chris, I guess it's time for the next lab. Oh, also, I want to remind everyone that if you just joined us, we've got a completely free guide that basically goes along with this Google Professional Cloud Architect training. My team put about 550 pages of content into that Google Professional Cloud Architect study guide, so please sign up for it. It'll be emailed to you. Tomorrow at 11 a.m., we're going to have some fun, and we're going to talk about how to become a cloud architect. We run one every week, but tomorrow we're going to do it at 11 a.m. We'll talk about what we do as architects. We'll talk about the skills you need as architects. We'll talk about how to bypass HR, which you definitely want to do if you don't have the perfect resume. And we'll talk about anything you want related to becoming an architect of any kind: cloud architect, security architect, AI architect, enterprise architect. And it's all fun and live and free on Zoom. So sign up. It's in the description and the chat box. And guess what? I'll meet so many of you tomorrow. And we'll be finishing after the next lab. But we've got a lot more tomorrow. We've got a lot more Friday, and we've got plenty to go for next week. So I always like getting geeky. This is always fun for me. So, Chris, let's roll with the next one.
Hello. In this lab, I will demonstrate how to create virtual machines and allocate them in specific availability zones and subnets. In the previous lab, I created the infrastructure of the virtual private cloud, and now I will use that infrastructure to create the virtual machines and complete that suggested virtual private cloud from the document VPC networks. I will scroll down to that diagram, and in the previous lab, we created the VPC network. We created 3 different subnets in 2 regions, US West and US East regions. In this lab, I will create the virtual machines inside the different subnets and specific availability zones. Let's switch to the console. And here we have the custom mode VPC, and I will show the details with 3 different subnets that were created using the custom mode to have control over different settings. For instance, the IP address ranges for each one of those subnets. I will now open the Compute Engine VM instances page in a new tab. Switch to that tab. And then I will start creating the virtual machines. I will click the Create Instance button, and I will call the first one VM1. And this VM1 will be allocated inside the subnet 1. So the VM1 will be inside the subnet 1 and inside the US West 1A availability zone. If you need a refresh on regions and zones concept, please refer to the bootcamp content or to the documentation. But in simple terms, the region is a geographical area that contains a number of availability zones, and each availability zone is one physical data center inside that region. This means we cannot create new availability zones. They exist physically inside the geographic region. What we can do is to create subnets that span across availability zones. Let's create the first virtual machine inside the subnet 1. So this is US West 1 region. And I will select the availability zone US West 1A as in the diagram. For the disk of that virtual machine, I will select the custom disk, the custom image I created for the custom web server. I click select, and from the networking part, I will change the network interface because the default setting is to use a network interface in the default network. I don't want to use the default network, so I will click the delete button here on the right and click add a network interface. The network will be my custom mode VPC, and the subnet will be the subnet one that I created inside that region. Here is the subnet one. So after selecting the region and the availability zone, I select in which subnet I want to allocate the network card of this virtual machine. I will accept the other settings and click Done. And then I will click Create to create this virtual machine. While this virtual machine is being created, I will create the second virtual machine. I will change the name to VM2, and the VM2 will be created in the region US East 1 in subnet 2 and availability zone US East 1B. US East 1 and zone US 1B. As I did in the first virtual machine, I will change the disk for a custom image. That is the custom Apache web server. And for the networking, I will delete the default network interface suggested, click Add Network Interface, select the network, the custom mode VPC, and the subnet is the subnet 2 inside that VPC. I will click Done and then click Create, and I will create the third virtual machine, call it VM3, and the VM3 will be this virtual machine inside the US East 1 region, US East 1C availability zone. I will change the boot disk to the custom image of the web server. Under networking, delete the network interface, click Add Network Interface, select the custom mode VPC network, and now I will select the subnet 3 to create this virtual machine. I will click Done and then click Create. So now we have one virtual machine in the region US West 1 in the subnet 1. We have one virtual machine in the region US East 1 subnet 2. And the third virtual machine is being created inside the region US East 1 subnet 3 zone US East 1C. So right now, each of these virtual machines exists in a different availability zone. Physically, they are in different data centers. I will copy the external IP address of VM1, open a new tab, paste the address here and press Enter to test if I can reach the web server. And it doesn't go. I will copy the external IP address of VM2, do the same. And when the VM3 is ready, I will copy its external IP address, create a new tab, and test if any of those virtual machines can reach the web server. So far, none of them can reach the web server. Let's go to the custom mode VPC page and then click the firewalls option. I click the arrow to show the firewall rules, and I can see we have one rule to allow ICMP traffic and another rule to allow SSH traffic, but there is no rule to allow HTTP traffic. We can click the add firewall rule here, then name the rule as HTTP traffic, and it doesn't accept spaces. I will add a hyphen here, and it doesn't allow uppercase letters as well. I will change to HTTP in lowercase. The network for this rule is the custom mode VPC rule, and I will accept most of the defaults. One of them is the direction of traffic is ingress, meaning the HTTP requests are coming from the internet with destination of the web servers running in virtual machines in our network. The action for this rule is to allow any HTTP ingress traffic, and the targets for this rule, I can select different options here. There is one option to all instances in the network, meaning any virtual machine can be reached by those HTTP requests. There is one option to specify target tags and another one for specified service account. I will select all instances in the network, and the source filter will be IPv4 ranges, and the range I will add here is 0.0.0.0/0. This IPv4 range means every address, every IPv4 address that exists on the internet is allowed, should be allowed by this rule. And I will, from the protocols and ports, I will leave specified protocols and ports selected. I will check the TCP option here and enter the port 80 for HTTP traffic. Please remember, for production, please use HTTPS, which is port 443. I will click Create to create this firewall rule, and then I will hit refresh on the virtual machines to see that they can connect to the web server now that there is a firewall rule allowing HTTP traffic into the network. So far, we have created one web server in this region and zone and subnet, one web server in this region, zone, and subnet, and one web server in this region, zone, and subnet. To demonstrate that subnets can span across availability zones, this virtual machine is inside subnet 3, but it exists in the availability zone US East 1B. When this virtual machine is created, there will exist 2 virtual machines in subnet 3, but each of these virtual machines exists physically in a different data center. One in the availability zone US East 1B, another one in the US East 1C. Let's create the VM number 4. The VM4 exists in region US East 1, availability zone US East 1B. Let's do the following. Let's leave the region as it is and see what happens. I will change the boot disk as I did for the other virtual machines, choosing the custom Apache Web Server disk or image. And now when I delete the network interface and try to add a network interface inside region US East 1, what will happen? Custom mode VPC, subnetwork, no subnetworks in this region. This means that in the machine configuration, I am trying to create a virtual machine in the region US Central 1 in any of the availability zones existing in that region. But when I try to create a network interface, I am trying to select from the existing subnetworks from the custom mode VPC, and I haven't created any subnet on that specific region. So I will change now the region to US East 1 and the availability zone US East 1C. So this is the location the virtual machine will physically exist. Now I can create a network interface connecting this virtual machine with the subnet number 3. I will accept the other parameters and click Done, and then click Create. Now the virtual machine 4 is ready. I will copy its external IP address and test if I can reach the web server in that virtual machine. And here is the hello world. If I go back to the VPC firewall rules and check the HTTP traffic, I will click Edit this rule, and I will change the targets for the allow HTTP traffic from all instances in the network to specified target tags. And I will enter the target tags web server, and I will click Save. Now I will go to the VM instance 4 and I will click Edit, and I will enter a network tag as web server for this virtual machine and click Save. So I changed the firewall rule. Instead of allowing the protocol to all internal virtual machines, I changed it to allow for specific target tags. Will allow the HTTP protocol to enter only the virtual machines that have the web server tag. As I created the web server tag in the VM number 4, only the VM number 4 should keep working after changing the firewall rule. The other 3 virtual machines are trying to reach, or the requests for those virtual machines are trying to reach the virtual machines, but no responses is being received. But the requests sent to VM4, they are replied almost instantaneously. So now if I go to the different virtual machines and add tags to them, enter the web server tag, for the VM1, then for the VM2, and then for the VM number 3. Well, before I change the VM number 3, I will refresh. VM number 1 is already accessing the web server, VM number 2 as well. But VM number 3 is still trying to access without success. After I enter the network tag here and click Save, that will change for VM number 3 as well. There it goes. In this lab, I demonstrated how to create virtual machines in different regions, availability zones, and subnets. And I demonstrated that subnets can span across availability zones by creating one virtual machine in one availability zone and another virtual machine in a different availability zone, but the two virtual machines belong to the same subnet. I will now demonstrate how you can delete a subnet and how you can delete a complete VPC. I will go back to the VPC networks. Then I will click the name of the VPC, custom mode VPC. And here under subnets, let's first try to delete a subnet without deleting the virtual machine. I click the subnet name and I can click the delete icon here on the right to delete that subnet, reminding that there is an existing virtual machine in that subnet. Or better, there are two virtual machines in subnet number 3, and here is the error. Let's close this error. Let's go to the virtual machines page. And for the subnet 3, we will delete the VM3 and the VM4. Now the virtual machines are deleted. Let's try to delete the subnet number 3. Now the subnet 3 doesn't exist anymore. This is how you can delete a subnet you have no use for it anymore. I will go back to the VM instances page, and since I will demonstrate how to delete a complete VPC, I need to delete these virtual machines. And if there were any other services being used inside the subnets on this VPC, I would have to remove all the services as well. See the documentation to verify the specific services that must be deleted before you can delete the VPC. Now that the virtual machines are deleted, I will delete the VPC. To delete the VPC, you click its name, and then you click Delete VPC Network. You need to type in or paste the name of the VPC on this field and then click delete to confirm you want to delete the VPC. Now the custom mode VPC is deleted. In this lab, I demonstrated how to create virtual machines in different regions, availability zones, and subnets. And I also demonstrated that subnets can span across availability zones. I demonstrated the whole cleanup, how to delete a subnet, and how to delete a complete virtual private cloud network. Thank you for watching and see you in the next lab.
Welcome back. So I hope you guys had fun watching Leo do some networking, setting up the VPC, putting some things in the VPC. I know I did. So we're at the end of today, but don't worry. We still have Thursday, Friday this week, and we also have all of next week. Leo, you want to share about some of the next labs you have are going to be about?
Sure. In this lab, I used a custom image. If you got curious about how to create a custom image, we have a lab exactly showing how you can create a boot disk for a virtual machine containing exactly the applications you need on that virtual machine and more. We will use the custom image to create virtual machines, to create instances, templates, so we can create auto-scaling groups with a different number of virtual machines.
Oh, that's fun. And if any of you remember what it used to be for me in the old days to image all these virtual machines and how much manual intervention it took, this is nothing like this. It's really cool. So I hope you all had a great time. I really enjoyed spending time with you. I see we have people from all over the world, and that just makes me happy. So welcome to everyone, wherever you're at. If you had a good time, maybe give this a like. Tell a friend, because we really want to do what we can to help as many people as we can. And that's why we do these free boot camps. You know, we've got them for almost any program you can think of, but today's is about the Google Professional Cloud Architect. So not used to getting out a little early. We finished a few minutes early. I know we held you a little late on Mondays. So welcome. Enjoy the night. Have some fun. Be proud of yourselves. You guys have put up with a lot of deep content now. And it's not always the easiest thing to learn new things. So, you know, be proud of yourselves. You're working hard, and this is great. So I'll see you all tomorrow. Give me a hashtag Google Professional Cloud Architect. And I hope to see so many of you in the webinar on how to become an architect, which will be at 11 a.m. It'll be on Zoom. We'll go over how to become an architect. We'll talk about what we do. We'll talk about the exact skills you need and what you could do to get hired. And it's all free. That'll be in the description of this video if you're watching after the fact, as well as the chat box. Take care, everyone, and I look forward to seeing you tomorrow.